Hello everyone, welcome to Simplilearn's YouTube channel. In this session, we will be learning about Advanced Java Developer full course. But before we begin, make sure that you have subscribed to our YouTube channel and don't forget to hit that bell icon to never miss an update from Simplilearn. Now, without further ado, let's get started with our agenda for today's discussion. So at first, we'll begin with Introduction to Java Enterprise Edition. Followed by that, we will understand the fundamentals of exceptions and how to handle them. Next, we will learn about the Java collections. Followed by that, we will enter into Java Servlet tutorial. Next, we will understand the fundamentals of XAMPP and how to install it on our Windows system. Followed by that, we will learn Lambda expressions and learn more about them using some real-time examples. Next, we will learn about enumeration in Java. Followed by that, we will learn annotations in Java, serialization in Java. Next, we will get into multiprocessing in Java, and we will learn about it by implementing some practical programs based on multi-threading in Java. Next, we will learn about synchronization in Java and then the autoboxing in Java. Followed by that, we will learn input-output streams in Java, Java database connections, generics in Java, string handling in Java, java.lang library and java.util library. Followed by that, we will learn networking in Java. In the next segment, we will learn about images in Java, concurrency utilities, regular expressions in Java, non-blocking input-output in Java, Java Beans, Java API. Then we will learn the most important framework in Java, that is the Spring framework in Java. Next, we will enter the Spring model view control. Then we will understand Spring and RESTful application programming interface. Followed by that, to make things more interesting, we will go through a Spring Boot project. Then we will learn some testing fundamentals using JUnit testing tutorial. And finally, we will go through some most updated Java project ideas. Then to help you crack your Java interviews like a pro, we will go through some Java interview questions. I hope I made myself clear with the agenda. Now, let's quickly begin with our first topic, that is, what exactly is Java Enterprise Edition? The Java EE stands for Java Enterprise Edition, which was earlier known as J2EE and is currently known as Jarkataka EE. The Java Enterprise Edition provides a platform for developers with enterprise features such as distributed computing and web services. Now let's move further and understand why exactly we needed Java Enterprise Edition. We needed Java Enterprise Edition for 4 major reasons: to have powerful API support, to reduce development time, to reduce application complexity, and finally to improve the application performance. So followed by the need for Java Enterprise Edition, we will move ahead and understand the Java Enterprise specifications. So in the Java Enterprise specifications, we are going to discuss the 4 major specifications used by enterprise developers. So the first one being the enterprise specification, followed by that we have a web specification, then we have web server specification, and finally some other miscellaneous specifications. We shall discuss each one of them in detail. Firstly, we will move ahead with enterprise specification. So in enterprise specification, we have the first one to discuss, that is the context dependency injection. The context dependency injection provides a container to inject dependencies as in Swing. Next we have Java Enterprise Java Bean. The Enterprise Java Bean is a set of lightweight APIs that an object container possesses in order to provide transactions, remote procedure calls, and concurrency control. Followed by Java Bean, we have Java Persistent APIs. So the Java Persistent API are the specifications of object relational mapping between relational database tables and Java classes. Next, we have the Java Transaction API. It consists of Java interfaces and annotations to establish interaction between Java transaction support offered by Java Enterprise Edition. The APIs in the abstract from low-level detail to the interfaces are also considered as low-level. Followed by Java Transaction API, we have the Java Servlet. The Java Servlet specifications define how you can manage HTTP requests either in a synchronous or asynchronous way. So followed by Java Transaction API, which is one of the enterprise specifications, we will move ahead into the Java Web specifications. So the first one in the Java Web specification is the Java Servlet. So this specification defines how you can manage the HTTP request either in a synchronous or asynchronous way. It is low level and other specifications completely depend on it. So followed by Java Servlet, we have the Java WebSocket. So the Java WebSocket is a computer communication protocol, and this API provides a set of APIs to facilitate WebSocket connections. Followed by WebSocket, we have the Java Server Faces. So the Java Server Faces is a service which helps in building graphical user interface out of the components. So followed by Java Server Faces, we have the Unified Expression Language. The Unified Expression Language is a simple language which was designed to facilitate web application developers. So followed by the web specification, now we will enter the web service specification, out of which we have the first one, which is the RESTful Web Service. So the Java RESTful API Web Service provides services having representational state transfer schema. Next, we have the JSON processing. Java API for JSON processing is a set of specifications to manage the information provided in a JSON format. Followed by JSON processing, we have JSON binding. So the Java API for JSON binding is a set of specifications that provide for binding or parsing a JSON file into Java classes. Next, we have the XML binding. So XML binding simply allows for binding of XML into Java objects. For example, SOAP is an XML-based protocol to access web services over HTTP. This API allows you to create SOAP web services. So followed by the web service specifications of Java Enterprise Edition, we finally enter into the other miscellaneous specifications of Java Enterprise Edition. So out of that, the first one is the validation. So the validation package consists of various interfaces and annotations for declarative validation support offered by Bean Validation API in Java. Followed by validation, we have the batch applications. So the batch applications provide the means to run long-running background tasks which involve large volume of data and which need to be periodically executed. Followed by batch applications, we have Java Enterprise Connector Architecture. So the Java Enterprise Edition connector is a Java-based technological solution for connecting Java servers to enterprise information system. So with this, we will enter into our next step where we will learn the system requirements to install Java Enterprise Edition. So the basic requirements to install Java Enterprise Edition into your local system are: you should be having the Java virtual machine from the standard 6th edition or more. Followed by that, your local system should be having at least 1 GB of RAM capacity. Next, your system should be having at least 250 GB ROM space available. And finally, you should be having the Java Development Kit installed into your local system. Now next, we will understand how to install Java Enterprise Edition into your local system. So in short, these are the steps you need to follow to install Java Enterprise Edition into your local system. First, you need to browse into the Oracle official Java site, then go to Java Standard Edition Development Kit. Followed by that, accept the license terms, download the JDK file, run the JDK file as an administrator in your local system, then set up the Java environment. I know this looks a little bit complex, but don't worry, I will drop a link in the description box below which will explain you in a much detailed way how to install Java into your local system. Please check that to have a better understanding of how to install and set up Java in your local system. So followed by this, we will learn the differences between the Java Standard Edition and Java Enterprise Edition. So the first difference between the Standard Edition and the Enterprise Edition is the Standard Edition provides basic functionalities like defining classes and objects, whereas Java Enterprise Edition mainly focuses on high-end and corporate type of Java applications. The second difference between the both is Java Standard Edition comes with only the standard specifications which will be used by a beginner. And similarly, on the other hand, Java Enterprise Edition comes with some advanced specifications which support web applications and servlets. The third difference between the both is the Java Standard Edition comes with features like class, libraries, and deployment environments, whereas the Java Enterprise Edition has structured application with clients, business, and enterprise layers. The fourth difference between the both is the Java Standard Edition is used for desktop and mobile application developments, whereas on the other hand, the Java Enterprise Edition is used mainly for development of web applications. The fifth difference between the both is the Java Standard Edition is preferred and used by beginners. And on the other hand, the Java Enterprise Edition is preferred and used by experts in Java field. The sixth difference between the both is the Java Standard Edition does not have authentication, whereas on the other hand, there are strict rules and regulations to be followed when using Java Enterprise Edition related to authentication. Now, let us begin with what is an exception. So, an exception is defined as an event that arises due to an unexpected input or logical failure in the program. This may not be considered merely as an error, but it surely does impact the normal functioning of the program segment. Now, these types of exceptions are resolved by the most efficient mechanism called exception handling. Exception handling is not any rocket science, but a simple mechanism that drives the compiler to the next statement by making the compiler understand that the input obtained or the malfunction that arises is just an unexpected or an unnecessary event which can be ignored by sending the user with a relevant message about the exception arose. For a better understanding, let us go through a small example. So as you can see on our screen, we have typed in a program. So according to this program, we are going to access a file called data.txt from the C drive. So this particular data.txt is not really existing in the C drive. So when we run this program, we will face an exception that says file is not found. So let's try to run this program and see. So as expected. So when we run this program, we get that this particular file, what you're looking for, which is data.txt, is not found. Or in other words, it is not present in the specified location. So this is how the exceptions work in Java. Now followed by this, we will move ahead into our next topic where we will understand the meaning of an error. So what exactly is an error? So here, we are trying to learn about the error just to eliminate the ambiguity between an exception and an error. Also further, we will discuss the major differences between them. But now, let us go through the term error first. Unlike an exception, an error poses a serious potential threat to the program, or sometimes it is even capable enough to collapse an entire software. So basically, an error is occurred due to syntax error or some logical error while coding. So we have a sound understanding of an exception and an error. Now let us move further and learn the differences between the both. Error versus exception. So some of the major differences between an error and an exception are: an error is classified under unchecked type, whereas on the other hand, an exception is classified under both checked and unchecked. The next difference is, if a program encounters an error, then it turns out to be completely irrecoverable until the error is resolved. Whereas in the case of an exception, if the program encounters an exception, then the program is easily recoverable. Followed by that, the third difference is, an error belongs to the package called java.lang.error. On the other hand, an exception belongs to the class java.lang.exception. The fourth difference says that an error can be encountered only during the program's runtime, whereas on the other hand, an exception can be expected both during the runtime as well as the compile time. Finally, we will mention an example for both an error and an exception. We can consider the input and output error as an example for error, and on the other hand, we can consider divide by zero exception as an example for exception. So with the differences discussed, we will now move ahead and have a look at the exception hierarchy in Java. The hierarchy of errors and exceptions is really simple. There is one root class called the throwable. Now, the throwable class is basically inherited from object which comes from the superior root called java.lang. Now, the throwable class is inherited by two child classes which are none other than the error and an exception. Further, an error is inherited by different types of errors, for example, JVM or Java Virtual Machine error, memory error, and also in some cases, some of the errors are caused by the incompatibility of the IDE or the framework which you are using. Next up is the exception. Now the exception is inherited by few more exceptions which are mentioned as below. The exceptions can be input-output exception, SQL exception, class not found exception, runtime exception, and many more. Further, the runtime exception is inherited by some more, which are the arithmetic exception, number format exception, etc. Now that we have a good understanding of the exception hierarchy, let us move ahead and check the differences between checked and unchecked exceptions. So the first one, which is the checked exceptions. These are really simple exceptions and can be defined as follows. An exception that pops up during the compile time is called as the checked exception. It is not serious and is completely ignorable. Followed by the checked exceptions, we have the unchecked exceptions. On the other hand, the unchecked exceptions are defined as an exception that pops up during the runtime is called as the unchecked exception. It is considered as serious and is caused by logical errors. So to understand checked exceptions in a much better way, we shall go through an example. So this particular example is based on checked exceptions. So basically, we have a text document called data.txt in the location documents, username, users, C drive. So this particular data file has 5 lines. So we are going to access the starting 3 lines of this particular file, and basically when we try to run this program, we will face some of the major exceptions, which are unhandled exception type input output, and again the same exception, and here file not found exception. So these exceptions are errors. So to understand checked exceptions in a much better way, we shall go through an example. So this particular code segment here is trying to read a document from C drive, which is data.txt. So this particular data.txt has 5 lines of text. So what we are going to do here is try to type in a for loop and try to read the first 3 lines of this particular document. So basically when we run this program, we will face some of the exceptions called file not found exception, input output exception, and another input output exception. So we can resolve this particular program with small modifications to the program, and then if we run this program, then we can find our lines. So the lines in the data.txt file were, hello, welcome to Simplilearn. We are an e-learning company. Our certification is recognized by major MNCs. Enroll and upskill. So this particular example was for checked exceptions. Now, we will also go through an example for unchecked exceptions to learn it in a much better way. So this particular example is based on unchecked exceptions. This particular program is really simple. We have an integer type array, and inside that we have 10 elements, which are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So what we are going to do is we are going to access the 11th element of the array, which is not really present. So this should throw an exception. So array index out of bound exception is one of the examples for unchecked exceptions. So with this, we will move ahead into our next topic. Now we know what exactly are checked and unchecked exceptions. Moving further, we will slowly dive into the process of exception handling. In the process of exception handling, we have 5 major keywords. So we will learn each one of them as follows. So the first one is try keyword. The try keyword is used to specify the exception block. In a program, when you specifically type the exception that you might expect to face in your program, then you describe it using the keyword try. Followed by that, the solution for that exception will be defined in the catch block. So the catch block is used to specify the solution. Finally, the finally is a keyword which has the executable code which is completely mandatory for a program to execute. Followed by finally, we have the throw keyword. The throw keyword basically throws the exception when it is found during the runtime. Followed by that, we have the throws. The throws keyword is used to declare the exception. So basically, this is where you declare the kind of exception you are going to expect in your program. Sometimes you might try to type in your user-defined exception, or sometimes you might type in the exception that is default in its way. Or in other words, it might be system-defined. Now that we have a good understanding of the implementation of the exception handling in Java, let us move further and solve some of the most frequently faced exceptions in Java. So with this, we enter into our 7th topic, which is common exceptions faced in Java. So the first one is the array index out of bound. So if you try to store a value in an array or try to access an element in an array which has an address exceeding the array's maximum location value, then this particular exception is thrown. So to understand this particular exception, let us go through a practical example. So as you can see, on our screen we have an array of integer data type. So we are going to store the values 10, 20, 30, 40 and 50 in 5 different locations of the array, which is 0, 1, 2, 3 and 4. Now we are going to provide the address of the required element. So during that process, we are going to specify one location which is more than the maximum location of the array. So here the maximum location of the array is 4, and if we try to provide the location 5, then this program should throw us an exception. So let's try to run this program and see the output. So as you can see, we have our array here. Now the program is requesting us to provide the address of the element required. So what if we provide 5? So now it should throw an exception. So this exception is the array index out of bound exception. Now let us try to run this program again and specify the proper address. So for this time, let's provide 4 and see if we get the output. So as you can see, at the address location, we have the element 50 as we have defined here. Now our program is running perfectly alright. Now let's move ahead into the next type of exception, which is none other than our null pointer exception. If you try to perform an operation on a null value, this particular exception is thrown. So might be a little ambiguous. To understand this particular exception in a perfect way, let us go through a practical example. So here on your screen, you can see that we have a program, and inside the program we have a string called str which stores a text called Simplilearn. Followed by that, we have another string type which stores a null value, which is abc. As you can see, abc is equals to null. Now here we are going to access the value of abc. So here the string abc has a null value and we are trying to access it. So this particular code segment should throw an exception called null pointer exception. Now let's try to execute this code. As you can see, it has thrown an exception called the null pointer exception. So whenever in Java, if you try to access the null values, then the null pointer exception is thrown. Followed by this, we have the next type of the common exception, which is the number format. If you try to store a value with wrong formatting, then this particular exception is thrown. Now, to understand this in a much better way, let us try to execute a sample program. So here on the screen we have a sample program where we are trying to cast a string into integer. So this kind of operation should throw an exception. So as you can see, the program has been successfully compiled and we have our exception here which says number format exception. Followed by this, we have another most commonly faced exception, which is the arithmetic expression. If you try to divide a number by 0, this particular exception is thrown. Now let us go through a practical example. Now you can see we have a sample program on our screen where we have two particular numbers, n1 is equals to 0 and n2 is equals to 100. So here what we are trying to do is we are going to divide the number 100 by 0, which is practically not possible. So when we try to execute this particular program, then we should be getting an exception that says you cannot divide a number by 0. So there you have your personalized message which says the divider cannot be 0. Try a different number. So this is how the automatic exceptions work. So with this we have come to our last topic, which is the best practices to be followed while working with exceptions in Java. So the first one is use exceptions conservatively. So exceptions have proven that they can be costly if used recklessly or unnecessarily. So it's better we use Boolean values to indicate successful implementation of smaller operations. For example, if you specify a particular operation and it successfully gets executed, then you can just notify the user by specifying a Boolean value which can be 1, or in the case of failure, you can just specify the number 0. Next after that, we have the customized exceptions. It is a very good practice of customizing your exceptions in the design time rather than planning them on the go. So in other words, we can consider this as if you're planning to design a software, then in that particular stage itself, you must also evaluate the kind of exceptions you might face on the process of designing. So tomorrow if you completely design a software and suddenly an exception is popped in your head, then designing or including that particular exception in your finished software might be difficult. So it's better you start planning your exceptions. Followed by that, we have exception logging. Keep track of the exceptions, and this process comes handy as the user understands why exactly a particular exception has popped up. Followed by that, we have early throw and early fail. An exception should be thrown as early as possible and should be resolved in the same pace. And then we have the closing resources. Since exceptions halt the complete program, we must make sure that the system resources are shut so as to save the resources. What exactly is a Java collection? A Java collection can be generally defined as a collective unit of objects in the form of a group. For example, a group of numbers of integer data type, etc. Moving forward, we enter into our next topic where we face the Java Collections framework. This will help us understand Java collections in a little more detailed way. A Java collection framework represents a unified architecture for storing and manipulating a group of objects. Its architecture includes the following: an interface, a class, and the Java Collections API. To understand these in a much better way, we shall now go through the Java Collections hierarchy. The utility package java.util contains all the classes and interfaces that are required by a collection framework. The collection framework contains an interface named as an iterable interface, which provides the iterator to iterate through all the collections. This interface can be extended by the main collection interface, which acts as the root for the collection framework. All the collections extend this collection interface, thereby extending the properties of the iterator and the methods of this interface. The following figure illustrates the hierarchy of collection framework. Out of the complexities, we have the interface and the classes as the major part of the collections. Now let us understand each one of them at one step at a time. As you can see on the screen, we have the iterable class, which is implemented by the collection class, and this particular collection class is further implemented by list, queue and set. And moving ahead, we have the following classes which have implemented the list, queue and set classes. In the list, we have array list, linked list, vector, stack, and on the other hand, on the queue, we have priority queue, dequeue, and array dequeue. And finally, on the set, we have the hash set, linked hash set, sorted set, tree set, etc. Now moving further, we will enter our first Java collection, which is none other than the interface. So the first one is an interface. An interface can have methods and variables, but the methods declared in an interface are by default abstract. That is, only the method signature is available, not the body. Interfaces specify what a class must do and not how it must do. It is a blueprint of a class. Now, a Java collection is a foundation to the Java collections framework. Note that all the collection interfaces are generic. For example, public interface collection is the syntax for the generics, and when we declare the collection, we should use it to specify the type of object which it can contain. It helps in reducing runtime errors by type checking the objects at compile time. To keep the number of core collections interface manageable, the Java platform doesn't provide separate interfaces for each variant of each collection type. If an unsupported operation is invoked, a collection implementation throws an unsupported operation exception. Now, under the collection interface, we have many interfaces that we should use for data manipulation. A few of the major ones are set interface, list interface, dequeue interface, queue interface, map interface, sorted set interface, sorted map interface. Don't worry, those are a lot of interfaces, but we will discuss each one of them in a detailed way along with a practical example for a better understanding. So the first one in the docket is the set interface. A set is a collection that cannot contain any duplicate elements. This interface model is the mathematical set abstraction and is used to represent sets such as a deck of cards. The Java platform contains three general-purpose set implementations: the hash set, tree set, and linked hash set. The set interface does not allow random access to an element in the collection. You can use an iterator for each loop to traverse elements of a set. Now, for a better understanding, let us go through a practical example. I have prepared a code document for all the programs that I am going to explain to just save time. You can always have access to it. All you need to do is just ask for it in the comment section below. So you can see on my screen we have an example for set interface. In this particular example, we are going to store the elements 21, 23, 43, 53, 22, and 65. So let's try to execute this program and see the output. So you can see the elements stored in the set interface are 65, 21, 53, 22, and 23, 43. So the sorted set is here, which is the 21, 22, 23, 43, 53, and 65. And the first element being 21 and the last element being 65. So this is how the set interface practically works. Now let's move ahead into our next type of interface, which is none other than the list interface. So what exactly is a list interface? The list interface is an ordered collection that can contain duplicate elements. You can access any element from its index. The list is more likely an array with dynamic length. The list is one of the most used collection types. An array list and linked list are the implementation classes of the list interface. The list interface provides useful methods to add an element at a specific index, to remove and replace elements based on the index, and to get a sublist using the index. For a better understanding, let's check out an example. So this particular program is based on list interface. So we are going to add in three names, which are David, John, and Stacy, into our list. And also we have a fourth addition, which is Stacy again. Just to check if the statement is true, it says list interface also allows duplicate elements unlike the set interface. So let's try to run this program and see the output. So you can see the program got successfully executed and the names David, John and Stacy are added into the list. Now let's come back to our program and remove this comment and try to run again and check if the fourth element, which is the duplicate of the third, Stacy, will be added into the list or not. So as you can see, the program got successfully executed and the fourth element, which is Stacy, the duplication of the first one, got successfully inserted into the list. So this is how the list interface works. Now let's move ahead into our next type of interface, which is the queue interface. So what exactly is a queue interface? Queue is a collection used to hold multiple elements prior to processing. Besides basic collection operations, a queue provides additional insertion, extraction, and inspection operations. Queues typically, but do not necessarily, order elements in the FIFO or first in, first out manner. Among the exceptions are priority queues, which order elements according to a supplied comparator, or the elements in natural ordering. Whatever the ordering used, the head of the queue is the element that would be removed by a call to remove or pull. In a first in, first out queue, all new elements are inserted at the tail of the queue. Now for a better understanding, let's go through a practical example. So as you can see, the program on my screen is an example for queue interface. So in this particular queue, we are going to store the names of fruits: apple, mango, grapes, and banana, and apple being the head of the queue and banana being the tail of the queue. Now let's try to execute this program and see the output. So we are also going to count the size of the queue, which is 4 basically in the first. After that we are going to remove the element grapes from the queue. So the command is queue.remove the element name. So after that the grapes element has been removed from our queue. We have the latest size of the queue as 3. Now after that we are also going to check if the element apple is included in the queue or not. So for that statement, yes, the element apple is included in the queue and the result is true. So this is how the queues work, and let's move further. And in the next phase we have the dequeue interface. So what exactly is a dequeue interface? So a linear collection that supports element insertion and removal at both the ends is called as a dequeue interface. The name dequeue is short for double-ended queue and is usually pronounced as DEQ. Most dequeue implementations place no fixed limits on the number of elements they may contain, but this interface supports capacity-restricted dequeues as well as those with no fixed size limit. This interface defines methods to access the elements at both the ends of the dequeue. Methods are provided to insert, remove, and examine the element. For a better understanding, let's check out an example. So you can see on my screen we have a program for dequeue interface. So here we are going to add in some elements into our dequeue and then also try to remove the first element and print the updated dequeue. Now let's try to execute this program and see the output. So as you can see, the program got successfully executed and the elements which we tried to push into the dequeue were 52, 10 and 21. 52 is being the first element and the 21 is being the last element. So we tried to remove the first element, which is the 52. So after that the updated dequeue is having 2 elements which are 10 and 21. So this is how the queues work. Now let's move ahead and learn our next type of interface, which is the map interface. So what exactly is a map interface? A Java map is an object that maps keys along with its values. A map cannot contain duplicate keys. Each key can map to at most one value. The Java platform contains 3 general purpose map implementations, which are the hash map, tree map, and linked hash map. The basic operations of a map are contains key, contains value, size, and is empty. For a better understanding, let us check out an example. So this particular example on my screen is an example for map interface. Here we are going to add 3 elements and map them as 1 as cricket, 2 as hockey, and 3 as archery. Now let us execute this program and see the output. So you can see the program got successfully executed and the elements are mapped with their keys, and the element cricket is mapped with the key 1, and similarly hockey with key 2 and archery with the key 3. So this is how the map interfaces work. Now let's move further into our next type of interface, which is the sorted set interface. So what exactly is a sorted set interface? So a sorted set is a set that maintains its elements in ascending order. Several additional operations are provided to take advantage of the ordering. Sorted sets are usually used for naturally ordered sets such as word lists and membership roles. For a better understanding, let's check out an example based on sorted set interface. So you can see the program on my screen is an example for sorted set interface. So here we are going to add in Bob, Sean, and Jennifer into our set, and we are going to print the same. Let's try to execute this program and see the output. So you can see the program got successfully executed and we have our elements printed in the sorted set, and you can see the names are being arranged in the form of ascending order according to the alphabets which have started in the first position. So this is exactly how the sorted set interface works. So the last one in the interfaces is the sorted map interface, a map that maintains its mapping in an ascending key order. This is the map analog of sorted set. The sorted maps are used for naturally ordered collections of key value pairs such as dictionaries and telephone directories. Now for a better understanding, let's check out an example based on map interface or sorted map interface. So you can see the program on my screen is an example for sorted map interface. So here we are going to add in the elements John, Molly, Aaron, and Daisy into the map interface. Now along with the names, we also have their aggregates, which is 76.5 for John, 87.3 for Molly, and 78.2 for Aaron. And for Daisy we have 73.4. Now finally we are going to fetch the data of Molly, which is the aggregate of Molly. Now let's try to execute this program and see the output. So you can see the program got successfully executed and Molly's aggregate is 87.3. So this is how the map interfaces work. Now let's move ahead into our next topic, which is the Java collection classes. So now that we have finished the Java collection interfaces, let us have a quick understanding of Java interface methods. So the first method is the add method. The add method is used to add an object to the collection, and next is the isEmpty method. This method returns the true if the collection contains no elements. Followed by that we have the clear method, and this method is used to remove all the elements from the collection. Followed by that we have the remove method. This method is used to remove the given object from the collection. If there are duplicate values, then this method removes the first occurrence of the object. Next to the remove method we have the size method. So the size method is used to return the number of elements in the collection. So after the size method we have the stream method. The stream method is used to return a sequential stream with this collection as its source. So the next method we have is the toArray method. So the toArray method is used to return an array containing all the elements in this collection. Followed by that we have the hashcode method. This method is used to return the hashcode value for this collection. Next, the equals method. The equals method is used to compare the specified object with the remaining elements in the collection. Followed by that we have the iterator method. So the iterator method is used as an iterator over the elements of the particular collection. And finally we have the contains method. So the contains method returns true if a specified element is existing in the collection and false if it is not present. So with this, we finished the collection interface and collection interface methods. Now we will move ahead into our next topic, which is none other than the Java collection classes. So what exactly is a class? A class is a user-defined blueprint or prototype from which objects are created. It represents a set of properties or methods that are common to all the objects of one type. Now we'll start up with the first one, which is the hash set class. So the Java hash set is the basic implementation of the set interface that is backed up by the hash map. It makes no guarantee for the iteration order of the set and permits null elements as well. So this class offers constant time performance for basic operations such as add, remove, contains, and size. Assuming the hash function disperses the elements properly among the buckets, we can set the initial capacity and load factor for this collection. The load factor is a measure of how full the hash map is allowed to get before its capacity is automatically increased. For a better understanding, let's go through an example. So on my screen you can see a program which is an example for hash set classes. So inside this we are going to store some names which are the names of the manufacturers of bikes along with null values. So we have added in two null values to just check if it allows two null values at once. So basically it only should allow one null value. So let's check out how does it perform. So you can see the program got successfully executed and the null value is stored only once, that too in the first location. So this is how the hash set classes work. Moving further, we will deal with the next type of class, which is the tree set class. So a tree set class is a navigable set implementation based on a tree map. The elements are ordered using their natural ordering or by a comparator provided at set creation time, depending on which constructor is being used. This implementation provides guaranteed logged time cost for the basic operations such as add, remove, and contains. Note that the ordering maintained by a set, whether or not an explicit comparator is provided, must be consistent with equals if it is to correctly implement the set interface. Now, to understand in a much better way, let us go through an example. Now we are going to add in some numbers into the tree set using the add method. Now let's execute this code and see the output. So you can see the numbers are added into the tree set and the numbers are ordered in ascending order, which is 0, 18, 88, 748, 983, 8476. Now let's move further into our next type of class, which is the array list class. So array list in Java is a resizable array that is an implementation of list interface that allows null elements. So in this class we have three types of arrays, which are one-dimensional arrays, two-dimensional arrays, and three-dimensional arrays. Now let's check out the one-dimensional array. So a one-dimensional array looks similar to this, where we have the array index and the element present in the array. So here our indexes are A0, 1, 2, 3, and 4, and the elements which are shown here. To understand one-dimensional arrays in a much better way, let's go through a sample program. So you can see the program written on my screen is an example for one-dimensional array, and we are going to store the elements 10, 20, and 30 into my array A. So you can see the program has been successfully executed and the elements have been added into my one-dimensional array. Moving further, we will discuss the two-dimensional arrays. The two-dimensional arrays are completely similar to one-dimensional array, but the only difference is the index numbers. Earlier we had index number, but now we have index numbers. Now using these index numbers, we can represent the elements in a matrix form. So to understand this in a much better way, let's go through a sample code. So you can see this particular program in my screen is an example for two-dimensional arrays. So here we are going to add in elements 1, 2, 3, and 4 in the matrix form, and we are going to use two for loops to print that. Now let's execute this program and see the output. So you can see we have the elements 1, 2, 3, and 4, and the elements are printed in the matrix form. at the array index location 0, 0 we have 1, 0, 1 we have 2, and 1, 0 we have 3, and 1, 1 we have 4. So this is how the two-dimensional arrays work. And finally, let's deal with the third type of array, which is the multi-dimensional or three-dimensional array. So you can see the three-dimensional array is completely similar or a little bit similar to the two-dimensional array, but the only difference is we have a third vector here. So next up we have the linked list. Linked list also come under Java collection classes. There are three types of linked list, which are single linked list, doubly linked list, and circular linked list. Now let's check out each one of those. So the first one is the singly linked list. So you can see in a singly linked list, each memory segment is divided into two parts. So the first half of the memory location is given for the element, and the second half of the memory location is dedicated for the address. So this particular address is used to point to the next element or the next memory allocation which stores the second element, similarly the third. So this is how the singly linked list works. So the last memory allocation is called as the tail, and the last address will not store nothing but null, which indicates the end of the singly linked list. Now to understand singly linked list in a much better way, let's try to execute a sample program. So you can see the program on my screen is an example for singly linked list. Now we are going to add in the elements 1, 2, 3, and 4 in the form of a singly linked list. Now let's try to execute this program and see the output. So you can see the program got successfully executed and the elements are 1, 2, 3, and 4. Now let's move further and try to learn the next type of linked list, which is the doubly linked list. So the doubly linked list is completely similar to that of the singly linked list, but the only difference is we have two address locations. So the first address location of the head stores null, and the last address location of the tail stores null, which indicate the start and end of the doubly linked list respectively. So here in the second memory location you have two addresses. So the first address points to the previous element and the next address points to the next element. So to understand doubly linked list in a much better way, let's try to execute a sample program. So as you can see, the program on my screen is an example for doubly linked list, and we have the node which has the data and previous address, next address. Now let's try to execute this program and see the output. And the elements that we are going to store in this particular doubly linked list are 1, 2, 3, 4, and 5. So as you can see, the program got successfully executed and the nodes are 1, 2, 3, and 4, and 5. So this is how the doubly linked list work. And now let's check out the third type of linked list, which is the circular linked list. So there are similarities between the previous linked list and the circular linked list. So the circular linked list makes it circular based on the last address location. So this particular address location points to the first element back again. So this is how it becomes a circular linked list. So to understand this in a much better way, let's check out an example for it. So you can see the program on my screen is an example for circular linked list. Now let's try to execute this and see the output. So you can see we have successfully included 1, 2, 3, 4, 5, 6, and 7, and 8 into our circular linked list, and they are printed on the screen. So this is how the circular linked list work. So moving further, we will try to understand the next type of classes in Java collections, which is the hash map class. So hash table is based on the implementation of map interface. This implementation provides all the optional map operations and permits null values and the null key. Hash map class is roughly equivalent to hash table, except that it is unsynchronized and permits null. This class makes no guarantee for the order of the map. Now for a better understanding, let's go through a sample program. So this particular program on my screen is an example for hash map class. So here we are trying to load the data, which is the name of the manufacturer and their bike. So let's execute this program and see the output. So you can see the program got successfully executed and we have the manufacturer and their made bikes. Now moving further, we will deal with the next type of class in Java collection, which is the tree map class. So the tree map is based on navigable map implementation. The map is sorted according to the natural ordering of its keys or by a comparator provided at map creation time depending on the constructor used. Now let's check out an example for better understanding. So you can see the program written on my screen is an example for tree map class. So we have the roll numbers and the names of students here. Now let's try to execute this program and see the output. So the program got successfully executed and the result has been printed on the output console. So we have the roll numbers of the students and their names: Amber, James, Violet and Reynolds, along with their respective IDs. So now with this we complete the Java collections classes. Now we move into our next topic, which is the collection API algorithms. So the first one is sorting. Sorting does the job of ascending and descending numbers based on the algorithm written by the user. For a simple example, we shall consider the bubble sort algorithm for this one. So you can see on my screen we have an example for bubble sort algorithm. So we have the elements 2, 89, 39, 48, 6, 28, 1, 2 and 33, which are ordered in an unorderly manner. Let's try to execute this program and order them. So you can see array before bubble sort is 289, 38, 48, similarly 33, and after the bubble sort we have the sorted array, which is 1, 2, 6, 28, 33, 39, 48 and 289. So this is how the bubble sort works. Now let's move further and understand the next type of API, which is the shuffling algorithm. So the shuffling algorithms are designed to destroy the current arrangements. They are employed on creating randomness in the list. So for a better understanding, let's check out an example. So you can see the program written on my screen is an example for shuffle algorithm. So we have an array which has the elements completely sorted in ascending order, which is 10 to 100. Now when we run the shuffle algorithm, these elements will be completely shuffled according to a random order. Now let's try to execute this program and see the output. So you can see the elements which were in an ascending order are now completely in this order. So this is how the shuffling algorithm works. Now let's move further and understand the next type of algorithm, which is the searching algorithm. Searching algorithm is employed to search an element in the list or array based on the type of searching mechanism used. Now for example, let's use the binary search. Now you can see a program on my screen which is an example for binary search. So we have the elements 1, 2, 3, 4 and 5 in our array. Now what we are going to do is search for the element or the key element 2 in our array using the binary search algorithm. Now let's execute this program and see the output. Now you can see the program got successfully executed and the output says the element which you are looking for is found in the index location 1. So this is how the binary search algorithm works. Now let's move further and understand the next type of algorithm, which is the composition algorithm. So the definition says the frequency and disjoint algorithms test some aspect of composition of one or more collections. So the frequency counts the number of times the specified element occurs in the specified collection. So the disjoint determines whether two collections are disjoint, that is whether they contain no element in common or not. Now to understand it in a much better way, let's go through an example. So you can see on my screen there is an example for composition. Now let's run this program and see the output. So you can see the program got successfully executed and the elements are completely disjoint. Now moving further, we will enter into our next topic, which is based on the benefits of Java collections. So there are various benefits of Java collections. Out of those, the major benefits are software or code reusability. So the Java collections enable code reusability to save time. Followed by that, the ease of designing APIs. So the next two ease of designing APIs, we have the simplicity in learning and using APIs, and finally increased speed in programming. So these were the major benefits of Java collections. What exactly is a servlet? Now imagine you're searching for some information on the internet. You open your local browser and start typing it. This question from you to the internet is called as request. So further, this request is sent to the cloud, or in technical terms, Your browser sends your request to the respective server responsible for storing for that particular information and helps you with it when requested. Now the server gets triggered with your request, and in return, it helps you back with the information you have requested for. This answer from the server is called the response. So this is how the request and response work in a server. For this process to happen so smoothly and effectively, we need a servlet. Digging a little deep into the server, we find the component responsible for such an effective job. It is called the servlet container that holds Java-based web application and a set of individual components called as servlets. Now we are close to our answer. So this particular Java-based component takes care of web request and response. To sum it up with the form of a definition, we can define it as follows. A servlet is a Java program that runs on the Java-enabled web server or application server. They are used to handle the request obtained from the web server, process the request, produce the response, and then send a response back to the web server. Now, hoping that it was a clear explanation, can we move ahead with the next topic? So the next topic we have is, so how does the servlet work in reality, or more practically or in depth, what's the life cycle of a servlet? So the life cycle of a servlet in real time has the following stages. These stages are the ones that a Java servlet actually follows in real life to get our work done. So the stages are init, service, and the CRUD operations, which are the get, post, put, delete, and finally destroy. Now let us understand each one of them in a bit more detail. The first one is the init process. The init method is called only once. It is called only when the servlet is created, and not for all the requests afterwards. So it is used for the one-time initializations, just as with the init method of applets. The servlet is normally created when a user first invokes a URL corresponding to the servlet, but you can also specify the servlet is loaded when the server first started. When a user invokes a servlet, a single instance of each servlet gets created, with each user request resulting in a new thread that is handed over to the doGet or doPost as appropriate. The init method simply creates or loads some data that will be used throughout the lifecycle of a servlet. Followed by the init method, we have the service method. So what is service method? Service method is the main method to perform the actual task. The servlet container, that is the web server, calls the service method to handle requests from the client or the browser and to write the formatted response back to the client. Each time the server receives a request from the servlet, the server spawns a new thread and calls service. The service method checks the HTTP service type and accordingly performs the CRUD operations, which are the get, post, put, delete, etc. and calls doGet, doPost, doPut, doDelete, etc. methods as appropriate. The service method is called by the container, and service method invokes doGet, doPost, doPut, and doDelete, etc. methods as appropriate. So you have nothing to do with service method, but you override either with doGet, doPost, and other types depending on what type of request you receive from the client. So this is how the init and service methods work. Now digging a little deeper, we have the doGet, doPost, doDelete, and doPut methods. So first we will discuss about doGet method. So what exactly does a doGet method do? A GET request results from a normal request from a URL or an HTML form that has no method specified, and it should be hardly by doGet method. Followed by doGet, we have doPost. A doPost request results from a HTML form that specifies list post as the method, and it should be handled by doPost method. Similar to doGet and doPost, the doPut and doDelete options are usually used to update and delete the data when asked by the client. So to sum up these doGet, doPost, doPut, doDelete, we can consider them as CRUD operations. So doGet basically gets the information what you're looking for. doPost method usually posts the information or provides you with the response from the server, and followed by that we have the doPut, which is usually used to update the data which is present on your server and finally delete, which is used to delete an existing data on your server. So these can be considered as CRUD operations. And finally, we arrive at the last method, which is the destroy method. The destroy method is called only once at the end of the life cycle of a servlet. This method gives your servlet a chance to close database connections, halt background threads, write cookie list or hit accounts to the disk, and performs other such cleanup activities. So with this, we finish up the life cycle of a servlet. Now we shall understand its architecture. Basically, the architecture of a servlet can be understood by reverse engineering the lifecycle of a servlet. So this is how the servlet execution takes place when a client or a browser makes a request to the web browser. So the servlet architecture includes the following. First one, servlet interface. To write a servlet, we need to implement the servlet interface. Servlet interface can be implemented directly or indirectly by extending generic servlet or HTTP servlet class. Followed by that, the next part is request handling methods. As we have discussed before, there are mainly three methods defined in servlet interface, which are init, service, and destroy. And inside service, we have do-put, do-post, do-get, and do-delete methods. The first time a servlet is invoked, the init method is called. It is called only once during the life cycle of a servlet. So we can put all your initialization code here. The service method is used for handling the client request. As the client request reaches the container, it creates a thread of servlet object, and request and response object are also created. These request and response objects are then passed as parameter to the service method, which then processes the client request. The service method in turn calls the do-get, do-post methods if the user has extended the class from HTTP servlet. And lastly, the creation of instances. This is based on the load of the servlet. So with this, we have finished the architecture of servlet. Moving further, we shall quickly discuss the features of servlets and then enter into the practical mode. So the following are the features of Java servlets. The first feature is Java servlets are portable in nature. As I have mentioned above, the servlets use Java as programming language. Since Java is a platform-independent programming language, the same holds true for servlets. For example, you can create a servlet on Windows operating system that uses Glassfish as a web server and then later run it on any operating system like Unix, Linux, and Apache Tomcat web server. This feature makes servlet portable, and this is the main advantage of servlet over CGI. We shall discuss all the differences of CGI versus servlet in the next section. For now, we will discuss the features. Followed by the first feature, we will now enter into the second feature, which says Java servlets are efficient and scalable. Once a servlet is deployed and loaded onto a web server, it can instantly start fulfilling the request of the clients. The web server invokes servlet using lightweight thread, so multiple client requests can be fulfilled by servlet at the same time using the multi-threading feature of Java. Compared to CGI, where the server has to initiate a new process for every client request, the servlet is truly efficient and scalable. The next and the final feature of Java servlets is they are robust and highly secure. By inheriting the top features of Java, such as garbage collector, exception handling, Java security manager, etc., the servlet is less prone to memory management issues and memory leaks. This makes the development of web applications in servlets secure and less error prone. So these were the important features of Java servlets. Now let us enter the practical mode. So we are in the practical mode right now. There were two parts in the practical mode. The first one was to set up the environment for Java servlets, and the second one was to execute a basic program. So this document has the following steps to follow. That is the prerequisites before executing a Java servlet program. So we have these prerequisites where we have to set up Java home and Java path. Followed by that, we need to set up the home and path for JRE, which is the Java runtime environment, and finally Catalina home and path. So Catalina home and path is nothing but the Tomcat server home and path. Now we will set up these things by using the environment variables. Now I'm using a Windows operating system, so I'll be using the control panel to enter the environment variables. There you go, you have edit environment variables. So inside that, just select environment variables, and inside this you can see that I have already set up the environment variables for Catalina home, Java home and JRE home. So now let us just select Java home and edit it so that we can see how did I set it. So you can see I have named the variable name as Java home, and inside the variable value I have a location. So this location is nothing but the Java JDK location in my local system. Now followed by that we have JRE home. So similar to Java home, we have set up the JRE home as variable name is equals to JRE home, and the variable value is the location of JRE folder in my local system. So I have my JRE folder in my local system at C drive program files Java JRE, and similarly the Catalina home, which is inside my program files Apache Software Foundation and Tomcat 8.5. So similarly we'll also check up the path variables. So inside system variables you can see the path, just edit it so then you can see the path variables set for Java, JRE and Tomcat. Now just select OK, OK, and finally another OK. Now your prerequisites have been set up. So this is how you set them. So in case if you have doubts about the Tomcat version to download, then I'll help you with that. Just open Google and type in Tomcat download. So now you have entered Apache Tomcat official site, and since I'm using a Windows operating system, I'll be selecting the 32-bit or 64-bit Windows Service Installer version, and after this gets downloaded, you need to set up the home and path variables for Catalina server. So once after the environment is set up, you need to follow 4 stages to create a servlet program, which are creating a dynamic web project, create a servlet, add servlet API jar file and run the servlet. So to create a dynamic web project, you need to select new, and inside that you have the option of other. Just select other, and inside that you'll be finding web. So select web, and inside that you need to select the dynamic web project and select next. So you just need to name to your dynamic web project. So I'll be naming as server, then select next, and inside that you have a source folder, and now you can select finish. Now there you go. Java Eclipse will ask you for opening this particular in Java EE perspective. Then just select open perspective. Now basically Java will set up everything you need here, and there you go. You can see server folder here which has already set up everything you need. Now what you need to do is set up a new servlet. So right click this and select new, and inside that you can see the option of servlet. Just select it. Now you can see a new dialog box, and here you need to set up the class name. For now let's just type in hello and go to next. Now again next, and in here you have a lot of options. So for now we are just executing a basic program, so let's just select do get method. Now let's just finish it, and there you go, your servlet has been ready. So this is the basic template created by Eclipse for you. Now next we need to add in the build path. So for that you need to right click the server and then select build path, and here configure build path. From here you can add the external libraries. Select the external libraries option, and you can see I have the Tomcat libraries here. Just select all and open. And that's how you add all the required libraries of Tomcat server. Now apply and close. Now the last step is to execute the project. Now just to save time, I have already typed in the program, which is over here. Now let's try to execute this. This program will just provide us a simple output, which is none other than Hello world. Now the server I have chosen is Tomcat server. Let's finish it. So there you go. The message has been displayed successfully. Hello, welcome to Simplilearn. Now we'll move ahead with our next topic. Now that we are done with the environment setup and the basic example, let us now discuss the advantages and disadvantages of using Java servlets. So first, we will discuss the advantages. The following are the advantages of using servlets in Java. Servlet is convenient in modifying regular HTML. We can write the servlet code into JSP. Servlets include the feature of multi-threading of Java. We can make use of exception handling of Java. Servlets have a separate layer for business logic in the application. And finally, it is easy for developers to show and process the information. So these were the advantages of using servlets in Java. Moving ahead, we will discuss the disadvantages of using servlets. So following are the disadvantages of using servlets in Java. Designing a servlet is considered as a little complicated. Servlets often slow down the application. Business logic of servlet is difficult to understand. We need a JRE, which is the Java Runtime Environment, on the server to run our servlets. And finally, the data connectivity is a little complicated. So these were the major disadvantages of using servlets in Java. Moving ahead, we will understand CGI. Why are we learning CGI? Because even CGI is similar to servlets, and it also does the web interactive job similar to servlets. So thought you should know about some basics of it. So let's understand its definition and architecture real quick. So the CGI, or Common Gateway Interface, is a standard for writing programs that can interact through a web server with a client running on web browser. These programs allow a web developer to deliver dynamic information, usually in the form of an HTML, via the browser. A CGI program can be written in any language including Java that can be executed by your web server. CGI programs are commonly used to add search engines, guestbook applications, database query engines, interactive user forums, and other interactive applications to websites. In very basic terms, a CGI program must interpret the information sent to it, process the information in the same way, and generate response that will be sent back to the client. Most of the input of CGI program is passed into through environment variables. So with this, we will move ahead into the architecture of Common Gateway Interface. So you can see the architecture of Common Gateway Interface is completely similar to servlet. Normally, the request is sent in the form of an HTTP request. So this particular HTTP request is divided amongst the CGI shells, and it will be processed by the CGI shells based on the program provided, and the response is sent to the user. Now moving ahead, we shall understand the differences between the Common Gateway Interfaces and the servlet. So the first difference is the Common Gateway Interface scripts are executable codes written in native operating system, while on the other hand, the servlets are written and run using the Java virtual machine. The next difference is the Common Gateway Interface performance is considered to be low compared to servlets. On the other hand, servlets are having high performance compared to CGIs. The third difference is, for a Common Gateway Interface, it is hard to switch between different platforms, that is the operating system platforms. When we come into servlets, the servlets are considered to be completely platform independent. Followed by that, the Common Gateway Interface scripts are directly executed. So on the other hand, servlets are translated into bytecode, because the servlets are executed using the Java virtual machine, and in Java virtual machine, whatever the code you transfer, it will be converted into bytecode first, then executed. And the last difference is the Common Gateway Interface is not portable, and on the other hand, we have the Java servlets to be completely portable. So these are the major differences between the Common Gateway Interface and Java servlets. Now let us understand the Java servlets requests and responses. So first we will deal with the request phase. In request we have various types. The first one is being the HTTP request. The HTTP object is used to represent the HTTP request to a browser that the user sends to the web application. Thus, anything the browser sends is accessible through the HTTP request. Followed by the HTTP request, we have the request parameter. The request parameters are the parameters that are sent from the web browser along with the request. The request parameters are typically sent as a part of the URL or as a part of the body of an HTTP request. Followed by the request parameter, we have the request header. The request headers are the name value pairs sent by the browser along with the HTTP request. The request headers contain the information about the web browser software being used, what type of files that the web browser can receive, etc. Followed by the request header, we have the input string. If the browser sends an HTTP post request, request parameters and other potential data is sent to the server in the HTTP request body, it doesn't have the request parameters that is sent in HTTP request body. It could be pretty much as the data like file or SOAP request. The next one is a request session. The session object can hold information about a given user between the requests. So if we have set an object into the session object during one request, it will be available for you to read during any subsequent request within the same session time scope. Followed by the request session, we have the servlet context. The servlet context contains the metadata related to the application. Followed by servlet context, we will enter the response phase. In the response phase, we will deal with the first one, which is the HTTP response. The HTTP response object is used to represent the HTTP response to your request. A web application sends back a response page to the user as a response to the HTTP request from the browser sent to your web application. Followed by the HTTP response, we have the write HTML. To initiate the process of sending the HTML back to the browser, you need to retrieve the print writer from the HTTP response object. This can be done using the write HTML. Followed by the write HTML, we have the response header. Similar to HTTP request, the HTTP response includes headers as well. These are responsible for all the data written in the response. Followed by response header, we have content type. The content type header is responsible to tell the browser about the type of content you are sending in the return. Followed by content type, we have the content length. The content length header is responsible for telling you about the number of bytes your servlet is sending you in return. Followed by content length, we have redirection. Redirecting will help you to redirect yourself to the different web page from the current one. So these were the HTTP requests and responses in Java servlets. Now we will enter the next part where we will deal with the session tracking and cookies. So first, we will understand session tracking. Session simply means a particular time of interval. Session tracking is a way to maintain state or data belonging to a user. It is also known as session management in servlets. HTTP protocol is stateless, so we need to maintain state using session tracking techniques. Each time the user requests to the server treats the request as a new request. So we need to maintain the state of a user to recognize a particular user. You can understand this in a better way by looking at the picture showed on the presentation. Each time you send a request, you will be receiving a response from the server, as well as this particular request will be recorded as a state in order to recognize you as a particular user. Now after session tracking, we will enter into cookies. Cookie is a small piece of information that is persisted between multiple client requests. A cookie has a name, a single value, and optional attributes such as comment, path and domain qualifiers, a maximum age, and a version number. By default, each request is considered as a new request. In cookie technique, we add a cookie with response from the servlet. So cookie is stored in cache of a browser. After that, if the request is sent by the user, the cookie is added with a request by default. Thus, we recognize the user as an old user. There are two types of cookies. They are non-persistent cookie and persistent cookie. Let's understand non-persistent cookie first. A non-persistent cookie is valid for a single session only. It is removed each time when the user closes the browser. Now, let us understand the persistent cookie. The persistent cookie is valid for multiple sessions. It is not removed each time when the user closes the browser. It is only removed when the user logs out or signs out from the browser. What exactly is XAMPP? Well,
XAMPP is a one-stop, open-source, cross-platform solution for multiple needs. In general, it is considered as a bundle of software utilities that include an Apache server, MySQL database, support for PHP, and support for Perl. This simple and lightweight solution works on Windows, Linux, and Mac, hence the cross-platform part. Now that we have a quick briefing about XAMPP, let us get started with the installation procedure. So installing XAMPP is really simple. All you need to do is just Google download XAMPP and you'll see the first link and just click onto it, which will redirect you into the Apache website. Here you can see multiple varieties of XAMPP. The first one is for Windows, second is for Linux, and the third one is for Mac. Now we will select the Windows version. So here we have the 7.2 version, 7.3 and 7.4. So I would suggest you to go with the latest version, that is the 7.4. You just need to click on the download button and there you go. You can see on the bottom left corner that your software is getting downloaded. Now this might take a while, so I have downloaded it on my local system previously. So let's get back to that and start our installation procedure just to save time. So I might want to cancel this. So let's get back to the download section and there you go. You can see the XAMPP software which is downloaded here. So all you need to do is just run it. So just provide the permission yes. Ignore this warning and just select OK. You can start the visit by clicking next. So here you can see multiple options for server, programming languages, etc. So you have the varieties of servers such as Apache, MySQL, FileZilla, etc., Tomcat. You never know which one you might need in the future, so I would suggest you to just select all. And same goes for the programming languages. Just select next. So now you can see the next dialog box where you're asked to select the location for your software. So it would be better if you select the default location, that is C drive. Just select next, and here you're asked to select the different languages for your control panel. So let us select English. English is a default option here. Now let's click next, again and next, and now your software is ready to get installed. Don't worry about this new web page which is popped up in your screen. Now let's get back to our setup file. Now let's just select next to start with the installation, and there you go. You can see that XAMPP is getting installed into your local system. Now this might take up a little while. All we need to do is just wait. Anytime now, the installation will be finished. So there you go, the installation is completely finished now. You can just click on the finish button and the process will be finished. And there you go. You can see your XAMPP control panel on your screen. Let's maximize this for a better view. Yeah, that's good. Now you can see the modules on your control panel, which are the Apache server, MySQL database, FileZilla server, Mercury server, Tomcat server. You can start any one of these. Let's get started with Apache first. To start that, all you need to do is just select the start button. And you can see the Apache has just got started. And you can see the first one was attempting the Apache app to get started, and then you can see the Apache app status changed to running. Now you can see the process IDs of Apache server as well as the port number, which is 80. Now you have an option of configuring your port numbers, because what if in future you may need to start Tomcat and Apache server parallelly but in different port numbers. So to make sure that they don't interfere with each other, you can configure them on different port numbers. To do so, all you need to do is just open config. And inside config, choose the first option, that is Apache http d.conf. Just scroll to the bottom and now you can see the port number here. So just let us change it to 3000. Similarly here, And now select the file option and save it. Now let's try to restart our Apache server, stop it, and then again restart it. And there you go, you can see the change of the port number to 3000 and the process IDs, which are 9620 and 9868. So this is how you install XAMPP server, and this is the complete procedure to install XAMPP server into your Windows operating system. What is a Lambda expression? Now, Lambda expressions were not there along with Java since the beginning. They were an update to Java since its 8th version. Lambda expressions are basically an advanced method of writing methods. To be simple, these Lambda expressions can be used inside a previously written method. This approach reduces the code length and improvises performance to a greater extent. So, we can define it as follows. A Lambda expression is a short block of code that takes in parameters and returns a value. Lambda expressions are similar to methods, but they do not need a name and they can be implemented right inside the body of any method. Now your very first question is, we had methods, then why do we need a Lambda expression that could replace the conventional method? So that's exactly where we understand the need for Lambda expressions. Now, Lambda expressions are having some impeccable features. They are capable of converting huge block of code into a tiny argument. Now, how cool is that? Now coming back into methods, when we need to create a method, we need to make sure that it belongs to a certain class. No matter that, we can create a method without having to belong to any class, but that would be just excess lines of codes lying in your project. But when it comes to Lambda expressions, a Lambda function can be created without belonging to any class. And finally, Lambda expressions can be passed around as if it was an object and can be executed on demand. Now, how do they work and what is the functional interface? These will be the next questions. Before that, we shall understand the syntax of Lambda expressions. Then, slowly, we will move ahead into the functional interface. So, followed by the need of Lambda expressions, we enter the syntax of Lambda expressions. Now the syntax of Lambda expressions is something which is shown on the screen right now. Now you might be wondering if Lambda expressions have 3 different syntaxes. No, it's actually based on the number of parameters we use. So the first syntax belongs to the first type, where we have absolutely 0 parameters. The second one is preferred when we had one single parameter. And the last one is preferred when we had multiple parameters. Now, do not worry about the number of parameters used. We shall execute examples based on each and every type of them to have a better understanding of each type. Now we enter the most important topic of today's discussion, which is the functional interface. In Lambda expressions, functional interface serves as a data type for the Lambda expressions. It is represented by the annotation called functional interface. It mainly consists of an unimplemented abstract method. And when an interface is represented using functional interface annotation, or basically a functional interface can never have more than one unimplemented abstract method inside it. If you try to declare more than one, then automatically we will face a compiler error. So the functional interface can be defined as follows. A functional interface in Java is an interface that contains only a single unimplemented abstract method. A functional interface can contain default and static methods which do not have an implementation, in addition to a single unimplemented method. Now that we have a theoretical understanding of a functional interface, let us get into the practical mode where we will try to execute some different examples based on functional interfaces and Lambda expressions. I hope so far everything was clear. Now let's begin with the practical session. Now we are in the practical mode and we are on Eclipse. Now let's quickly create a project. Let's name our project as Lambda. Just finish it. And done. Now we are having a Lambda project over here, and this is our source file. Now let's quickly create a new package. So by default, the name of the package is same as the name of project Lambda. So it's okay, not a problem. Let's just finish it. Now let's create a new class. Yeah. So we have our class here. Now let's quickly execute the code. As you can see, this particular program on my screen is an example for a button click operation. So what exactly this program will do is it will create a button on my screen, and when I press that particular button, I'll be displaying a message called "Hello world, welcome to Simplilearn" on my console. So this particular line on my screen is an example for Lambda expression, where we are trying to execute a printf statement using the Lambda expression syntax. Now let's quickly try to execute this program and see the output. So you can see that I've got the button over here on my top left corner of the screen. If I just try to press this button called click me, I'll be printing a message on my console which is "Hello world, welcome to Simplilearn." Let's try that again. Yeah, that's how it works. Now let's stop this button. Let's stop this program and continue with the next example. So this particular example is based on both functional interface and also the Lambda expression. So you can see this particular code segment is represented using the annotation called functional interface. So this is what I was talking about. The functional interface annotation, which represents a code segment that has only one unimplemented abstract method. Now let's try to quickly execute this program. So this particular code or program is nothing complicated. It's just trying to print the area of a circle. We already have a pi value, and we'll just calculate the value of the area of the given circle with a certain radius. So the radius will be taken as an input from this particular code segment here. Now let's quickly try to execute this. So you can see the program got executed and the console is asking for an input for radius. Now let's type in some random input. Let's input 15 as the radius. Now we should be getting the area of the circle with radius 15. So which is around 706.83 units. I did not mention the units here. Let's consider as centimeters. So this is the square centimeter area of the particular circle with radius 15. Now let's continue with the next type of program. Now let us try to execute the next example, which is based on the both functional interface and a Lambda expression that has 0 parameters. So we discussed this before. Lambda expressions are 3 types with 0 parameters, single parameter, and multiple parameters. So this example is based on 0 parameters. It doesn't have any parameters. It's just printing one single message. That is, "Hello world, welcome to Simplilearn." That's all, nothing more than that. Now after this, we'll try to execute another example which is based on single parameter. Now let's quickly run this program and see the message. So there you go. On the console we have the message, "Hello world, welcome to Simplilearn." Now let's move ahead and try to execute the next type, which is the single parameter one. So now you can see on my screen we have another program which is based on single parameter. So what we're trying to do is here just we are sending a string of data which is the name of a city, and we are just running through regex, and then we'll find if the data given is valid or not. So the city name that we are passing here is New York. Now let's just quickly execute this program. And there you go. We have the output. The value returned from Lambda is true. So the function that is info.matches worked perfectly. Now let's quickly get into the next type of example where we have multiple parameters. So as you can see on my screen, we have a small and simple example for multiple parameters Lambda expression. So the multiple parameters that we will be passing here are the values of x and y, and these x and y will be multiplicated with each other so that we'll be getting a product of these two numbers. Now we have the functional interface which has one unimplemented method, which is the float multiplication. Now let's quickly try to execute this and see the output. So the values passed were 100, 200 and 205. So the respective product of those two or those four numbers is been given here. So the product of 2 and 5 is 10 and the product of 100 and 200 is 20,000. So that's how the program for multiple parameters in a Lambda expression works. Now let's try to continue with our next example where we will try to print multiple elements present in a list or an array using for each loop. As you can see on my screen, we have a small little simple program which is a list, and inside the list we have a set of names of fruits, and we are just going to print these names of the fruits using the for each loop. And inside the for each loop, the control will run through a Lambda expression which is simple print statement. Now let's try to quickly run this program and see the output. So you can see the program got successfully executed and the names of the fruits have been printed here. Now let's try to execute one last program based on Lambda expressions where we will try to use filter operation over a collection. So as you can see, we have our last program on my screen. So in this particular program, we have three variables, which is the ID of the bike and the manufacturer name and on-road price of that particular bike. So what we're going to do is we have three particular variables here, which is Yamaha, Bajaj and Hero, and the cost of all the three bikes are different. So what we're going to do is apply the filter operation and filter out the bikes with on-road cost which is greater than 80,000. So this is how it should work. Now let's try to quickly run this program. So you can see the program got successfully executed and the bikes having price greater than 80,000 have been printed on my output console here. So with this, let's continue with our next topic. So let us move ahead and learn the major differences between the Lambda expressions and the methods. So the first difference between the Lambda expression and a method is the Lambda expression doesn't specifically need a name, but whereas for a method, name is mandatory. And the next difference is Lambda expressions may or may not include parameters. We have already executed an example based on 0 parameters. And the third difference is in a Lambda expression, it does not have to return a type, but in the method, it specifically needs to have a return type. And the last difference between the both is Lambda expression includes a body as the main code segment, whereas on the other hand, for a method, code body is just another code segment of the program. So these were the major differences between a Lambda expression and a method. Let us now enter into the next part where we will understand the Lambda expressions in the form of an object. So as discussed in the features before, Java Lambda expression is essentially an object. You can assign a Lambda expression to a variable and pass it around just as a normal object. Moving ahead, we have variable captures. A Java Lambda expression is capable of accessing variables declared outside the Lambda function under certain circumstances. Java Lambdas can capture the following variables. They are the local variables, instance variables, and static variables. Each of these variable captures will be explained as follows. First, we will understand the local variables. Java Lambda can capture the value of local variable declared outside the Lambda body. Now look at this Lambda expression that implements Java Lambda interface. Right now, this Lambda expression is only referencing to the parameter value passed to it, but we can change it. As you can see, the Lambda body now references local variables str, which is declared outside the Lambda body. This is possible if and only if the variable being referenced is effectively final, meaning it does not change its value after being assigned. If the str value had its value changed later, then the compiler would complain about the reference to it from inside the Lambda body. Moving ahead, we have the instance variable capture. A Lambda expression can also capture an instance variable in the object that creates the Lambda. Here's an example for that. Notice that the reference to this .val inside the Lambda body, this captures the name of the instance variable of the enclosing company ID object. It is even possible to change the value of the instance variable after its capture, and the value will be reflected inside the Lambda. The semantics of this is actually one of the areas where Java lambdas differ from anonymous implementations of interfaces. An anonymous interface implementation can have its own instance variables that are referred via this interface. However, a Lambda cannot have its own instance variables, so this always points to the enclosing object. Next, we have the last type of variable capture, which is the static variable capture. A Lambda expression can also capture the static variables. The static variables are reachable from everywhere in Java application provided the static variable is accessible, that is, scoped as public. Here is an example that creates a Lambda which references the static variable inside the Lambda body. The value of a static variable is also allowed to change after the Lambda has captured it. Again, the above class design is built nonsensical. Don't think too much about that. The class primarily serves to show you that the Lambda can access static variables. Followed by the variable captures, we have the method references. So method reference is used to refer method of functional interface. It is compact and easy form of Lambda expression. Each time when you are using Lambda expressions just to refer a method, you can replace your Lambda expression with a method reference. So there are three types of method references available in Java Lambda expressions. Those are reference to a static method, reference to an instance method, reference to a constructor. Now with this, we shall wind up our session by our last topic, which is the best practices to be followed while using a Lambda expression. So these are the few best practices to be followed while using Lambda expressions. The first one is prefer using standard functional interfaces. Functional interfaces, which are gathered in java.util.function package, satisfy most developers' needs in providing target types for Lambda expressions and each method references. Each of these interfaces is general and abstract, making them easy to adapt to almost any Lambda expressions. Developers should explore this package before creating a new functional interface. Followed by that, we have use of functional interface annotation. Annotate your functional interface with functional interface annotation. At first, this annotation seems to be useless. Even without it, your interface will be treated as functional as long as it has just one abstract method. But imagine a big project with several interfaces. It's hard to control everything manually. An interface which was designed to be functional could accidentally be changed by adding of another abstract method, rendering it usable as a functional interface. But by using the functional interface annotation, the compiler will trigger an error in response to any attempt to break the predefined structure of functional interface. So it is also a very handy tool to make your application architecture easier to understand for other developers. So followed by that, the next best practice that you can follow is to not overuse default methods in functional interfaces. We can easily add default methods to the functional interface. This is acceptable to the functional interface contract as long as there is only one abstract method declaration. So followed by that, the next best practice that you can follow is to instantiate functional interfaces with Lambda expressions. The compiler will allow you to use an inner class to instantiate a functional interface. However, this can lead to very verbose code. So you should prefer using Lambda expressions. And the final best practice that you could follow is avoid overloading methods with functional interfaces as parameters.
Let's get started with string handling in Java. String class is very versatile in Java and it provides a lot of handy functions which can help you manipulate strings in multiple ways. For example, if you want to trim a string, or if you want to append a string to another string, or if you want to find a particular character at a particular index, or if you have an index and you want to see what character is present at that particular index, or if you want to do any other kind of pattern matching in the string. So string is very versatile in that context. And today we will have a look at some of those methods. So I've just opened the Java Docs API for string, and you can see in the method summary, you will find a long list of methods. We will go through some of these methods. For example, if I just show you a snapshot of what I'm talking about, it has a char at method. So you provide an index, an integer index, and this particular method will tell you which character is present at that particular index in the string. Remember, string is basically a zero-based character array, zero index-based character array. Similarly, you can also call code point at, which is going to return the character in the Unicode code point at a specified index. Similarly, compare to method can be used to compare two strings with each other. Compare to ignore case is also there, which can compare two strings, ignoring whether they are in uppercase or lowercase. You can use concat method to join two strings together. You can use the contains method to find if a particular character or a particular sequence of character exists in a particular string or not. You can do a content matching, you can do copy. You can also see if a particular string ends with a particular character or a sequence of characters. So there are tons of different methods available here. And please do check out the API because, like I said, this is going to come very handy when you start writing real-time projects or the real-life projects. So with that knowledge, let's go to our IDE and let's have a look at some of these examples in action. So here also you can obviously have a look at the string class from the IDE itself. Just write string and hit control and you will see an underline and a hyperlink. So just click on this and the string class will be opened and you can actually read about the documentation of the whole string class. But we are not going to do that. We are going to have a look at some real life examples of how we can use different methods of the string class. So here I've created two strings, str1 and str2. str1 is holding a string which says John is studying, and str2 is holding a string which says in college. Now, the first utility function which I'm going to talk about is the length method. So if you want to find out what is the length of this particular string, then you can just call the length method on the string, and that is going to return the length of the current string. Let's see that in action. Let me comment the rest of the code, and let's see this one in action. So if I run this program, I get the value 16. So if you count this, 1, 2, 3, 4, space is also counted, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you get the exact length of the string when you call the length method. Similarly, another method is concat method, and concat method is used to concatenate two strings together. Concatenation basically means joining two strings together. So if you want to join the string 1 and string 2, then just call str1.concat with the string you want to append or you want to concat. So the concat method on the left hand side of the string is going to get concatenated with the argument which you pass in the concat method. So let's see that in action now, and let's see the result as well, because I'm storing the result of concatenation into a new variable and printing that variable. So I get this whole text here, and you see the studying in just got merged. There was no space in between because there is no space here. If you just put it like this, and if you rerun this, you will see the proper space as well while concatenation. One of the things which I also want to call out is strings are immutable in nature. When I say immutable, it means that once you have created this str1 holding this value, then this particular object's value pointing to str1 cannot be changed. You cannot mutate the strings. If you try changing str's value, Java is going to create a new object and point str1 to that object. But the object which was created initially is not going to be overwritten. So remember that concept that whenever you're doing manipulations on the string, the previous string object still remains there. It doesn't get overwritten or it doesn't get modified. Whenever you modify a string, you get a new object. That's the property of string. So we saw the concatenation. Let's move ahead. There's also a format method. Format method is used to dynamically populate some parts of the string. For example, if you have a long list of students and if you want to print the name of students, then what you can do here is that you can assign those names to certain variables. and you can point or refer those variables in the string with the percentage syntax, percentage S syntax basically. So the string.format method is used to supply dynamic values inside a static string. So in this case, this part of the string is static, where I'm saying the name of the student is. Then in the next string, remember plus also can concatenate it. It is also doing the exact same thing as the concat method. It's just a shorthand. So I'm creating first string, then I'm creating second string, but here I'm writing percentage S. I will come to that. And then I've created one more string where I'm using percentage D. So what happens that Java format method supports certain special type of references. For example, if you want to dynamically place a string, you can use percentage S. If you want to dynamically place an integer value, you can write percentage D in the format method. Similarly, you can also write other percentage F for a float value, and there are more other similar placeholders which are available in the format method. So do check out the format method documentation if you want to know what all percentage types or variable types can be dynamically placed inside the format method. Here I'm just using percentage S and percentage D. And then once you have created the first part of the format method, which is string with dynamic placeholders till this particular point, then you put a comma and you start providing the values. Remember, the sequence of the values have to be exactly the same way in which you have used them here. So if percentage S is coming first, then you have to supply a string value. If percentage D is coming after that, after the string value, you have to provide an integer value. If there was another percentage S after percentage D in the same string, then after 21, you had to provide another string value. So that's the contract which format method needs to honor. And if I run this particular program, and if I try to see the output, let's try to see the output as well. And for the output, I need to store this whole string.formats output into a variable. So let's say I say string R, and then I can print R and see what comes out. So that's it. Let's run the program now. And now you will see this line. The name of the student is John, comma, and the age is variable is 21. I think it's coming because I've just wrote variable is here. But if you remove this and if you say the age is percentage D, then you'll get a nice human readable output without any extra formatting. So the name of the student is John and the age is 21. And that there was a comma, that's why you still see the comma. But this is the basic idea with using the format method. Now another method which I want to talk about is the char at method. Let me comment the previous output so that we can follow along. So I'm just going to comment all of this, which we have covered already. And let's focus on the char at method. So char at method can be used to find the character present at a particular index in a string. So whatever index you specify in the char at method, the character present at that particular index will be returned. So when I say str1.char at 5, remember strings are 0 based indexed character arrays. So 0, 1, 2, 3, 4, 5. At 5, I is present. So this char at method should return I. So if I run this particular program, yes, I see the output as I. Now let's move ahead with the next example or the next API call. The next API call is the usage of equals method, where I can see if the two strings are equal or not. So here I'm saying str1.equals str2. If both strings are same, it is going to return true. Otherwise, it is going to return false. So if I run this, I get the output as both strings are different. It goes in the else block because str1 and str2 are different. They are holding different values. So here the exact content of the string is going to be matched. The next one is the index of method. So index of method can be used just for the reverse functionality of char at. In char at, we were supplying the index and getting the character. Here we can supply the character and get the index of it. So what is going to happen that you write the string dot index of, and then you supply the character for which you want to find the index of. So I supply y here, and if I run this particular program for this line, the output is 12. Let's see if the output is correct. So here, if you try to find what is sitting at the index number 12 in this string, so again 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So yes, y is present at the 12th index, and that's the output I get. What if you provide a character which is not present in this particular string? let's say Z, which is not there, and see what the output is. In that case, you will get the output as -1. So if the character is not present in the string, you will get the output as -1. Another thing, what if the character is present more than once in the string? For example, I is present more than one time in the string. So if I write I here, whether I get the index of this I or this I, let's see. So I'm going to run this program again and I get the value 5. So 5 is basically this I, because this I is definitely not 5. It's farther index. So the first match of the index is going to be returned in terms of the index of method. Okay, so that was about the index of. Let's look at the next one, which is the replace. In replace, it's as the name suggests, you can replace a character or a sequence of characters in a string by calling the replace method on the string on which you want to do the manipulation. And remember, you're doing the manipulation here, so the previous object is not going to get overwritten, but a new object is going to get created. So what I want to replace is with R. So in this particular string, I see an occurrence of S here. So this S should be replaced with R if the replace functionality works as I just explained. So let's run this program. And yes, I can say instead of S, I see R being replaced there. And that's the usage of the replace method. Next one is the split method, where if you want to split the string into multiple elements, so you just call the split method and you provide the separator. Here I'm separating the string whenever there is a space. I'm basically breaking up the string into multiple substrings. That's what I'm doing here, or multiple strings I would just call it as. So whatever separator you provide, whenever the string is going to encounter that separator, it is going to split one part of it. So I'm providing the separator as space. It means in this particular case, I'm going to get 3 items. The first breakup is going to happen here. So the John part of it will go out, and is will go out in a separate string. Then again, between is and studying, I have another space. So there will be another break here. So I should get 3 elements if I call the split method. One element will be holding the value John. The second element will be holding the value is, and the third element will be holding the value as studying. And then I'm printing all the elements of the array. Remember that split method returns a string array. So that's what I'm using here to store the output of the split method. And then I'm just using the streams API to iterate over this string array, outputting or printing each element of the array. So let's run this program. Okay, so I can see 3 different outputs through this system.out.println. First John, then is, then studying. Like I said, split method is going to create a 3 element size array of strings because I'm separating it based on the space. The last utility function which I want to talk about. So this is the last one, but I'm skipping some more due to the interest of the time. But like I said, do check out the documentation to read or understand more about other string utility methods, which I'm not covering here in this session. So the last one I'm going to talk about is the substring method. And substring is basically going to take a mini string out of the long string. So what if you want to trim the string? What if you have a long string and you only want to get a part of the string? So you can specify the starting point. You can specify the end point, and whatever string characters are present between the starting index and the end index will be taken out from the string, and you can store that output into a new string and print that. So here I'm calling the substring method, providing the starting index as 1 and the ending index as 5. Let's run this program and interpret the output. So I'm getting the output as OHN. So what is happening here? Let's go back to the str1. So I said start with 1. Remember, string is a 0-based index. So it starts with 0, 1. It starts with O because O is present at the first index. And then I'm going up till 5. So 1 gets printed. Whatever character is present at 1 index get printed. Second index get printed. Third index gets printed. Fourth index gets printed, which is just a space. And then the 5th index is I, which is not printed here. So it means that when you call the string substring method, then the end index position will not be printed. It starts from the beginning index and it will go till end index -1 position in terms of printing. Because if you select this, you'll see an extra bar here because the space is also getting printed. So it is printing everything before the 5th index. It will not include the 5th index character. Remember that when you use the substring functionality, that the end index is not included in the substring. If you want to include that, you need to increase the index by 1. So for example, if you want to print I as well, then you have to write it as end index as 6. And if you run this, then you will also see I now. Yep. So that is how this substring functionality works. Let's get started with java.lang package. So java.lang package is one of the most core and fundamental packages in Java, which is provided out of the box to the developer. You never explicitly import this package in your Java program because you don't need to. Java provides this automatically the moment you create a file with .java extension, and you are running that particular program inside or on a JDK, you get the java.lang package automatically. For example, when we were running the string handling demo, I was using the string class, but I never imported this string class. You can see there is no import for string because string class is also part of the java.lang package. It's automatically imported for you. You never need to explicitly import the package or any classes of that package. So this is going to be more of a theoretical lecture where we will just have a look at or a quick overview of all the java.lang package classes and other utilities. You don't need to remember all the classes and utilities, but this is just to give you a sense of what all it contains. So in terms of the interfaces, it has the appendable interface, auto-closable, char sequence, clonable, comparable. If you remember, we also used comparable when we were writing the comparable implementation to compare different objects in a collection. So this also comes automatically as part of the java.lang package. Iterable, runnable, again, we use this in the threading example. So this also comes automatically to you. You never need to import the runnable class from the java.lang package. When we move to the classes, all the data type classes which you can think of in terms of Boolean, byte, character, class loader, compiler, enums even, float, integer, long, math. So all the classes which we were using, the data type classes which we were using in different examples are also part of the java.lang package. Okay, so this is a long list. It also has the thread class. So whenever you are creating thread, you again never imported thread class, but it still just worked fine because this was also coming as part of the java.lang package. There are also a bunch of enumerations which it provides in terms of Unicode, thread state, etc. It also provides exception classes like arithmetic exception or the different runtime exceptions which we dealt with, like array index out of bound, array store, class cast, class not supported, the root exception class. So a lot of exception classes also come as part of the java.lang package. It also provides some error classes. If you remember when we talked about the exception framework, you have the error types and you have the exception types. So it also provides some error classes. If you want to use that, you never need to import any of these classes and you will automatically get them from the java.lang package. Similarly, it also provides some annotations as well, like functional interfaces, or you remember we use this annotation a lot, the @override annotation, but we never imported the override class or the override annotation because it's part of the java.lang package. So this basically tells us that there are a lot of different classes, utilities, enums, errors, exceptions, data types, which are provided out of the box from the java.lang package, which makes our life so much easier whenever we want to work with Java, because we don't need to import the very basic classes which we use very frequently. And another very important package is the java.util package. We have been using the java.util package in all of the collections, examples, and tutorials we walked through in this whole tutorial series. So let me just open the java.util package for you. So if I go here to java.util, and I will be able to see the java.util packages, different classes, etc. Yes, so here it is, the java.util package. And remember, java.util package is not imported automatically. You have to explicitly import the java.util package to use the classes of it. So that's the difference between java.lang package and java.util package, that you cannot you can use the classes coming from the java.lang package without explicitly importing those classes or importing the java.lang package. But java.util package is something which you have to explicitly import in your Java program to make it work or even make it compile. So what java.util provides? First of all, the collections framework. The whole collections framework comes from the java.util package. So for example, all the interfaces which we use while we work with the collections framework classes, interfaces like collection, list, set, map, you can see the map interface, you can see the list interface with the generics. So all the interfaces which we use from in the collections framework are present in the java.util package. Similarly, when we talk about the classes, all the concrete classes implementation of the collections framework in terms of array list, linked list, hash map, hash set, tree set, tree map, you will see all of those classes here. Here we are covering all the, this is showing all the classes summary. So you see some abstract classes, and you will also see some concrete classes as you move further down in this particular list. So you see hash map, you see hash set, hash table, linked hash map, linked hash set, linked list. We used all of these classes while we were going through the collections framework tutorials. So it provides all of these and a lot of other classes like the scanner class, which we covered in the Java project for taking the inputs from the command line, from the user, stack class again from the collection, some time classes, and it also provides a bunch of enumerations like the locale, basically setting the language categories for a particular program. It also provides some exceptions which we used while we were working with the collections framework. So most of these exceptions are or some of these exceptions are related to the collection classes. For example, the concurrent modification exception gets thrown whenever the whole execution detects concurrent modification of an object when such modification is not allowed. You will see other different types of exceptions like illegal format, etc. in this particular exception section of this particular package. Then it also provides just one error class as well. So this is what the java.util package contains. And just to refresh your memory, whenever we ran any collection demo, we always imported the java.util classes. You can see this is all coming from java.util. So this is something which you have to import, without which your program will not even compile. So that's also one of the difference between the java.lang package and the java.util package. And that's pretty much all I want to cover in this particular session. So we basically did a quick tour of the java.lang package and the java.util package. And like I said, it's impossible to cover all of that or all of the classes and enums and interfaces and errors and exceptions with all the examples. So I would suggest you to just keep this in mind about the java.lang package and java.util package. I told you the basic concept that java.lang contains all the types, the class and the variable types or the data types we dealt with, and java.util majorly contains all the collection classes. That's the basic thing which you need to remember whenever you work with Java. And your java.lang package never needs to be imported, but java.util package needs to be imported always whenever you use the util classes. Let's get started with networking in Java. So when we talk about the networking in Java, Java has a whole dedicated package called java.net package, which has all the different classes which you need to have to write a networking program in Java. So you will see a bunch of classes with two classes, most important ones, which are inet4 address and inet6 address. So as you can understand that inet4 address is the class which can be used to represent the IPv4 addresses, and inet6 address class can be used to represent IPv6 addresses. And then you can learn about sockets. It also has socket classes. It has a lot of interfaces, with the prominent one being the networking interface. There are some high-level APIs. For example, the URI class is there, which can be used to represent a universal resource identifier as specified in the RFC. And this is just an identifier. This doesn't provide the means to access the resource. If you want to access the resource, then you need to use URL, which is the class representing the universal resource locator, which is a slightly older concept than URI. But with URL, you can hold the address as well as access the address. URL connection is also one of the class which is created from the URL class to set up a communication link with the URL. And similarly, HTTP URL is for an HTTP connection, and you have protocol handlers. There are a lot of interesting classes which you can explore if you want to learn more about what all networking support Java provides. But when we talk about the basic ones like IPv4 address, the URL, URI classes, these are the ones which generally most developers interact with. If you want to write a socket program, then you can still do that with the classes and interfaces support provided by Java. So you can see a bunch of interfaces here, cookie policy, socket option. Then in terms of classes, you can see again content handler, cookie manager, HTTP cookie, inet4 and inet6 address with the classes which I talk about. It also has a generic class, but I would always recommend to use one of these if you know what address you're dealing with. The URL connection, the jar URL connection class, proxy class, some bunch of socket classes, URI URL classes, and then some enums and exceptions as well, which are related to networking connections. For example, malformed URL, if the URL itself is not correct, then you get a malformed URL exception. Socket exception, if there's a socket timeout exception, then also you have a dedicated exception for that. So there are a bunch of different exceptions, classes, enums, and interfaces available, which you can have a look at if you want to dig deeper into it. So I've also prepared a demo where we will be using some of these functionalities of this particular package. So let's jump to the IDE and see what I've built. So here I have created a class called networking demo. And what we are trying to do that we will provide the Simplilearn URL, and we will try to get bunch of information about how this website is hosted. So you just create a simple string variable and you can type any string, you can write any favorite website of your choice here. And then we create the inet address class. And like I said, you always use the concrete implementation of the inet address class, which is in this case, inet4 address. So I use the get by name and we supply the URL to get an inet address object. And what does inet address contains? It contains all the information in terms of the internet address on which that particular website is hosted. So you will see a lot of different functionality in this class. Let's explore some of the functionality and methods which are provided by the inet address class. So once you do this, you will get an inet address object if the URL is correct. If the URL is incorrect, you will get a malformed URL exception anyways. If you want to just see the address of the IP address where this particular website is hosted, you can call the get address method. And if you want to see the host address method, then you can call the get host address. Now you might be wondering what is the difference between get address and get host address. So let's get first that out. Let me comment the rest of the code and let's first focus on this particular part. So let me comment the local address part as well. We will come to that in a while and I can just remove this comment. So we are printing the get address and the get host address, and let's see what values do we get and how do we see if it's a different value. So this explains, right? When we call inet address.get address, we just get all the values. As we know that when we deal with IPv4 address, the address has 4 values, something dot something dot something dot something. If you want to verify it, just go to your own laptop and you will be able to see some address like 192.168.something.something. So that IPv4 address has 4 sections, and all the 4 sections will have some values. So if you use the get address method and you try to convert this into a string, it basically will return an array. The get address method will return an array which will look like this. But if you want to see it exactly in the format in which the real world networking protocols understand it, then use the get host address, which is going to show it exactly in the way in which we write the IP address, where we write some integer dot some integer dot some integer dot some integer. So that's the difference between get address method and get host address method. Same value, different representation. The next function which I'm going to talk about is about local address, and the local address or the method name is any local address. So this method is going to tell me if there is a wildcard address which is associated with this particular host. You can also see what this method is doing from the documentation. So if you go to the documentation and if you search for this particular method in the inet4 address class, you will see it says utility routine to check if the inet address is a wildcard address. The result will be a Boolean which will indicate if it has a wildcard address or not. So let's run this program and understand if it has a wildcard address. No, there is no wildcard address associated for this particular website. Similarly, there's another method which we can explore, which is link local address. So let's search for the documentation of it first. So this is the class. If you search it, it will just show you the exact class which is present with the method. And this method provides basically a check to see if the inet address is a link to a local address within the domain of the website. So the result again will be a Boolean. If it says true, it means there is a link to the local address. And if it returns false, it means the address is not a link local unicast address. So let's see the output of this with respect to the Simplilearn website. So if I run this program now, I again get false. So there is no wildcard address attached or associated with the website, and it does not point to a local unicast address either. Is there a loopback mechanism? Now, these all are networking concepts, and since this is not a networking session, so I will not go deeper into what a loopback address means in detail, but to give you an understanding of where it present and how you can use this in Java is what we are going to focus on. So if you want, you can always read about what is a loopback address. But if you want to know if the URL which you are pointing to is the address which is returned by that website has a loopback address or not, then you can use the is loopback address method. And this again returns true or false based on whether it has a loopback address or it does not have a loopback address. So if I run this particular program, I get the output false again. So no, the Simplilearn website does not even also have a loopback address. The last one, or the second last one, which I want to explore is the site local address method. So let's see, what does this method do? Let me just remove this extra commented lines. So let's look at the documentation of this method. So this says a utility routine to check if the init address is a site local address. The result is a Boolean indicating if the init address is a site local address, or false if the address is not a site local unicast address. Again, this concept is again a networking special concept, similar to the loopback address. So this is just basically showing if the site also has basically a local unicast address associated with it or not. So if you want to see the site local address output, I have enabled that code, and if you run this particular program, we get false for that as well. Yes, that means that the Simplilearn website is built with pretty good practices. There is no loopback address, there is no site local address, which we don't need for this particular website in this case. The last one is just a simple thing, just to see the hash code. It's not much of a relevance, mostly in the programs, but just to tell you that this is also available. So you can also see the hash code, which is contained by the init address object. So we covered a bunch of functionality in this particular example. We had a look at the java.net package. It has an inet4 address class and inet6 address class, a lot of networking exceptions and interfaces support as well. And the simple way to use it is to you point it to a website, call the get by name, call the get host address, and you will get the IP address in the exact format in which the networking world deals with it. Similarly, you can call the get address to just get an array of it, just as we saw here. And then there are a lot of utility functions available in the inet address class, like is any local, is link local, is loopback, is site local, and there are actually more. If you look at this class, you will find more methods here in terms of what, like for example, it also has a is multicast address. This is basically to check if the init address is an IP multicast address. So there are a lot of different methods here. There are some MC methods as well, which will check, which are specially created for the multicast address scenarios. So a utility routine to check if the multicast address has a global scope, if it has a local scope, or sorry, it has a node scope basically, or it has a link scope, or it has a site scope. So there are a lot of different methods available for the multicast as well, which you can have a look at. And we already covered the get address, the get host address, and the hash code address classes. There are some URL classes as well. Like I mentioned, URL and URI classes are also very important classes, which you might need to use whenever you are building a connection with a particular application based on their URL. If you're doing socket programming, there are socket classes available, which you can also use while using the networking concepts in Java. So you can build a pretty decent and robust application using the networking classes and the networking support provided by Java to build a networking application. Let's get started with image handling in Java. So we deal with images on a daily basis, and you will often be required to deal with image handling in Java programs as well, where you might need to read an image or write an image or load an image into memory and do other kind of manipulations on the images. So Java does provide support for image handling as well, and you can pretty much load any type of image, be it a GIF image or be it a PNG or be it a JPEG image. Basically, it converts into a Java 2D image to render it, and it basically creates a byte representation of the image to serve and save the contents. So in this section, we are going to talk about the image handling aspects of Java. And to do that, there are broadly two classes which Java provides. As you can see in this official documentation, the first one is java.awt.image class. And the second one is java.awt.image.bufferedImage class, which extends the image class. So this is basically the super class, as you can see here, which you can use to represent any kind of graphical image as a 2D array of pixels. And buffered image is a concrete implementation of the image class, which you can use to construct instances of the class. And buffered image is sort of the, I would say, the de facto standard or the go-to class whenever you are dealing with any kind of image rendering tasks in a Java program. And we will also have a look at how we can use the buffered image class to basically read a sample image and also write a sample image to a file system. So you can read more about this in the documentation, and there are also a bunch of documentations available in terms of how you can read it, how you can load it into the program, how you can draw an image, how you can create and save the image, etc. And like I mentioned, we will be covering some aspects of it in today's demo as well. So this was a very brief theoretical introduction about image handling. And like I always mention, if you want to know more about this, do check out the official documentation of Java, where you can learn more about the image handling classes and utilities. So with that, let's move to the demonstration part. So I have prepared a demo here, which talks about image handling. So I've created a class called image handling demo, which has a public static void main method. And I'm just giving some sample dimensions for the image in terms of width and height here. And then, as I mentioned, that we will be using the buffered image class. So I'm creating a reference for the buffered image. It's currently assigned to null. So basically there's nothing. And then I am calling the method read from file. So like I mentioned, you mostly will be dealing with reading from an image or writing to an image. So here we will look at both of the aspects as to how you can load an image from your file system into a Java program and then write it back to the file system from your Java program. So let's first look at the read from file method, which will tell us how we can read a Java file. So I provide some sample dimensions. These dimensions will vary based on your use case, and I supply the buffered image object. Inside that, I have created a try block, and in the try block, the first thing you need to do for image handling is to basically create a file object, because image is also technically just a file, right? So you provide the file image path here at this particular location. So let's go to the sample image path. This is the destination path, and let me open the sample image path as well, which is somewhere in the C drive. So this is the image which we are loading. This is the path which I've mentioned, which is c/sample.jpg. So let's first have a look at the image as well as to what this image contains. So this image is basically from a clinical trial and showing some blood sample or some vaccine bottles, which is probably the very popular image nowadays because we are living in this pandemic world. So this is the sample image which I've chosen to read, and then I will load this into the Java program, and then we'll try to write it back to the file system to a destination location. So this is where my image is present in the C drive named with sample.jpg. And this is what I've supplied here. So you just need to supply it in double quotes. Remember, when you're dealing with Windows file system, you always have to use double forward slashes, which is different if you're working with on a Mac machine or you're working on a Linux system where only this will work fine. So that's a bit awkward thing which Windows has, and you have to respect the operating system's restrictions or way of doing things. So once you have loaded the file or created the sample.jpg file object, then the next thing we are going to do is we are going to create an object of the buffered image. Remember, we just created a reference. We did not create an object yet of the buffered image class. And now is the time to do that. So we supply the width, we supply the height, and then we supply the type of the image. Let's go to the constructor of this image to see what this image type means. So this image type can be basically the type of the created image, which comes from the color space. So whether it's an RGB image or ARGB image or BGR image or byte gray image, there are multiple different types of images in the media space. And whatever type of image you have, you need to basically supply that image type in this particular argument. So in my case, it was an ARGB image, so I supplied that particular. If you click on this, you will see that currently it's inside Java. An 8-bit RGBA image basically has a static constant, which is denoted by 2. You can read more about this inside the buffered image class documentation as well. So once I've supplied that, my buffered image object is ready, which has all the details, dimensions, and the types of the image. Now the next thing is that you need to fill this image object with the file. So you basically need to read the file and store the output of this read operation into the buffered image object. Then what will happen that along with this information, whatever is present here will also be added to the same buffered image object. So to read a image or simple a file, Java provides an IO utility which is called image IO, and there is a read method available which is a static method on this particular class. As you can see, I'm calling the class.method name here, and then you supply the sample file name. Once you have done that, then it will basically be reading the whole image into a 2D byte array and copying that over into this buffered image object. Once that is done, if this particular line is successfully executed, then you will get this message which will say reading complete, and it will try to print some hash code of the image object. And after that, if there's any exception in this block, for example, this particular line may raise an exception, or this particular line may raise an exception if the file does not exist, then you need to have the IO exception caught. Remember, IO is a checked exception. So if you are using these operations, file, new file, and image IO.read, you need to catch the IO exception because it's a checked exception. So either you need to catch it or you need to rethrow it. These are the only two options you have with a checked exception. So once we have done all of that, if everything goes fine, if everything is happy till line 35, then we just return the image object and our read from file operation will be done. Going back to the main method, once the read operation is done, the next thing I'm going to do is writing this image object to a new destination file. So let's see what is happening in this write to file method, because this is the method which is responsible for writing this image to a new destination location. So I've created a public static void method inside the same class where the public static void main method is present. As you know that static methods can only call other static methods. That's why this had to be static. And I'm supplying the same image object which was returned from the read operation. That goes in as the argument of this particular method. And again, I'm using a file object. And this time I'm providing a destination location where I would like to write this image. So this is the destination location I've chosen, which is F drive Java tutorials folder, and the image should be stored with the name out.jpg. So this is the location. There's already an out.jpg here. So let me just remove it so that we can observe the output. So we create the file object. After that, we again use the image IO utility. We call our static utility method called write. We supply the whole image object. We supply the image type extension, and we supply the output location. Again, if I take you to the signature of this, you take the rendered image, you take the format name, which is JPG, and the output location. So these are the three things which you need to supply once you call the write method on the image IO utility class. Image IO is a very handy class, and do remember this class whenever you are dealing with the image handling operations. It will provide a lot of static convenience methods. So we write this write this image object to a file, to a destination location. And if everything goes fine in these two lines, we will get this message which will say writing complete. If anything goes wrong, we again catch the IO exception, and the exception will be printed here. That's all is happening in this particular program, where we are reading from file and we are writing to the file, reading it from here and writing it on this particular location. So let's run this program and see if we are able to read from file successfully and also write it to the specified location. So run as Java application. It's a slightly memory heavy operation, so it takes a bit of time because the whole image needs to be loaded into memory. Be very careful about that. It might eat up a large portion of your RAM if the image is too heavy. So here it says reading complete, and then it prints the hash code details of this particular object. And then it also executed the write to file method, and it said writing complete. So just to show you the reference back again, this is what we read, sample.jpg in C drive. And if I go to the F drive, Java tutorials, where I provided the output location, I do see an out.jpg here, which was not there earlier. And if I double click on this, it's exactly the same image. So Java was able to read the image and render the exact same image by converting the 2D byte array representation back to an image exactly the same form. There's no change in this image. So this was a very short and lightning tutorial for you to show you how you can use image handling classes, for example, the image IO class and the buffered image class, to do basic image handling operations. Obviously, you can do more complex operations with it as well, but for the demonstration purpose, I've just kept it simple. Let's get started with concurrency utilities in Java. Now, concurrency is a huge topic, and it's not possible to cover this into a 10 or 15 minutes tutorials. So treat this particular session as an introductory session where I will talk about some of the most relevant classes which you need to know when you talk about concurrency. We have been talking about this whole concept of concurrency programming throughout the thread tutorials as well. And the basic idea is that you would like to do multiple things at the same time. That's the basic idea. Now, in that context, Java does provide a lot of utilities and packages, especially the java.util.concurrent package is one of the most popular package which you need to use whenever you are dealing with concurrency programming paradigms in Java. So with that, let's have a look at what does this java.util.concurrent package contains. So broadly, it contains a lot of utility classes, which can be very useful for you when you are writing the concurrent programming code. Apart from that, it will also provide some basic ideas around the locking functionality and the atomic packages as well. When we talk about locks, again, we discussed about locks when we talked about the whole thread synchronization concept as well. And it basically marries very well with the whole concept of locks and atomic packages as well. Atomic is again a different topic, which is used for thread safe types basically. But whenever you will hear about concurrency utilities, be it in your discussions or be it in your interviews, you will be seeing a discussion happening around executors. You will hear these terms like executors, executor service, future, completable future, callable, all of these. You will hear the name of all of these classes quite frequently. So these classes were first introduced in Java 8 and have been there since then to support the concurrency programming paradigm. So I will talk about these three classes broadly in today's session, and we'll have a look at a demonstration of these three classes as well. Let's first talk about executor. Technically, it's an interface. It's not a class, though I said that it's a class, but it's basically an interface. An executor is basically a very simple interface which will help you define the subsystems which you would like to create with the help of threads, maybe including thread pools, or if you want to do a disk reading and writing operation in an asynchronous way, or you want to create some sequence of task frameworks as well. So executor will provide you a very lightweight framework to do all of that, especially around thread pooling and asynchronous IO is where it shines most, because in your computer you have limited resources and you would like to dedicate a certain pool of threads for a particular task or for a particular executor object. So with that, the second class which we would like to know about is executor service. An executor service will provide a more asynchronous task execution framework, and this is probably the class which you will be using whenever you're dealing with asynchronous programming in Java. Asynchronous programming basically means that you submitted a particular task, but you did not wait for it to be completed. You did not hang your process or your thread for that particular task to be completed. It's very simple. It's very easy to relate this to a real life. For example, if you are, there are times when you do two things at the same time. For example, let's take a very, very simple example. If you're just boiling milk on your gas stove, so you put the milk on the gas stove and then you move out for a couple of minutes to do something else. For example, maybe checking your mobile for new emails or doing some other work, maybe just doing some laundry. So you submitted the milk boiling task, then you moved away from that task because you know that this particular task is going to take some time and you utilize your time somewhere else. That's what we mean by asynchronous programming, and executor service will provide you with constructs to create a similar behavior in your Java program as well. So remember about executor and executor service. We will look at the implementations later where we can talk about that. Another interesting class which I would like to talk about is future, if we have it here. Yeah. So future is another class which we will be looking at, and future is basically to fetch the result of the submitted task. Again, taking the same naive example of the milk boiling example. So it would be great, right? If there is some mechanism or some alarm which just sets off the moment the milk is boiling and it's about to be spilled out. It would be great to know that in advance via some alarm or something. So future provides that kind of a carrier or that kind of a holder where you submitted a particular task, you moved your threads to something else, you did something else, and then you can check with the future object, and future object will tell the status of that submitted task, whether it is completed or whether it's still in progress. Once it is complete, then you can fetch the result of that submitted task based on with the future object. So that's the concept of future. So remember, executor service and future, they will work quite hand in hand, because executor service will be used to submit the task and future will be able to fetch the result of that particular task asynchronously. So that was about a quick theory. You can read more about it in the documentation. You can see an executor service, future class, what does this basically in these class do. But to have a look at or get a greater sense of this, let's have a look at our demonstration of it to understand these classes better. So let's move to the Eclipse IDE to look at an example. Let me close all the classes and just open a relevant one. So yeah, so let's first deal with the executor interface itself. So if I just minimize this one, here I've created a main class and I've created a public static void main method, and you see two static methods here, executor invoke and executor service invoke. I'm basically showing you how you can use executor and executor service. So if you're just using executor, then how you would do that is basically you are going to create a reference of the executor, and then the executor needs basically an executor object, because it's an executor reference. So you need to supply an executor object. So either you can supply an inner class right here, or you can call, you can create a executor type of class, which I've created here, which is called caller class. So I've created a class called caller, which implements the executor type. And the moment you write implements executor, it will force you to override the execute method. And inside the execute method, you're going to run your own thread. So this is how the current thread or the executor's own thread will be running. So once you have done the initialization, then you can call the execute method on the executor class. Remember, you got this object, so you can call the execute method on the executor object here, and inside this you can provide this particular Lambda function implementation, which is going to ask you what exactly you want to do when I run this particular thread. So when I run this thread, when Java runs this particular thread, what do you want Java to do? That's something which you will provide here. So this is how you can use, it's a very simple example. Like I said, if I build a more complex example, it will take a lot of time and a lot of other concepts to cover. So treat this as an introductory session, and you can basically try to run a very simple example of this, writing whatever complex logic you want to write while the thread is running, and put that into this execute. Similarly, if you want to use executor service for doing the asynchronous operations, then it will follow the same way, but there are some differences along the way as well. So this is the method which is showing the executor service implementation, or the way of using executor service. So again, I create a reference of executor service, and then here you see I'm saying executors dot new fixed thread pool with a size of 10. So that's the power of executor service. It is going to create a pool of threads dedicated to itself to do the tasks whichever are written inside here. So whatever you write here, these thread pool will be utilized to execute that particular task. You can assign the size of the thread pool based on how many threads you need. There are multiple static utility methods, like there is one new fixed thread pool which I've used. But if you just do Control Enter, you will see cached thread pool, single thread execution, a new work stealing pool. So like I mentioned, there are a lot of classes, interesting classes here, which you can use. For simplicity, I've just used a fixed thread pool here. Once you get the executor service object, then here you called execute, but here you will be calling the submit method. And then the drill goes exactly the same way, that you write the Lambda function implementation inside here, basically the functional interface implementation, and you provide your own implementation code which you would like to run whenever you call the run method, whenever this executor service calls the run method on that particular thread. You can actually go to the submit method and you will see it accepts a runnable. It basically accepts a thread object. So whatever you write inside this particular code will be the public void run implementation of that particular thread class. If you don't remember how runnable works, please go back to my threading tutorial and watch that, where I explained the runnable interface and the run method in detail. So that's what we are doing here. So this is for executor and this is for executor service. So let's run this program. And yes, I mean, nothing, because I'm not doing anything much apart from just doing sysouts here. And that's what you see here, the executor example and the executor service example. So this was about executor and executor service. Now let's deal with another interesting class of called future, which I said that I will also talk about. So for that, I've created a separate demo because it deserves a separate demo. It's a very interesting class. So let me just make it full screen. Yeah, so I've created a class called future demo, which has a public static void main method. And again, I'm doing this executor service initialization, but this time I'm using a new single thread executor. Now, what does this do? This will basically create an executor which will use a single worker thread operating from an unbounded queue. Remember, even if this single thread terminates due to, let's say, a failure during the execution, before the graceful shutdown, a new one will automatically be spawned and will take its place if the execution is still pending. So that's the power of single worker thread from an unbounded queue. That's what I've used here. Based on your use case, you can use other ones as well, like I mentioned earlier. Then I have the executor service object with me, and similar to the previous example, I'm going to call the submit method. And inside the submit method, I need to provide the runnable class runnable interfaces implementation. And that implementation will basically be of the public void run method. And this is what I want to do in my run method, where I'm sleeping the thread for 10 seconds. Thread.sleep method takes millisecond values as the parameter. So this is 10,000, which means 10 seconds. So I'm sleeping this thread or pausing this thread for 10 seconds and then returning a string called completed. This is what I am doing in the executor service.submit implementation. The result of it is going to be a future object. Remember, the result of the submit task is going to be a future object. So I store that future reference here, and then at line 20, I'm using the same future object to ask Java to check if this task is done. And the way you do that is just by calling is done. So till the time, there's a negation condition, till the time the task is still in progress, because this means future is not done because I've put a negation, then just print this out where you say the task is still in progress, it's still not complete, and you pause this particular thread. Remember, this was a different thread. If you pause this particular thread for 500 millisecond, or basically half a second, and you again check this condition. If it's still not done, you print this, again pause for half a second, again check this, till the time future.isDone becomes true. When future.isDone becomes true, that means that this particular task is completed. Now you see, I mean, generally when we execute the programs, the execution happens sequentially, that after line 17, the control will automatically flow to line 20. And before the control can reach line 20, everything above line 17 has to be completed. That's basically synchronous programming for you. But when you talk about asynchronous programming, using the power of executor service and future objects, you can do something here which will go into a separate thread. And then you can continue your execution here. So this can be in a different method altogether, where you submit something, and this is basically checking the status of this task. Understand this very well. This is very important concept, that it's not though it's a sequential execution, after line 17, line 20 is getting executed, but line 20 is not waiting for everything above line 17 to be finished. It will continue. That's the power of asynchronous programming. So here we are checking this, and once the future.isDone says true, then we say task completed. And then you probably would like to fetch the result of this particular task, right? And for that, future provides a method called future.get. This is going to pick the future object state, and whatever you are returning from here will be returned here, and then I'm printing the result. So if everything went fine, this result should say completed, because what I'm returning from this future object. And always remember to shut down your executor service to release the thread pool which you created here. I've also put a catch block here because I'm using the thread.sleep method, which will ask you to handle an interrupted exception. And then there is an executor service exception, which is execution, and a timeout exception as well. There are other interesting methods as well on the future object, which is like future.cancel, where you can cancel explicitly a future task which is currently in progress. You can check the status of it by calling isDone, which I've used here. You can also call isCancel to check if the user or some other process explicitly canceled the execution of the submission of the executor service task. So hope this is you are able to understand the flow of it, that these block and these block will program will execute them, but they will run in different threads. So let's see what happens. Now I'm going to run this particular program. And if I bring this here, you see the task still in progress keeps getting called. So we submitted the task here, and now this block is getting executed. This block kept getting executed. So this task did not finish, right? The thread.sleep was this whole thread was sleeping for 10 seconds, but line 20 did not wait for 10 seconds. It continued execution and it kept checking the future object 10 times at least, or till the whole 10-second sleep was taken away. And once this thread woke up, it returned completed. Feature.isDone became true, and it came out and it said task completed. So that's what we get here. And at the end, in the result, you get completed, which is what you returned from here. So this is the power of asynchronous programming. Please, like I mentioned, please do read more about these classes and how they work and what is the paradigm of asynchronous programming. It does make debugging a bit hard at times, but it's a very interesting concept to be used in concurrent applications. Let's get started with regular expressions, or regex, in Java. You may hear people calling it as regex or regex. Doesn't matter. You can call it anything as you want till the time you have the concept understood in the right way. I'll just call it as regex. So when we talk about regex, let's understand why do we need them and how Java actually provides support for that. So the basic idea behind regular expressions is to find a pattern in a text corpus. If you have a lot of strings available, if you have any kind of text, any kind of string, and if you would like to find a particular pattern saying, okay, does this whole text paragraph contains any character, or contains any number, or contains any special characters, or contains characters after numbers or numbers after characters. So if you would like to find those kind of patterns in your text corpus, then that concept is called regular expression finding. And Java provides the support for that particular regular expression finding through a package called java.util.regex package. So this is the package which you would need to use when you want to do any kind of regular expression finding in the text. Now, you may be thinking that why do I need to use this? I already have the string handling methods, right? You can do substring, you can find a particular character in the string, etc. But that is limited because it only provides string methods, ways to manipulate and find and replace strings. But regex is generic. You can literally find any kind of character in your string. It can be a special character. It can be a square bracket. It can be a multiply sign. It can be a divide sign. It can be, like I said, integer, capital letters, small case letters. So any kind of pattern you would like to find, java.util.regex can be used to find that kind of pattern. Now, this package is very interesting and it provides lots of classes. And again, this is a very big topic and very complex topic. So we will just scratch the surface of it. And like I always say, whenever you would like to read more about it, go back and read the documentation. Currently, the documentation I've opened is for Java version 8, but when you are reading it, you can go for the latest Java edition documentation. So with that, let's talk about some of the interesting classes which we will be dealing with and we must know when we talk about regex in Java. So I already explained what are regular expressions. Let's go to the interesting classes. The first class which we need to know about is the pattern class. So pattern class, or an object of the pattern class, will basically be representing a compiled regular expression. So you write your regular expression in a certain way. Regular expression has its own language, I would say, to write the pattern. For example, if you would like to write a pattern saying that check if this particular text paragraph has the characters first, then the integers, then the characters, then this particular special character. So that is your pattern. You write that pattern, then you need to compile that pattern. To compile that pattern, you can use the pattern class. This class generally does not provide any kind of public constructors to you, so you cannot initialize the pattern object explicitly. But to create a pattern, you need to basically call the static method named as compile. So compile is the method which you need to use to compile your regular expression, which will then return the pattern object. Once you have written your pattern and you compiled your pattern, the next class which you need to know about is the matcher class. Matcher class will provide that particular engine framework which will understand and interpret the pattern and then will try to find that pattern on the text paragraph which you're supplying, and it will result in true or false. If it finds that pattern, it will say true. If it's not finding the pattern, it will say false. So that's the basic idea. So you need to know about the pattern class and you need to know about the matcher class. So It also does not, the matcher class also does not provide any kind of public constructors, and you obtain a matcher object by calling the matcher method on the pattern object. So once you created a pattern object, just call the matcher on that particular object, and that will get you a matcher object, and then you can use that object to find the patterns in that particular text corpus. There is also a dedicated exception which is called pattern syntax exception, which will be thrown whenever you have written the regular expression syntax incorrectly. Like I said, it has its own language, so you need to write the expression in a way regular expressions are supposed to be written and supposed to be understood. I will touch upon that in a while, but that's the basic idea about the three classes. Now, when you would like to find a pattern, it can be a string pattern, it can be some characters, it can be some predefined characters, some quantifiers. You can also create subgroups within the regular expression. So like I said, there's a tons of functionality which is available in this particular concept, and we will just cover some of the relevant ones, or just run through some of these concepts, and then I will switch to a demonstration. For example, if we talk about the string literals, then you can do the string matching. For example, if you want to find this particular word or this pattern, this is just a text pattern, right? So if you would like to find this particular text pattern in the text string, then you can write this particular text pattern as a string pattern inside the pattern object. So that's about the string literals. Now let's move to some interesting ones like meta characters. And the meta characters are very interesting because they have a special meaning. For example, if you write your regular expression like this, where you say cat and then you say dot, then when you are applying this particular regular expression to find the match into a string, it is only going to find the match for cat. It is not going to find the match for cat dot, because dot is a meta character in regular expression. It has a special meaning. It does not mean dot, but it has a special meaning. And that special meaning basically means that even though the dot is not present, it will basically mean that after cat, it can be any character. So the meta character dot means any character, which is why you see this match succeeds, because it will search for this pattern, which it matches. And after that, it can be any character, it doesn't care. So even if it's S or D or whatever, it will say true because CAT was found a match. So dot means any character after the pattern you have specified. Similarly, there are a lot of other characters, special characters or meta characters, like the ones which have been listed here: question mark, star, plus, dot, and all of these have their own dedicated special meaning. They are not your normal arithmetic operators or other operators. They have their special meaning when you are dealing with meta characters. So do read about them in detail, and I will be using a bit of meta characters in the example as well. Then the character classes are also very interesting. Similar to the example which I told you before, if you want to find a particular string or a particular integer into a text corpus, then you can use the character class patterns. For example, you just put a square brackets and you write ABC. This means that it will try to find exactly ABC in the string. If you put a cap in front of ABC, then it will try to match any character or find any character except A, B, or C. So it's a negation. Similarly, if you specify small a to z and capital A to z, it means any character can be there between small case a to z and capital case a to z inclusive. Similarly, you can provide specific ranges like A through D or M through P. So only the characters which will match the union of this condition will be returning true, and rest of the if this particular pattern is violated, then you will get false. So similarly, you can build a lot of complex combinations and permutations with these special meta characters and character classes. Do read about these in detail if you are curious to know about it, and there is tons of materials available on internet which you can read about to learn more about. Similarly, there are predefined character classes as well. Dot is something which I already explained, which means any character. Then you can use /d to find a digit in a particular string or in a particular text corpus. /D is for non-digit, or you can use the classic negation condition as well. /s is for a white space character. /S is for a non-white space character. Word, non-word. So there are a lot of different examples. So I think by now you would have built a decent understanding of what I'm trying to tell you is that you can specify these patterns, compile them, and then use the matcher. So let's move to a very simple demonstration. It's not a complex example, but very simple example just to get the point across. So I'm creating a regex string here, and this is the pattern I've specified. I'm saying any character, star means any number of characters, so it can be anything here. Then the string, the pattern expects an alphabetical string or alphabetical section. After that, the alphabetical section should be followed by a numerical section. And after the numerical section, again, it can be any character. So this is my pattern. I create a simple string with this regex pattern. And like I mentioned in the documentation, you call pattern.compile to compile the regular expression. So I compile the regular expression, I get the pattern object. And after, again, as per the documentation, it said that you can call the matcher method on the pattern object to get a matcher object. So I say pattern.matcher and I provide my string on which I want to test it. So I've just put a random string where there are some integers, then there is some alphabets, and then again there are some integers. Once you have got the matcher object, just call matcher.find. This will return a boolean where you can test whether the matcher found a hit in the text corpus or not. If it found a match, the match found will be true. And if it didn't find the match, you will get a false value in this result. So with that understanding, let's run this program. So I get the output match found. Why did I get that? Because I said that start with anything. So it started with anything. I don't care what it is. It's an integer or any special character. I don't care. After that, there should be some alphabets. So there are some alphabets. And right after alphabets, there should be some numbers. So again, there are some numbers. And after that, there can be any character, 0 or more characters. So there is nothing here. That's why you see a match found. Let's do an interesting test here. Let me do this. I put A to Z again here. So now I'm saying start with anything, have alphabets, have numbers, and again after numbers, you should have some alphabet, which is not the case here because you start with something, you have alphabets, you have numbers, and after numbers, the string ends. There is nothing after that. So let's see what happens now. You get a match not found because this particular pattern, when got compiled and got applied on this particular string, did not find the string following the regex pattern which you have specified. So this is a very simple example to show you how you can build patterns. You can use groups concepts as well to group the patterns. It can get very, very complex and very, very nasty. So use them very wisely, very carefully. And do read about the documentation and other examples which I talked about to get more understanding and more comfortable with regex. Let's get started with NIO packages in Java. Now, let's first understand why do we need this package and where will we be using this package. Let's talk about the where first. You can use the NIO package to read from a file or write to a file. Now, let's talk about the why. Because the obvious question will be that we already have the IO package in Java, right? Where you can use the classes from that particular package to read from a file or write to a file. Then why do we need another package doing exactly the same thing as NIO? So the basic reason for launching the java.nio package was providing the multi-threading capabilities to the IO library. And we could not do this in the existing IO library because we had to probably rewrite and change the functionality of it. That's why Java created a new package called java.nio package. And this package is basically, if you understand what NIO means here, generally, as per the popular perception, it means non-blocking IO, that you don't want to block your threads while you're reading to a file or writing to a file. Classically, NIO meant networking IO, but as per the popular perception, people know it as non-blocking IO. So the basic idea is because whenever you are reading a file or writing to a file, the thread gets blocked until the whole file is written or until the whole file is read. So the NIO package provides an improvement over that. It provides an improvement in a way that you can read the file into a different thread, but at the same time, move on to another thread and write to a file. So you get this multi-threading capabilities and non-blocking capabilities out of the box from the classes provided by java.nio package. So that's the brief about this package. Now, some of the popular classes which you will be dealing with and some of the concepts which you need to know about NIO package are buffers and channels. This is probably the core concept of the whole NIO package of how channels and buffers work. So let's say you are trying to read something, then the read operation will be happening from the channel into the buffer. And similarly, the write operation will be happening in the reverse way, which means to the channel from the buffer. So that's how the buffer and channel work together, that whenever you are trying to write something, you have to first open a channel, create a buffer, and then you can read from the channel into the buffer. And similarly, when you're writing to the buffer, you again have to go via the channel route. So channel is that route basically. Buffer is basically just a plain container for the data, and channel is basically representing the connection to the entities which are capable of performing the IO operation. So think of channels as a pipe, a channel literally basically. If you understand the English meaning of channel, that's exactly what we mean by here, that it provides just a means to an end. It provides sort of a wire to the buffer. And then you also have selectors and selection keys classes, which together with selection channels work to provide the non-blocking IO functionality. There are some other APIs, interesting APIs as well, like charset and some more, but I will not go into the detail of that, because if we know about buffers and channels and selectors, then we will be able to figure out what exactly we would like to do with this. I would also like to talk a bit more about the buffer class. So if you go to the buffer classes operations, the popular operations, you will see there will be the read operation, which is for reading the files basically, or reading the content of the file. This works on the byte stream concept, first of all. So to read the bytes from the file, you will call the read method. There's also a very interesting method called flip, which I will be using, which makes a buffer ready for the new sequence of operations. So once you have done something and you want to, let's say you read a particular file and you have come to the end of the file. Now you would like to reset the buffer and go back to the beginning of the file. Then you can use the flip method for that particular piece to bring the current position back to the position to the zero index or to the starting of the file. So that's about read and flip, and we will have a look at some of the other methods. And there are a lot of interesting classes in this NIO package. Do read about the documentation and check out the other methods as well to learn more about this package. But the basics are, like I said, channels, buffers, some methods of the buffers, and there's also a path class which is used to basically provide a particular path to a directory, which I will not be covering in this example, but something good to know. So with that understanding, let's move to an example and understand how we can work around with this NIO package. So for that, I have prepared an example where I will be reading from a file and then writing to a file. So I have a main method here. The first section here basically is about reading from a file, and the second section is about writing to a file. So let's go through both of these sections one by one to understand what is happening. So in the read section, I use the file input stream class from the IO package. I'm still not using the paths class here, just to show you that both of them still can work together if you want to use the old constructs. So I use the same file input construct to read a file called source.txt, which is present at this particular location in my directory. And this source.txt has just a one line of text, nothing more. So I basically create the file input stream object, and then I create a channel. Because we are dealing with files, so you create a file channel. If you're dealing with network socket, then you might have a socket channel. So that's also something which you need to know about, that this NIO package is generic. It can be used for any kind of communication of reading and writing, not specifically to file handling. So we create a file channel object here by calling file input stream dot get channel. It's that simple. Once you call that, you will get a reference or the object basically of the file channel. Then the next thing is to create the buffer. Like I mentioned, that channels and the buffer are the two main tools through which you work with an NIO library. So we create a byte buffer and we allocate some starting size to it, just some threshold size. So you can put it any number which you think is practical for your file and for the use case. Here I've put just 1024 bytes or 1 megabyte, because my file is pretty small. So I just put that and initialize the read buffer, and then I call read channel dot read operation. So the file channel object you created, you just call the read method on this particular channel and supply the buffer. And then it is going to read the file via the channel into the buffer, and this read method is going to return a result to denote if the file was written successfully or not. I'm just printing a sys out here, just a bare bones sys out, nothing new here. So this section will be used to read a file. So let's see if I can read the file successfully, and then we'll move to the write section. So I go to run as Java application. Yeah, it says file read successfully, and it read 27 bytes. It means that there were a total of 27 bytes in my file, which had a single line of text. So it read all of that, and it completed the execution. Now let's move to the write section, and I can comment the read section because we have covered that. So here I'm again creating a file output stream object because I need to write something. So again, using the same construct of the IO package I have covered previously in the previous sessions. Once you have the file output stream object created, the next thing is to create a channel. So I again create a file channel, but this time it's the write channel. I again create a buffer, which is the write buffer, allocate some size to it. Then this is the string which I want to write to this particular file. So my destination file will be called dest.txt, will be present in this particular location. And this file should have this string written if this whole operation goes successfully. That's my end goal. So to do that, I say write buffer.put, and whatever string you have created, just call get bytes on it, and you get a bytes representation of the whole string. So that's what I've done here, because this put method expects byte, because if you go inside this, it expects a byte array. So that's what I'm supplying here. I'm providing the bytes array on the string by calling message.getByte, or any string object.getBytes will get your byte array. Once you've done that, then I'm calling the flip method. Remember, I talked about this flip method to basically reset the index. That's something which you need to do in this particular case, so that the index goes back to the initial position and the buffer can be written successfully to a file, to a channel basically. So once the buffer has completed its operation, then I can write the buffer to the channel. And once that is done, then if these operations went successfully, then I will see a file called dest.txt in this particular directory. Currently, there is no dest.txt in this directory. You can see there are just 3 files, but there is no dest.txt. So let's run this program. So it says file written successfully, which was the last sysout at line 28. But let's also see what is happening in the directory. So now I see a dest.txt popping up here. It's a 1 KB file. And if I double click on this, I see the same string which says this is a test string, which is the same string which I supplied here. So you can see you can use the NIO packages to do the file read and write, and much more than just read and write using the NIO package. But this is just to get the point across that this can be done using the NIO or the non-blocking IO package as well, so that you get maximum performance on your machine while you deal with file IO operations. Let's get started with Java Beans. So we have been creating Java classes and creating objects of those Java classes to work and manipulate, transfer data, call methods, create properties, etc. And Java Beans just use that as the groundwork to create a specification. First of all, let's understand that Java Beans is just a standard. It is just a specification which has been provided by Java to be followed while you are implementing production grade or enterprise grade applications. So it's just a pure specification, set of standards. If you want to read more about this, please go to this particular link which is written here. I mean, if you just Google Java Beans spec Oracle, then you will be able to find this particular link. You will see a download option here. If you go here, you will get these 2 specification documents option. So you can just accept the license agreement and click on this particular Beans 101 PDF, and you can read about the whole Java Beans specification. I've already downloaded this particular PDF, which is opened in this tab. And if you go to the TOC here, it's an official Sun Microsystem white paper basically. And if you read about this is going to explain the whole Java Beans API specifications. It's going to specify the core components of the Java Beans component architecture. So it's a specification. Let's understand that very well. If you go to the table of contents, let's go to the interesting one, which says what is exactly a bean or a Java bean. So a Java bean is basically a reusable software component that can be manipulated in any visual IDE like Eclipse or IntelliJ or NetBeans, etc. So technically, a Java bean is just a Java class. But that Java class should follow 3 main properties. The first property is that Java class should have getters and setters to access the properties. Second property is that Java class should have a public no argument constructor so that anybody can create an object of it. And third is that the Java class should implement serializable. The reason Java Beans specified these 3 conditions which I said, let's talk about the third one, where we are saying that it should be implementing serializable interface. Why is that? It's because a Java bean would be required to be exported between applications, may be required to be written to a database or to a file system, or to be converted into an XML or a JSON document, sent over the network, again being deserialized. So this will be moving across a lot because that's what we mean by reusable. Multiple different software components and applications might be reusing that bean again and again, and that bean needs to travel across. And to enable that, that bean has to be serializable, because if you can't serialize it, you just cannot transport that object to another application. It's just not possible. This is how Java has been. So that's why you need to implement serializable. You need to have a public no argument constructor, and you need to have getters and setters to access your properties. You can actually read more about this if you scroll down. It will also talk about the difference between beans and class libraries. Remember, not class, but class libraries. And here it explains what I just said, that a Java bean can have properties, it can have events, and it can have methods. So properties are nothing but the normal attributes which you create inside a Java class. Nothing fancy. The same attributes are named as properties. For example, you may have a foreground property, and then you can have a method which is just a normal Java method which can be called from other applications or from an environment. And by default, all of the beans public methods will be exported. By exported, I meant when you export this, when you serialize and export this object, all the beans public methods will be exported by default. But then a bean can choose to export only a subset of its methods if it wants to. A bean can also have events. And events basically provide a way for one object to notify other objects that something has happened. So something similar to the producer consumer example, or the producer consumer pattern, where you can notify other objects. Threads also have this particular pattern where a thread can notify other threads that it has completed its task, and other threads can start. So that's the property behind event, where something has occurred, and then the object can tell other objects that something has occurred, so that they can react to that particular event. So these are the three main traits, which are properties, events, and methods. You can read more about this particular white paper. I will not go into the details because it's a long white paper, but it's a very well written white paper which will give you a very good understanding of how Java Bean specification was written, what was the thought process behind it. So coming back to the code, if you want to just write it, it can be very simple to write. Just write any class and say implements serializable. So it will ask you to provide a serial version UUID. So you can write this here. Then you can create your attributes as normal private attributes. You can create public methods to access and manipulate these attributes in the forms of getters and setters. So these are the public methods to access and manipulate these attributes. Here we have a parameterized constructor which will not be required, or which should not be there when you're creating a Java bean. It should just be like this, because when we talk about the public no args constructor, as we discussed in the very first lectures, that you do not need to provide the default constructor. Java will automatically provide a default constructor for every class. So you don't need to write something like this. It's just not needed, because you can write it, but it has no value attached. It has no meaning, because this is something exact. This kind of code is already generated by Java compiler when it compiles this particular class. So a public default no argument constructor implementing serializable, private properties, and public methods. And you can have additional event methods as well, which I talked about just when we were going through the white paper. And that's all pretty much what a Java bean is. So you can see it's just a Java class, but some additional specifications which a Java class has to follow to be called as a Java bean.
So before we begin with what exactly is a Java API, we will understand what Java is. So basically, Java consists of two major components, that are Java Runtime Environment and Java Development Kit. So when we get into Java's API, we might want to dig a little deep into Java's Development Kit. So JDK consists of three more major components, that are the Java's compiler, Java Virtual Machine, and APIs. Now we will learn each one of them in a bit more detailed way. So at first we have the Java's compiler. So Java compiler can be defined as a software program that is designed to convert the high level, that is the user return or user readable code, into the computer readable code, that is the machine level or byte code. So this particular byte code will be transferred to the next state where we find the JVM. So what is JVM? So JVM is an abbreviation for Java's virtual machine. So Java's virtual machine is responsible for processing all the bytecodes and providing an output to the user. Next, we find our topic for today's discussion, that is the Java API. So just like Java's virtual machine and compiler, Java's APIs are the integral software packages that come with the JDK. The primary intention of API is to establish communications between different applications. So on my screen you can see a pictorial representation of Java API's architecture. So at first we have the Java's program on the topmost layer. So this particular segment will be having the user return program in user language. Followed by that, we have the interpreter, Java's API, and the Java's virtual machine, which are responsible for reading and compiling the Java's program. So at the last final level, we have the application hardware, which is responsible for interacting to the Java's program. So this is how the Java API's architecture looks like. Now followed by this, let's dive into the next topic. So in the next topic, we find the types of developers using various types of APIs for different jobs. So at first we have the open developers, next we have the internal developers, and at last we have the partner developers. Don't worry, we will understand each of these developers in a bit more detail and along with some examples for a better understanding. So at first we have the open developers. So open developers are used by top-end companies. So leading companies provide access to their APIs as open source through authentication via a unique secret key to keep track and ensure the legal usage. So basically what happens here is there might be some big companies like social media companies or some more other companies which provide the API they use for their applications as open source to the developers. So these open developers get access to their APIs through getting authentication. So they'll be creating a profile, they'll be providing the research details of their application, like what are they using that particular API for and other reasons to use those APIs. Then they get the unique secret key from the owner of that API. And that's done just to keep track that the API provided is not misused. So the open developers majorly include the B2C teams, and some of the major companies that provide the APIs for open developers are Twitter and Telnix. So one best example is the Twitter, where the Twitter provides Twitter API for the Twitter developer accounts for using that for any kind of developing things or some data science applications and much more. So followed by the open developers, next we have the internal developers. So you can consider internal developers as an organization. So the internal developers belong to a specific organization and work in a closed environment. These APIs run with a high security that can establish communication between the application and the application hardware. So only the internal developers, that is the developers belonging to that particular organization, have the access to that particular API. So this particular type of APIs run on a high security level. So internal developers majorly include B2C teams, B2B teams, A2A teams, and B2E teams. So some of the major companies that provide the internal APIs are Instagram, Google Mail, and Google Cloud Virtual Machines. Next we have the partner APIs. So the partner developers are similar or like internal developers, but the only difference is there is a collaboration between two or multiple companies. For example, consider yourself to be linked with a different company and you both wanted to create an application. So only you both can have access to that particular API that you're using to create your application. So partner developers majorly use the B2C teams, and the major companies providing the partner APIs are Microsoft and Finextra. So with this, we finish the first topic, that was what is API and who exactly uses it and for what purposes. Now we dive into the next segment where we learn the need for Java APIs. So why exactly we need Java APIs? Now Java APIs are used for multiple reasons. But the three most important reasons for which we use Java APIs are to streamline the operations, improvise the businesses, and finally create some powerful applications. We will discuss each one of them in a bit more detail. So the first one is to streamline operating procedures. We have multiple social media applications like Twitter, Facebook, WhatsApp, etc. Followed by that, we have multiple delivery applications such as Amazon, Flipkart. Then we have the F&B such as Zomato, Swiggy, etc. So all these applications are running smooth and hassle-free because of the significant improvement in the implementation of Java APIs. By using Java's APIs, users are provided with multiple options on the screen. So this kind of approach makes the functionality very simple and easy to use. Followed by this, the next important requirement is to improvise the business. Introducing APIs to the public leads many companies to release private data to generate new ideas, fixing existing bugs, and receive new ways to improvise operations. The Twitter developer account is an example for API that gives programmers private API keys to access Twitter data and develop applications. Followed by that, we have the third one, which is to create the powerful applications. Online banking has changed the industry forever, and APIs offer the customer's ability to manage their finances digitally with complete simplicity. So this is made possible only by the use of APIs. Now, followed by this, we will dive into the next topic where we understand the types of Java APIs. So basically, there are 4 different types of APIs in Java. They are public, private, partner, and composite. We will discuss each one of these APIs in a bit more detail. At first, we will deal with the public API. So what are public APIs? Public means open. So public or open APIs are Java's APIs that come with the JDK, and they do not have any strict restrictions about how developers use them. So followed by the public APIs, we have the private APIs. So the private or internal APIs are developed for a specific organization. These particular APIs will be accessible through the authentication by only the employees belonging to that particular organization. So followed by private APIs, we have the partner APIs. So similar to private APIs, even partner APIs are having some authentication process to use. So the only difference is here, instead of one organization, we might have 2 or multiple organizations, and the employees belonging to that particular group of organizations will be able to access the APIs and implement them or use them. Followed by partner APIs, we have the last one, which is the composite API. Composite APIs are microservices, and developers build them by combining several service APIs. Now that we have covered the different types of APIs, let us now discuss the categorization of Java APIs based on the services that different varieties of APIs in Java provide. So data and API services are another way to categorize Java APIs other than the previous type, which is the public, private, partner, and composite. APIs are also classified based on their data manipulation capabilities and the variety of services they offer. So this type of categorization has 4 different types, which are the internal API services, external API services, CRUD operations, and user interface services. We will understand each one of them in a bit more detail. At first, we will understand internal API services. Internal API services are developed to offer organizations services specific to that particular organizations. These services include only complex data operations and internal processes. Followed by internal API, we have the external API. External API are open source APIs that developers integrate into existing application or website. So internal APIs are something similar to private APIs, and external APIs are something similar to public APIs. Next, we have the CRUD operations. So CRUD APIs provide data manipulation operations over various data storage units such as software and service, that is SaaS, and relational database management systems such as RDBMS, using standard data storage unit connecting tools like database connectivity, that is JDBC, etc. Next, we have the user interface services. User interface service APIs are open source APIs that allow developers to build user interfaces for mobile devices, computers, and electronics. Now let's examine the rules and protocols that Java APIs must follow. So that brings us to API service protocols. The rules and protocols guide the different functionalities of Java APIs. So different APIs have different service protocols. Let's consider an example for RESTful API service protocol as an example. So for a typical RESTful API, developers must follow the following rules. For a typical RESTful API, developers must follow these rules: stateless, uniform interface, client server, cache, layer. No worries, we will discuss each one of these protocols in detail. First, we will discuss stateless. So what exactly is stateless? So since the RESTful API follows client-server architecture by default, it is recommended that RESTful API services to be stateless all the time. Next, we have the uniform interface. The entities in a RESTful API are server and clients. Applications that run on global scale need uniform client and server interface through Hypertext Transfer Protocol or HTTP, and Uniform Resource Identifiers URI will allocate the required resources. Next, we have the client server. The client-server model used in the RESTful API should be fault-tolerant. Both the client and server are expected to operate independently. The changes made at the client end should not affect the server, and vice versa. Next, we have the cache. Including a cache memory allows the application to record intermediate responses and run faster in real time. A RESTful API also includes the cache memory. And next, we have the layer. A RESTful API is built using layers. Layers of API are loosely coupled or independent from each other. Each layer contributes a different level of hierarchy and also supports encapsulation. Next, we will go through some frequently used APIs. So this is the list of most frequently used APIs in real time. So we have Web API, Facebook 4J, Twitter 4J, Android API, Java Advanced Imaging, Java Data Objects, and you can also see the acronyms for them in the right column. So some of them have no acronyms and some of them have acronyms. For example, we have Android API as Google, Java Advanced Imaging as JAI, Data Objects as JDO, etc. So moving into the next slide, we have a few more APIs. So we have RESTful APIs, Java Media Frameworks, Java Persistent APIs, Java Speech API, Java 3D, Java USB for Windows, etc. And similarly on the right column, we have their acronyms. So for Java Media Frameworks, we have JMF. For RESTful APIs, we have nothing. And Java 3D, we have J3D, Java Speech API as JS API, and few others. So followed by this, we will advance into the next topic where we will discuss about the advantages of using Java's APIs. Now, using Java's APIs will help you with multiple advantages. Now we will discuss the most important advantages of using Java's APIs. So the first one, we have the extensive SQL support. APIs in Java enable a wide range of SQL support services in users' applications through a component-based interface. Next, we have applications. APIs in Java provide effortless access to all of an application's major software components and easily deliver services. Next, we have efficiency. Java's APIs are highly efficient because they enable rapid application development. Also, the data that the application generates is always available online. Next, we have the automation. API allows computers to automatically upload, download, update, and delete data automatically without human interaction. Followed by that, we have integration. Java APIs can integrate to any application and website and provide a fluidic experience with dynamic data delivery. Followed by that, we have scope. Java's APIs make websites, application, and information available to a wide range of users and audience. Followed by that, we have customization. Java APIs enable developers and businesses to build applications that personalize user interface and data. And finally, we have the adaptability. Java APIs are highly flexible and adaptable because they can easily accept feature updates and change to frameworks and operating systems.
Let's get started with Spring Framework. So Spring Framework is the most popular web application framework available out there today. And all of the big companies from Netflix to whatnot use Spring Framework to build the modern day Java applications. So before we go any further, let's understand why do we need a framework. So let's understand this with the help of a diagram. So let me just open a blank paint page and let me show you what I mean by a framework and why do we need this. So we built simple applications so far, But if you have to build a enterprise grade web application, you will have a front end probably where you will have what you see in the browser. So you will have the HTML, the JavaScript, or any other Java enterprise edition classes like JSP, Servlet, etc. Then you will have a backend where your Java classes are present, which contains the business logic. So the business logic. And then you have a database where you store the basically the whole data. So you have these three different layers. We also call this a three-tier architecture. So you cannot build all of this by just using the core Java classes, which we talked about. You need to do more integrations. You need to use more different programming languages and concepts to build a complete enterprise grade application. And if you try to build all of this by yourself, then it's going to take a lot of time and a lot of effort. That's why we have frameworks which basically provide the structure to create these three layers. So that's why we have these frameworks. And in the frameworks, Spring is the most popular framework. It provides the structure to write all these three layers. One of the reasons I did not talk about the Java Enterprise Edition technologies like servlets and GSPs because nobody works on them today. Even if you learn about servlet, it's good to know the conceptual overview of servlets, but nobody today builds applications on GSPs and servlets. That's the reason I did not talk about it, because today we have sophisticated front-end frameworks like AngularJS or React.js or Ember.js and whatnot, and it is iterating at a very faster speed. So there is literally practically no need for a Java developer today to learn about GSP, because I can bet you on that. You can take it in written from me. Nobody is going to build the GSP based applications in 2021. Everybody is going to use some sort of front-end framework to build that. And then you have a backend. In the backend, you have the exact core Java classes like I just explained. So you will be using the Java beans, and you will be basically using the pure Java concepts of collections and etc. to write the backend logic using the Java classes. And then you will need a JDBC connection to write to a database as well. So you would need a database as well. And Spring provides connectors and specifications to support all of these three layers. That's the reason. So generally, when you talk about a web application, let's talk about web application because Java primarily is used in web applications. So in a web application, you basically see a browser window where you load a particular page. But what happens behind the scene? This browser has some HTML and some JS maybe, and this code is basically calling some endpoint. This endpoint is present in the backend layer. So this endpoint is present in the backend layer. That endpoint transfers the control to the business layer where you have your core business logic written. And then the business layer transfers the control to the data layer, or some people also call it DAO layer. This DAO layer then talks to the database. That's how a web application works. And that's the architecture you will mostly be following whenever you are building any enterprise grade application in any organization. So Spring provides support for all of these parts. This obviously is written by Angular and React and other frameworks, but this whole section is basically presented or supported by Spring. So with that, let's understand a bit more about Spring Framework. So if you go to the Spring official website, it talks about some of the value propositions. Spring is used heavily. Like I said, it's used everywhere. It's very flexible framework. There are a couple of concepts which Spring provides, which is around inversion of control and dependency injection. And I will talk about these concepts in a while when we'll talk more about the Spring's components. It makes it's quite productive and quite fast as well. So it's very fast to build application on Spring. It has a whole dedicated security module as well. So it's quite secure by design. And the Spring community is huge. So you can find a lot of support on the internet. Let's learn a bit more about the Spring's core components or core technologies. So if you talk about the Spring's core components, these are the Spring's core components. So you have a testing module, you have a core module. First of all, inside the in the core components, you have a core module which has IOC containers, resources, events. I'll talk a bit about that. It has its own testing component, so it provides very good support for testing applications. It has a data access component. The data access component is used to provide connections, utilities to the database, because like I mentioned, your application will be talking to the database, and Spring provides a complete dedicated component to be used whenever you are talking to the database. It also provides a web servlet component to provide support for Spring MVC, which I will be covering in the next session, WebSockets and Stomp and messaging frameworks, etc. It also supports reactive or asynchronous programming if you want to do that. It provides a lot of integration capabilities in the integration modules if you want to do JMS or JMX or email or task scheduling, etc. And it also provides language support to support internationalization of the applications. So it has a lot of different components, but we will focus on this core component, which is of the interest here. So let's talk about that. The first thing which you need to know about Spring is its support for inversion of control, and it provides that support by creating an inversion of control container. What do we mean by inversion of control? The basic idea is, let me take any random example and I will be able to communicate the idea behind this. So let's go to any simple example which I have already covered. Let's go to method calling, for example. So we had a student class. We created a student class, simple student class, 3 properties, constructor and public getters and setters. And then I created a main class and I initialized the student object. So the responsibility of creating the student object lies with the student class itself. Student class have to be explicitly initialized to be having an object of the student. So this creates a problem because when you're dealing with enterprise grade frameworks, you might need to create a lot of objects on the fly whenever the endpoint is talking to the business layer. If I take the reference of this architecture, if the endpoint is talking to the business layer classes are talking to the data access layer classes. So when the business layer classes needs to talk to the data access layer classes, the data access layer classes needs to have an object because the communication happens between objects only. So who creates those objects? If every time the data access object has been called, and if we pass that responsibility to the DAO class to create the object, or every time the endpoint talks to the business class, we ask the business layer to create the objects, it becomes a lot of painful process because every time you will be doing this new student everywhere, you need a student object, which is very painful process. So what Spring says, it says, okay, invert the control of creating the object. So let's not give the responsibility of creating the object to the class. Let's give that responsibility to the framework. So the framework will be responsible for creating the objects of a class, and it's not the class who will be responsible for creating its own objects. So generally, outside the framework, a class is responsible for creating its object, but with Spring inverts this responsibility. That's why we call it inversion of control. The control is inverted, it's reversed, and now it's the framework's responsibility to create the objects. You will also hear about a concept called dependency injection a lot in context of IOC, and dependency injection is an implementation of the IOC concept. So using Spring's dependency injection mechanism, you can inject the object of any class into any class. Once you do that, Spring dependency is going to use the inversion of control concept and create the object. That's about IOC and DI, or dependency injection. Then the other modules like resources will provide a way to refer different files in properties if you want to. Then you have a validation module as well, which will provide different validation constructs, because once you receive the data, you might need to run a lot of validation, right? And writing the validation by yourself can be very painful. So it provides a validation framework as well by providing the validator interface. You can use this particular framework to write the validation rules, checking the name not empty, etc. Similarly, it also supports an expression language if you want to use that. So the expression language support is wide, very wide in fact. You can create an expression parser and you can do the expression language evaluation using the Spring expression language. Similarly, it also provides support for aspect-oriented programming. Now, again, all these concepts of validation and Spring expression language and resource support, you probably would need hours of reading to learn about these concepts, and I'm just running through them just to tell you about these concepts. And do read about why do you need resources, why do you want to do validation, why do you need an expression language, what is aspect oriented programming. Read about all of those concepts because they are not related to Java. They are generic concepts which will be applicable to any programming language. So any enterprise application you build in any programming language, you would need to do the validation, you would need to do the resource reference management, you would need to have an expression language, you would need to have aspect-oriented programming support. So this is just to tell you that Java does provide an AOP or aspect-oriented programming support as well, and it has a lot of APIs available for that. Along with that, it also provides very good logging capabilities because you definitely need to log all the actions which the framework or your objects are taking. So this was a very quick lightning overview about Spring. I understand it's not possible to cover all the concept of a framework as sophisticated and as smart as Spring in a 10 to 15 minutes lecture. So treat this as an introduction session. And like I said, read more about all of these components. I just explained the core because this is sort of the main building block of Spring framework. And then you have other supporting components as well. So do check out the documentation. There are tons of examples available. In fact, in the Spring's official website itself, if you go to the Spring Guide section, if you go to the Learn and you go to the Guide section, there are awesome getting started and topical guides and tutorials available. So for example, how to build a RESTful web service, how to schedule tasks, how to consume a RESTful web service, how to build a simple Java project with Maven, how to upload files with Spring, how to do messaging with Redis, which is basically a caching framework, how to do messaging using Spring to RabbitMQ. RabbitMQ is a messaging framework. So there are tons of examples available here. Very good documentation and very robust documentation. Do check out the examples to learn more about this.
Let's get started with MVC and the implementation of MVC using Spring. So before we go any further, let's first understand what do we mean by an MVC application. So in the previous lectures, I discussed about the 3-tier application where you had a presentation layer, you had a business layer, and then you had a database layer, which is talking to the database. And that's how we built a 3-tier application, which can also evolve into an N-tier application. But when the web development started, the most popular concept which came out was MVC. M stands for model, V stands for view, and C stands for controller. So the idea was that these 3 components together can render a web application. And how they render the web application is basically that the controller is going to receive the request which is coming from the web browser. Then the controller will have the knowledge of where the business logic for that particular request will be residing. So the controller is going to invoke the model, the corresponding model which is required to execute the business logic of the request. And the controller will also have the knowledge of what response page to be sent back to the user. So we are talking about the response page here, not response. Remember that, because it's a web application. So the model view controller architecture basically was designed to keep in mind that you have a web application where a request is coming from, and you need to process some business logic, and then you need to return back with a page response, which is going to be displayed on the web browser of the client machine. So that's why we had these 3 components as model, view, and controller. Controller taking up the request, then finding the right model for it, which can execute the business logic, and then also finding the right view for it, which can render the business logic processed by the model. So that's a quick overview about model view controller or MVC architecture. Do read about it in detail to understand how this works. But like I mentioned, that MVC, the most popular MVC implementation is provided by Spring. Spring is the most popular MVC framework, and the way Spring implements it is something which I have drawn already here. So let's understand how this works. So first, the request comes from the web browser, and Spring has a very first welcome servlet, which is called dispatcher servlet. Any request which is coming to the Spring enabled web application will first hit dispatcher servlet. And once the request comes to the dispatcher servlet has all the knowledge of all the controllers, of all the view resolvers, which I will talk about in a while, and of all the views as well. It also has knowledge about handler mappings, which again I will just discuss now. So the basic premise is that dispatcher servlet is the component which has knowledge about literally everything happening in your application, and that's why dispatcher servlet is the first servlet or the first component which receives your web request. So once the request comes here, first of all it looks at the path and finds out the right handler for it, the right controller for it. And the way it does that by using the handler mapping component or handler mapping logic, which is provided out of the box by Spring Framework. So the handler mapping logic will tell the dispatcher servlet which particular controller is going to process the request which is coming, because every request will have a different controller return. So whatever the type of request is, whatever the path of the request is, based on that, the dispatcher servlet is going to find a particular controller. Once the controller is found, like I mentioned earlier, the controller will have knowledge about the right model to invoke for that particular request. Model is nothing but basically a Java class holding the business logic for this particular request. So it will invoke that Java class and get all the business logic processed, and then it is going to return a model and view object. View is here simply pointing to the UI response which you are going to send back to the user. It can be a JSP page, it can be an HTML page, it can be any other view technology. So anything which is used to render a web application on a web page is view, and controller is going to send both the model and view information back to the dispatcher servlet. The dispatcher servlet will take the view part of it and go to another component which is again provided by Spring, which is called view resolver. The view resolver will have the knowledge to see which particular actual JSP or template to invoke for the view value coming from the controller. So based on the value which is returned by the controller, a view resolver is going to return the right page mapping. And once the dispatcher servlet knows the page mapping, it is just going to invoke that page by calling the view component. So dispatcher servlet, handler mapping, controller, view resolver, and view, these 5 components together help render a web MVC application in the Spring framework. So that was about the theory of how Spring works. Now let's move on to an example to understand how this works in action. So here I have already built a Spring MVC application, and if you're wondering how to build that, there's an easy way to do that using Spring Initializer. And that's also the recommended way. Actually, if you go to the documentation of Spring, you will see that it recommends creating a new project from scratch using the Spring Initializer utility, which is provided by Spring out of the box. So just go to a web browser and type start.spring.io. You will get this page where you can specify what type of project you want to create. So it is going to create the basic skeleton for any Spring application automatically for you. It's probably, like I said, it's probably the fastest way to get started with Spring. So we will choose a Maven project. Maven is again a dependency management tool which is used to download any kind of jars for your application. So we are going to use a Maven project and we want to create a skeleton for a Java application. We are going to use the latest released version of Spring or Spring Boot, which is 2.4.2. It says Spring Boot here, but don't get confused with it. We are going to use just the MVC classes and not the Spring Boot specific logic yet. Then you provide your group artifact ID and the name for your jar. You provide a description. You can provide a welcome package name, whatever suits you. And then how you would like to run your application. Whether you would like to package your application as a jar file, which is a Java archive, or you would like to run it as a web archive, which is a WAR file. So you can choose either packaging mode, and it is going to add appropriate dependencies inside the project to support the packaging of jar or the packaging of WAR. Then you can also choose the Java version. So you can see there are 3 Java versions listed here, which are 8, 11, and 15. So whichever Java version you are working on, you can choose that particular version. And once you have set everything, just hit generate. Once you do that, it is going to create a project here, and then you can import this project just as a normal project inside the Eclipse IDE. And that's exactly what I've done for this initial project, which is showing a very basic hello world sort of example for how Spring MVC will work. So this whole structure will automatically be created for you. And like I said, it was a Maven project, and in every Maven project, you will have a pom.xml. If I double click on this, it is going to open this XML and it will list down all the dependencies which my project needs to have. Let's understand the dependencies as well. So this project is currently using the properties of 1.8, but that's fine. You can obviously definitely change this value. I just kept it as 1.8 for now because I'm not using any new functionality yet. In the dependencies section, you will see all the dependencies or all the jars which are required by the Spring application to run successfully. The first dependency we see here is about DyMyLeaf, and DyMyLeaf basically is a view technology similar to JSP or similar to servlets technically, where you can use this DyMyLeaf templates, which are basically just HTMLs with some dynamic values, and you can use these DyMyLeaf templates to render web pages for your Spring MVC application. if you want to use some other view technology, you need to include the dependency of that view technology here instead of the MyLeaf. So that's about that. Then you need to include the Spring Boot Starter Web. The Spring Boot Starter Web is going to enable your application to become a web application. Then this is basically a good to have dependency which you can have in your project, which will help you deploy the project at runtime automatically without restarting the server, because the web application will be running on a server, on a web server basically, or an application server technically, because it needs to run somewhere so that so that clients can access it. That's how a web client architecture works, or the server client architecture works. So this dependency will allow you to deploy changes dynamically at runtime without restarting the server. Then this dependency is for tests, if you're writing any unit tests. And then you have a plugin which will allow to run this particular project with a single command, which we will see in a while. So that's about the dependency tour. Now let's look at what is in the src main Java. In the src main Java, I just have two classes. One is the main class, which will have a public static void main method, and this is the entry point of the Spring application. And then I have a controller class. I already talked about what controller is, but I will come back to that in a while. Let's understand the rest of the files as well. The next one is src main resources, where you will have your view technology data available. Like I mentioned, it is using the MyLeaf templates currently, and basically, like I said, they are technically HTMLs with some dynamic data. So I've created a templates folder under src main resources, which will automatically be generated by Spring Initializer. And then under templates, I've placed an HTML file. It's a pure HTML file, with the only difference is this value. So this is what the dynamic value means, which is supported by the MyLeaf templates. Otherwise, this is pure HTML. It's just a paragraph with a header, and this is the dynamic value which I'm populating. It also has application.properties, which has nothing, but you can use this particular file to supply environment specific properties for the development environment or the testing environment or the real production environment. If you have any unit tests, those will go here under src test Java, and this is the system library already provided, supported by Eclipse itself. And I already talked about the pom.xml. You also see a couple of more files created by Spring Boot. If you want to use that, you can use that to run the program from the command line as a utility. Otherwise, you can just use mvn spring boot command, which I will show you in a while. There's also a Gradle folder which you can ignore. Probably we don't need this because we are just using Maven and we are not using Gradle. Gradle is another dependency management tool very, very similar to Maven. So you can ignore this folder right now. So that's the structure. And now let's come back to the controllers. Remember, I told you that controllers are the ones which receive the request. So from the dispatcher servlet, which I talked about here, after the dispatcher servlet, the request comes to the controller. So once you hit a particular URL, then you need to create a controller for that URL mapping. Remember that you need to create a controller for almost every URL mapping you are having in your application. There should be some mapping to some controller somewhere. So I've created a greeting controller, and the way you specify or you make a simple class as a controller is by putting the @controller annotation. This is the annotation which is supported by Spring, and you can put this annotation on top of any class, and that class will be treated as controller by Spring. And the moment you put this class will also be registered with the dispatcher servlet. And like I mentioned, the controller's main purpose is to receive the requests, the web requests which are coming from the client. And the way you can receive the requests to a controller by providing the exact URL mapping. So if somebody runs this web application and says /greeting, then this particular method should get invoked. And how you define that is with the get mapping annotation. Use the get mapping annotation to provide the URL path. Whenever somebody invokes this URL path, this method would be getting called. And when this method is getting called, at that same time, this URL can also accept some query parameters. We call that as request parameters in the Spring language. So you can use the request parameters as an annotation to provide a placeholder for the variable for which the value will be supplied in the URL. So /greeting, if you call this URL something like this, then it will work because you have a variable called name which is being parsed as a query string because you have used the request param annotation. So we'll see an example of that when once we run this application and how we can supply the query string. But you use the request param annotation to supply the query string parameters to the URL. You can mention if the parameter is mandatory or non-mandatory. If the required equal to true was there, then this parameter would be mandatory. You can also supply a default value if the client is not providing this query parameter at all. Would you like to set any default value? If yes, you can supply that default value here. And then you just give a placeholder name like I said. Then the second argument which your methods which are intercepting the request should have is the model argument. And remember I told you that the controller will have or should have the knowledge about the model, and from here that knowledge comes. This particular method will expect you to provide a model argument as well. So if somebody calls this application and provides the URLs with /greeting, this particular method will get invoked, and then the code inside this method will be getting executed. So it's a very simple code right now, but this is where your whole logic will go. Remember that. But here I'm just saying model.add attribute name with the value which is coming from the query string parameter. That's all I'm doing here. And remember I told you that the model will hold the business logic. So here this is the business logic where whatever query string parameter which is coming from the request param, I'm capturing that and I'm adding that value with the variable name in the attributes of the model. So my model is set, and after that I need to return the view so that this particular file name will be intercepted by the view resolver here. If you remember, we talked about the view resolver. So when we return greetings as a string, that string goes here, and then dispatcher servlet asks the view resolver to find a particular HTML matching with this particular text. So view resolver is going to look at under src main resources /templates to see if there is a file with the name greeting available or not. Since we have that file available, the Spring is going to render this particular file supplying the model attribute value name. Now remember, the greeting.html had the exact same variable name. So this variable name should exactly match with this variable name here. If you make a mistake here, this is not going to work because the model is holding the business logic, and I'm printing that business logic inside the view using the die-my-leaf template syntax, which is $curly braces. So whenever you have to print any variable or a model attribute or any runtime value inside a die-my-leaf template, then you need to use the $curly braces syntax to do that. So that was about a quick overview of how this application is written right now, and that's all the code is here. Now it's time to run this application. So one of the simplest way to run this application would be to provide a Spring run configuration here for the Spring application, or you can choose another way, which is to first have a look at the Spring Web Content application, which is the entry point. So once your application boots up, this is the first line of code which is going to get executed. And to make sure that this code works, make sure that you have the @Spring Boot application annotation on top of the entry point class. So this is sort of the mandate which Spring will force you to put in front of the or on top of the entry point class to treat this class as the first entry point when you run the project. So to run the project, what we will do, that we will just go to the command line and we will say mvn spring boot run. So let's do that, and let me open the terminal for that. So I have opened a git bash prompt here. You can also open the classic Windows terminal, but this is something which Git installs by default if you install Git on your system. It's pretty much exactly the same. It's just more Unix-like, but it's also just a simple terminal shell utility to access your file system. So I have gone to the project which we were working with in the Eclipse IDE, and this is the path of the project. So once you reach to the path, what you would like to run is just say mvn spring-boot:run. That's it, and you hit enter. Once you write mvn spring-boot:run, you will see lot of code, lot of logs here where it is going to compile all the Java classes, run any tests if there are any, and then it is going to start the web content application, you can see. And once the application is started, you will get this message that everything is run. One of the interesting thing which you can see here is that it is also spinning up an application server automatically for you, and that application server here which is being used by Spring is Apache Tomcat. Technically, Apache Tomcat is a servlet container and it's not a full-fledged application server, but just to get the point across, you can use Apache Tomcat as an application server which is being used here out of the box by Spring. If you don't want to use Apache Tomcat and you want to use something else, you can do that as well. So now everything is ready and we can now execute the application to observe the output. So for that, let me open a fresh browser window so that we don't get any cached response. And now I can just type localhost 8080. And if I hit enter, I get a white label error page because there is no home page for Tomcat defined, but there is a home page for my application defined. In fact, let's try to access the URL which we wrote in the greeting controller. The URL was /greeting. So let's copy this and let's put this here. So localhost 8080 /greeting. And if I hit enter, I get the message hello world. Let me just zoom this in a bit so that you can see. So you will see this hello world message here by putting this URL. Why do we see hello world? Let's go back to the controller. So when you call this URL, this greeting controller got invoked. Since we did not provide any query string parameter, the default value, which was world, was picked up, and this world value was stored in the name variable, and the name variable was added as an attribute to the model. And then we were using the greeting.html and we were printing the name variable. Since the name variable was holding the value world, so the message came as hello world with an exclamation, and that's the output which we see here. Now let's try to supply the query string parameter. The way you do that is provide a question mark, provide the key of the query string parameter and the value you want to put here. So let's put simply code as a value and hit enter. So now the message got changed and now it says hello simply code. So what happened here is that whatever query string parameter we supplied, that got passed here as part of the request param, and the value of simply code got stored in this name key and in turn in this name variable, and then I added the same value into another name attribute and added that attribute to the model. So now this name here is storing the value simply code, and then all the things work exactly is the same as I just described. It goes to greeting.html and it prints whatever is stored in the name attribute coming from the model. Let's get started with Spring Boot and how we can build a simple application using Spring Boot. Before we go further, let's understand why we need Spring Boot. And the basic idea of Spring Boot is to build RESTful web services. If you want to know more about what are RESTful services, please you can read about the RESTful concept as a concept. What does REST stand for? But the basic idea is that if you are accessing anything over HTTP, then that particular component can be built as a RESTful component. And Spring Boot is the most popular choice for building RESTful web services today, and even in fact microservices, which you might have heard about. So you can build microservices which also run on HTTPs using Spring Boot. So what I'm showing you right now is the official guide of Spring, which you can use to build an application with Spring Boot. It will list down all the requisites which you need in terms of the JDK installations, Maven, and how to complete this guide, etc. etc. You can again use the same Spring initializer which I talked about in the previous session. You can use this to generate a Spring Boot project for you specifically. So all those options are available here. So I've already done that and I'm not going to repeat what I just did in the previous session, and will directly jump to an IDE where I have created a sample Spring Boot application. And the structure here, you can see the structure would look very similar with one change, that in the previous example when we were dealing with MVC, we had an src main resources folder, and that src main resources folder was having all the web components or the HTMLs. But since in RESTful web services you do not render the HTML, but you just send back the response. The response body can be pure XML or it can be pure JSON, but you do not send back an view, and that's the main difference between Spring MVC and Spring Boot. That in Spring MVC, you are required to return a view technology. Like in the previous session, we sent a thy_my_life template, which is basically in HTML. You can also return a JSP. But with Spring Boot, you do not deal with the view technology. And that's the world we are living in today. When you write Spring Boot, you do not have to worry about how this is going to be rendered on the web page, whether it is going to be rendered using HTML or whatnot. What you need to take care of using Spring Boot is to return the right response body, the exact text of the response, and that's it. So with that in mind, the Spring Boot was born, and the structure, apart from that, the structure would look very similar. There's a pom.xml here, which will provide all the list of jars and dependencies which are required for this particular project. So you can see all the dependencies here, pretty much the similar ones. We have a starter web, we have a starter test, and we have a Spring Boot Maven plugin. And we have an application file, which is the entry point, again having a public static void main method. So you need to put the @Spring Boot application at the top of the class to make it an entry point. If you don't do this, Spring Boot will not run this class, and Spring Boot will even not run your application. So what we are doing as part of this example, that we are just printing all the beans which are provided by Spring. That's all we are doing. Like I said, it's a very lightweight and an introductory session, so we will keep the logics to minimum. And I'm just getting all the bean definitions, sorting the bean definitions, and just printing them one by one. How do you get the bean definition? You get that with this application context class, which is returned when you run the application. And how you run the application is basically using this line where you say Spring application dot run, and you supply application dot class with any command line arguments which you might want to use. Once you do this, it is going to return an application context object to you, and the application context object can be used to get all the bean definitions by calling this method which says get bean definition names. So that's the basic logic which is being run in the main class. Now we also have a controller, but this time it's not a web controller, but it's a REST controller. So you see, in the previous example, we just had written something like this. It was just a pure controller. But here we have become more specific. We are saying that, hey, this is not a simple MVC controller, but this is a Spring Boot controller, or technically a REST controller. So Spring provides a separate annotation for that, which is @REST controller. So you write that particular annotation on the top of the controller class which you are creating, and then you provide a request mapping similar to what we did in Spring MVC. But while you return it, you do not return a view technology. You just return the raw response. Here I'm just returning a string, but you can return a JSON object, you can return an XML object, or whatever you want to, but not a view technology. That's what I'm doing. Like you can see, there's literally nothing I'm doing in this. It's just a simple string return statement which I've printed here. And that's all the code I have right now here. I just have these two classes. Okay, so that was all about what I have written in the project, and now it's time to run the project. So I have just reached to the location inside my terminal where the project's pom.xml was present, and if I just do an ls, you will see that there is a pom.xml available here, and all the code directories are also available here. So now I will just run this application, and to run this application I'm just going to type mvn spring-boot:run and hit enter. Once I do that, the Spring Boot application is going to get started. And let's go back to the controller and actually the main endpoint and see what we were doing there. I did a sysout here which said let's inspect the beans provided by Spring Boot, and then I was printing all the bean names. And if I go back to the output, I will see the same line being written here, which was around let's inspect the beans. So you can see that message which says let's inspect the beans provided by Spring Boot, and then all the beans which are available in the application context are printed here. So that's the basic idea which I want to give you, that you can actually build a Spring Boot application, and you can write your REST controllers, return a string body from it, and once this is run, then you can also run your application from the web browser as well. So let's try to hit that particular URL which I wrote here. So the URL of hello country. So for that, let me just open a new Cognito window, and our application is already running. So if I just say http localhost 8080/, I get this message here which says greetings from Spring Boot, and this is the message which we were sending from the REST controller. So this validates our understanding that we can invoke a REST controller, which is a Spring Boot REST controller, via the same method, but this time we are not getting an HTML, but we are just returning this particular string. Now you can use this string in any ways you want, so it depends upon the consumer. So that's all I want to cover as part of the Spring Boot. Now Spring Boot is a huge topic, and we can spend hours and hours talking about Spring Boot, but since this is more of an introductory session, so I just wanted the concept to get introduced, and remember the value proposition of why you would need Spring Boot. The basic idea is to build RESTful web services or build RESTful microservices. That's the basic idea behind using Spring Boot in your applications. And also remember the difference between Web MVC, Spring MVC application and Spring Boot application. Spring MVC is for building web application. Spring Boot is for building RESTful applications, which might not have a web interface integrated with them at that moment. So that's all I want to cover for this particular session. And in the next session, we are going to have a look at an advanced Java project using some of the concepts which we might have learned during this whole journey. And that would be the last session of this particular tutorial series.
Let's get started with a demo of a project which is using Spring Boot to build a RESTful web service. So a RESTful web service is nothing but any endpoint which you can access or you can consume the data from via an HTTP layer or via a simply a web layer, because most of the web traffic which we deal with is built on HTTP. So to take an example, if you go to any website where you sometimes see on the top right corner, you see today's weather. So how is that today's weather coming in? It's coming in via a REST web service. The website which you are accessing is basically hitting an HTTP endpoint, which is where the weather application is sitting, and it asks for the weather data, and the REST web application just returns the data, and that's how the website is able to show you the current weather. So RESTful web services are everywhere, and they are the most popular way to build applications today, where you just build your RESTful web service and you expose an HTTP URL. And then the consumers need to just access that HTTP URL to consume the data from your application. And you see, this makes it very easy because there is no data type restrictions. There is no tight coupling here. It's just an HTTP endpoint. So that's the basic idea. And we will look at a project where we will be using Spring Boot to build a RESTful web service. And then we will try to run that web service to save some data and also to return some data. So here on the package explorer, you see I have created a project called REST service. And let's just walk through the structure of it, and then we'll go into the details of it. So we have an src main Java where I have a package and I have a bunch of classes here. And before we go to the classes, let's first also access the dependency file, because every project needs some dependencies, some jars to execute it. For example, Spring itself is basically a jar. So you need to include the Spring jar in your project so that your project can become a Spring project. And there are generally two dependency tools. One is Maven and one is Gradle. In this particular project, I am using Maven dependency tool for downloading and managing the dependencies which are needed to run this project successfully. And the way you will find if it's a Maven project or if it's a Gradle project, for a Maven project, you will see a file called pom.xml. And if it's a Gradle project, you will see a .gradle file. That's how you can spot whether the project is using Maven for dependency management or it is using Gradle for dependency management. So let's open the pom.xml. Since it's an XML file, it will be a bit verbose, but if you just read it piece by piece, it will become easier to understand. First of all, since this is a Spring project, I need to include the parent dependency, which brings a lot of good defaults, sensible defaults from Spring Boot automatically. And this is the jar name. This is the artifact ID, which is Spring Boot starter parent. So any Spring Boot project you are starting, do include this parent. This parent is basically bringing all the dependencies from some other jar, and you can make your project as a child of this particular parent. So all the Spring Boot projects have this as a parent as a standard practice. After that, you provide your own details in terms of what is the package name, how do you want to see the jar name, and what is the jar actual name, what is the jar version, etc., etc. You also set the minimum required Java version to run this application. And then in the dependency sections, you provide all the jars which you need to run your project successfully, both compile and run your project successfully. So we added the Spring Boot starter web dependency, which basically brings all the dependencies around making a controller or making a repository, context component scan. All the interesting features which Spring provides get wrapped up inside the Spring Boot Starter jar. And you can actually go to the MVN repository and have a look at what all classes it provides. It's a lot of classes. So I'm just telling you in a brief that it provides all the RESTful functionality. Then you have the next dependency as Spring Boot Starter Data JPA, which is going to enable this project to also have a database. And if it has a database, then you need Java to talk to the database. And the way Spring suggests to talk to the database is via using the Spring Boot Data JPA library. We will see how this library can be used, but basically this provides ways to represent your Java object in the database. And then you need to also add the actual dependency of the database. And in this case, we are using an in-memory H2 database. So I'm not using an external database like MySQL or Oracle or PostgreSQL, because that will just make more configurations more complicated. I just wanted to keep it simple. And generally, in this H2 database, you can easily access by adding this dependency, and it will be an in-memory database created for you. Then I've also added Spring Boot Starter test here, which will be used whenever you're writing unit tests, and you must write unit test for your project. And then we need to add the plugin so that Spring Boot can run this project. That's all I have in the pom.xml. Now let's move to the interesting part, the Java section part. Let's start from the main class. So this is how the main class looks like, where you just create any name with the class, and then you add a public static void main method. Inside the public static void main method, you call Spring application dot run. And this run method is basically going to run your application, and you just provide the same class name which you just wrote here. So you just say dot class. And if you're supplying any command line arguments, it can interpret that command line arguments as well if you want. So you'd always need an entry point in an application, and this is the entry point which Spring Boot supports. And this is, if you see this code, this is just normal code. To make Spring be aware about this class being treated as an entry point, you need to add @Spring Boot application annotation on top of the class. This is one of the annotation which is coming directly from the Spring Boot library. You can see this import. So once you add this, then only Spring will be able to treat this class as an entry point. Otherwise, Spring doesn't know where to start from. So when you run Spring, it will try to find a class with an annotation Spring Boot application. And then inside the class, it will try to find a public static void main method. And once it has found both of them, then it will just run the application. So it's very simple, nothing fancy here. And what we are dealing with here is a student object. So we will try to insert a student object, and we will try to retrieve the student object. So if you ignore these annotations which I've added, it's just a pure POJO. It's just a plain old Java object. You create a student class. Let's ignore this field as well for now. I'll just come back to this annotation in this field. But this is just a student class. It has 3 fields as name, age, and address, an empty constructor and a parameterized constructor, and some getters. Intentionally, I have removed the setters because generally, whenever you are building any enterprise grade application, you would like to keep your objects immutable. Means once they have been created, you would not like somebody to allow to change the values of the object. This just makes programming much more easy if you treat all the objects in your application as immutable. That's why I have not added setters here. It's just considered a good practice. So apart from the standard things which we have already seen, there are 2 things here which I want to talk about. Let's first talk about this one. So @entity is the annotation which is coming from Java X persistence entity. And this makes Spring Boot save this particular object into the database. This is the annotation which you need to put on your class so that Spring Boot knows that this class represents a table in the database. So you need to add this to make sure that this represents a table. Second thing, a table will have a ID. It will have sort of a primary key. So I've created a new column called ID, which is basically representing the student's roll number or something, or maybe a registration number. And here I'm using a couple of more annotations. If you see, these annotations are also coming from Java X persistence library. And these annotations will basically allow a new ID to be created every time you create a student object. So you don't have to specify the value of this ID variable. Spring Boot will automatically generate a new ID value every time you create a new student object. And how does it generate? You can provide the generation type as well. So currently I've just set it as automatic, but you can set it as identity, sequence, or return or controlled by table. You can also see the explanation of each of these here. But I've just kept it as auto, which basically let the persistence provider pick any appropriate strategy for the particular database. In our case, the database is H2. So that's about the entity class. Let's call this as entity class. Now let's move to the repository. So you need a repository class. Like I explained in that 3-tier architecture, you always need a DAO layer or a repository layer to store your student object into the database. So we have enabled the student object to be saved, but we need a handler which can save this particular file, this particular object into the database. And the repository classes are the classes which will allow you to do that. So you create a very simple interface. You name whatever you want to name your interface as, and then you say extends JPA repository, the type of the object, and the unique identifier of the object. So the type of the object is student here, and the unique identifier of the student object is the ID, which is of type long. So you need to just supply the types, type of the object, type of the primary key, or the type of the unique identifier. And this annotation is coming from Spring Boot. You can see specifically Spring Boot data library, which we added. So you just need to create an interface, extend it from JPA repository, and make sure that you add this annotation as well. Spring heavily uses the concept of annotations, and this will help Spring understand that this is a repository layer class, and it will apply some more metadata to this class while this class is running in the JVM. So what happens here? You just created an interface. You did not provide any method to create or any method to delete or any method to get a student object, because all of that is automatically provided by Spring Boot via the JPA repository class. If we go inside this class, and if you scroll down, you will see the find all method, find all by ID, save all, flush, save and flush, delete, etc. And if you go further up, this also extends the paging and sorting repository, which provides pagination and sorting facilities. But the interesting one is that paging and sorting repository again extends a CRUD repository. And if you go to the CRUD repository, you will find all the basic methods to save an entity, save multiple entities, find an entity by the ID. That's why it needed that long type to make sure that it can execute this method. You can check the existence of an object, find all the entries, find all by ID, count them, delete them. So all the basic CRUD functionality. So we call them as CRUD because the reason it is called CRUD because create, read, update, delete. That's basically the generic acronym. So because this CRUD repository provides all the methods and their implementations automatically, we do not need to write any code at all. So that's why Spring Boot is so awesome, and that's why Spring Boot is very popular, because it's zero code in the repository and you still get all the CRUD functionality. So that's about repository. Now we have covered the entity class, we have covered the repository class, we have covered the entry point class. Now the only thing which is remaining is the endpoint, the HTTP endpoint, which I talked about. And that you can create by creating any class. Generally try to suffix it with the controller so that your core developers can easily find this class, and make sure that you put @REST controller annotation on top of it. This annotation will allow Spring to treat this particular class as an endpoint class. Then you can auto-wire the student repository. So if you remember, I talked about the whole dependency injection and inversion of control. So here dependency injection is in action. So here you're just telling student controller to auto-wire the student repository. And now what will happen that at runtime, student controller, or actually Spring, will automatically create an object of the student repository and supply that object of student repository to student controller. So you as developer do not have to create an object of student repository explicitly. That's the benefit, and that's how the dependency injection is working, because you inverted the dependencies now. The dependency is just injected into the class, and as a developer, you don't have to take control of creating the objects. It's the Spring which will automatically read the auto-word annotation and will automatically supply an object whenever it is required. Then I have two methods here, since we are talking about HTTP endpoints. So I have represented a post method here and a get method here. The way you will write a post method is via @post mapping annotation. And then you can provide the URL path on which somebody should call your endpoint to save something. So for example, somebody can call it HTTP localhost 8080/student/create. Whenever they hit that URL, the control or that request will directly hit this particular method. Why? Because you have provided the URL mapping here in the post mapping annotation. So since it's a post method, there would be request body. What is the actual request body which the client is sending? And you can represent that request body with the @request body annotation, and you can provide the type of the request body. And here I'm saying that, hey, if you want to access this particular URL, yes, all good, but you need to supply me with a text representation of the student object or a JSON representation of the student object. And then inside the method, I'm calling student repository dot save, which is going to save the student object which is coming in. So you see there's a lot going on here. I will show you how the student is represented in the request body as well, and then I will come back to how it got converted from JSON to Java. But this is how you can store this particular student object. You can hit this API as many times as you want and keep inserting a new student object every time. Then if you want to fetch a particular student, then you can do that by supplying the /student. And then in the curly braces, there's an ID written here. So basically you can supply the value of the ID of the student. So generally there would be another method here, which would be find all, to see all the students and with their ID, and then you can pick a particular student's ID, supply that student ID value here dynamically. That's why the curly braces supports dynamic value. So here it can insert 1, 2, 3, or whatever the student ID you want to fetch the value for. You provide that value in the student /ID, and all good. Then if somebody is hitting the URL with saying localhost 8080 /student/1, then student with the ID 1 will be returned from the request. And you need to put @get mapping to make sure that this method is treated as an HTTP get method. And you can provide the type, you can say get student, and here this dynamic value is captured with the @path variable, because you need to know the ID, right? Whatever ID somebody has supplied it in the URL, you need to capture that IDE and then use that IDE for calling the repository. So you can do that by using the @path variable. So here I'm just saying whatever ID is coming in, I will store that value inside this IDE. Once I've done that, then I can again call student repository dot find by ID, which is again a built-in method provided to me by the CRUD repository. I can supply the ID, and this actually is going to return an optional object, which is an object which may or may not contain a value. So it's just a defensive programming style. So this will return an optional, and you can call a get method to return the actual student object. This will return an optional of student. So optional of student means that this optional object may have a student or may not have a student. Why did Spring do that? Because the ID somebody is supplying, that ID can be invalid also, right? So optional object takes care of that if there is no student found, then you will not get a null pointer exception. And if there's a student found, you can return that. So it's just a defensive programming style which Spring has adopted by returning an optional of the student object rather than directly the student object. But if you're confident that this particular optional of student object does contain a student object, then just call optional.get, which I've called here, which will return the actual student object sitting inside the optional object. You can read more about the optional object and its usage from the official Java docs, and there are tons of examples available on it on internet. So this is about the controller. We have covered all the classes. Now it's time to run the application. So you go to the command prompt, you go to the particular file folder location, and there you just say mvn spring-boot:run. So I just hit enter, and this is going to run the application. It's going to spit some logs here, and if everything is fine, you will not get an error, and you will just be getting a message saying that application got started. And it's running on Tomcat localhost 8080 with no context URL. So this is not a web application. This is a RESTful web service, right? This is a RESTful service. This is not a web application. So there is no web interface. So how do you access this? You just have an HTTP URL. So you can use any of the REST client available on the internet. There are probably hundreds of different REST clients available on the internet. You can choose any one of them. I am using advanced REST client, which you can also install as an extension from the Chrome browser itself. So if I just open the Chrome browser and I just say REST client, if you just write this and hit enter, you will get many different options. And the first option you get is from Google Play Store's App Store. So you can go to the App Store, basically the Chrome Web Store, not the Play Store, but the Chrome Web Store, and you can just install this. Since this is already installed, you can click on Launch App. and it will open this interface for you. So this is this is not a tutorial for advanced REST client, so I'll just be quick here. You can choose the method type which you want to hit. So let's say I want to do a post, and then you can provide the URL here. So remember the URL which we put here in the controller method, this has to exactly match. So HTTP localhost /student/create should be the URL. So let me just copy paste this one here. Okay, so the URL is good here. It's a post type of method which I want to do, and I want to hit this particular URL. Now I need to supply the content type and the body. So in the content type, you can choose application JSON because I'm going to supply a JSON object. And in the body, this is how the JSON object looks like. Advanced REST client also provides a nice visual interface to basically create this JSON. If you are thinking that JSON creation is very tough, it's not actually tough. It's just curly braces. And then you put key and value, comma, let me just put an enter here so that it's more readable. So you just put curly braces starting and end, and then you just put key value. You put a key, which is the variable name, and the variable's value, variable name, variable value. And these keys have to exactly match the student's properties. So the student.java had this name, age, and address, right? So it has to exactly match. Otherwise, this request will fail. So this is all good. Now I can send this particular request. When you click send, it is going to hit my Spring Boot application, which is running on localhost 8080. It is going to call the student/create method. It is also going to convert this JSON into a Java object because here I'm supplying a Java object. So it will convert the JSON, which I'm sending from here, to Java object automatically, and it is going to automatically save it here because I've called the repository.save method. So let's hit send here. Once I hit send, I get a 200 OK. It means everything went fine. And in the response header, I get the object back because I have returned the object here. You see, this save method is going to return the same student object which you created. So everything is good here. My object has been stored here. And now it's time to fetch the object. So it has already been saved into the H2 in-memory database, and you can obviously go and connect to the in-memory H2 database and have a look at it. But for simplicity, I'm just going to do this here. And let's say the first object is generally added as the ID1 by default by the H2 database. So let's hit this particular URL. When I hit this URL, it is going to hit the student controller here. And in the student controller, it is going to hit the get student method, which is having a student/ID URL, and it is going to find the database with that ID. And if it finds a student object with that ID, it is going to return that. So let's confirm that now. So let's hit this particular send button, and it is going to hit a get request with this particular URL. Spring Boot is going to find if a student with the ID 1 exists in its database. So once I hit send, I get a 200 OK. And you see in the response headers, I get the same student object back, which I added. Let's try with 2 now. Let's see what happens. I see 2 and I get 500 internal server error because there is no object stored in the H2 database of the Spring application with the ID 2 yet, because we only inserted one object. That's why only one student object is there, and the first ID which H2 database created for it automatically was 1. So when you hit for get request with a student ID 1, you get the object. When you put any invalid value and you hit this, you get a 500 internal server error. You can also make it look nice by not sending the 500 internal server error and sending a nice exception from the backend. So from here, you can also send a nice exception that if this object is not found, you can say something like that, or else throw, which is again an optional object. And here you can supply a particular type of exception which you want to supply instead of just throwing 500 internal server error. But that's just additional defensive programming you can do. You can add more and more validations and constraints into this project as you build this project in a more complex paradigm. So this is basically what I wanted to show you, that we have created a Spring Boot application. We have connected it to a database. We have created also an HTTP endpoint with student controller. We ran that application. We used any random REST client. In my case, I used advanced REST client. And we first did a post request. We provided the exact URL. The URL has to exactly match with the controller URL. And then the body, the request body also has to exactly match with the student object's property, especially the case of the names have to exactly match. So if all this matches, then you will get a response back that the object has been created. If you want to fetch the value of the object, you're going to use the HTTP GET method, and you again provide a URL which has to exactly match to some method in some controller in the Spring Boot application which is running on localhost. And if you provide the right ID, you are going to get a valid result. If you provide an invalid ID, you're going to get a 500 internal server error. And from here on, you can make this controller as robust and as mature as you want. You can add find all method, you can add a update student method, you can add a delete student method, you can have all different kinds of filters. Like for example, return to me all the students starting with the name A, or return all the first students with the roll number 1 and 100, or between 1 and 100. So you can write as many endpoints as you want and build this application in with as much maturity and as much complexity as you want.
In this session, we shall learn what is JUnit all about. JUnit is an open source unit testing framework for Java. Here, the term unit testing framework comes into consideration. So before moving forth, let's check what is meant by the term unit testing. Unit testing, as the name suggests, is a way of testing a unit. Here, a unit refers to the smallest piece of code that can be fetched out of the system. It can be a line of code, a method, or a class. Keep in mind, smaller the chunk of code, the better it is. If the tested units are small, the tests tend to run faster, providing a better insight into the code and its performance. Unit testing helps in the early identification of defects. It enables the developers to spend more time on reading the code rather than writing it. And a successful code helps in boosting the confidence of the developer. Then coming back to JUnit, the framework is used by Java developers to create and test their codes. It is used for unit testing of the source code, and JUnit works on the approach of testing a small part, then coding that, and continuing the same till the end. JUnit testing helps developers to develop more reliable, readable, and a bug-free code. Every time a new code is added, all the test cases have to be re-executed to make sure that nothing is broken. There are graphs in JUnit that show the progress of the test. The graphs show green when the test runs smoothly and it turns red when the test fails. Now, when we know about JUnit, let's see the way to download and install that into our system. Before you go on to install JUnit, make sure you have JDK and Eclipse installed in your computer system. So, let's go on. First, open your browser. In the browser, type download JUnit. In download JUnit, we'll get about JUnit. In about JUnit, when we scroll, we find download and install. In download and install, when we go inside that link, we will find two jar files. Here, let's download these two jar files. When we click on this download button, we will download jar. After the first jar is downloaded, let's go back to that page and download the second jar file. After both the jar files are downloaded, let's go to the location. Here we can see two of our jar files are downloaded. Let's copy these jar files, go to our documents, and here in the Java libraries, where all the Java libraries are stored, let's paste them. After we have pasted these files, we shall open our Eclipse. As soon as our Eclipse opens, we will first create a project. Here, new, then we shall create a Java project. In Java project, let's name it JUnit installation. Click on next and finish. Here, then in this Java project, right click on it and go to the build path option. In the build path option, go to configure build path. Here go to the tab libraries, and this side go to add external jars. In add external jars, you will get the location of our 2 jar files, and if you don't get them, you can browse to the location where you have stored them or to the location of Java libraries. Then select these 2 files and open them. You will see the 2 jar files appear here. Then click on apply and close. Now come back to JUnit installation, that is a project, right click on it and click on refresh. Then right click on the src folder, go to new and create a package. Let's name the package to be JUnit install and click on finish. In this package, create a new class and we shall name the class JUnit install and click on finish. Now let's create a method over here. In the method, we shall type public void my JUnit install then system.out.println welcome to my JUnit testing. Now I will add a library over here, library test. I can see a error. Now when I hover over this library, I can see it says import test. So now when I click on it, the error is gone. Now we shall run our test, and since we are testing with JUnit, we shall click here, go on, run as JUnit test. Here we shall click on OK, and then we can see in the console it shows welcome to my JUnit testing as we had placed it over here. Here on the left side you can see the JUnit report. You can see runs 1 out of 1 and there is no or 0 errors, and same there are 0 failures. So here in the space provided, you can have as many number of tests, as many bunch of code you want, and with the help of JUnit, you can test any particular part of the code.
We will be going through some of the project ideas related to Java programming language. So the first project that we will deal today is the online courier management system. So this particular project motto is to deal with the courier management system. The system will be used for day-to-day activities like buy, return, booking, delivery and non-delivery, and self-pickup, etc. It is not easy to build this particular project all alone, as the technicality of the project is a little complex for a single programmer. I would suggest you that you get a team with you and also look out for some automation in the process by developing the relevant software. Robotic process automation is the new normal in today's life. The web-enabled interface allows the user to log in from anywhere in the world and track their courier and also view the customer rating. The system is designed to integrate with financial accounting to eliminate duplication of data entry and is also scalable to grow along with your company. The system needs to be built with user-friendly screens, rich in functionality and features, and finally the major part, it should maintain a high level of data integrity. So with that abstract discussed, now let's look into the features offered by this particular online courier service. As discussed in the abstract, this particular project should be providing the features of order and dispatch of the product, information regarding the customer, delivery executive, and followed by the delivery executive, we should be also having a payment window which manages the accounts and bill reports. So having said that, let's now move into the software requirements. So the software used in this particular project is the programming language, that is Java, Database is the Microsoft Access and some convenient RPA tools. And finally, the IDE. The IDE for this can be anyone which has a good support for Java. The most preferable one would be the Eclipse. And then comes the IntelliJ, NetBeans, and many more. Now, creating this kind of a project will give you a valuable experience based on building a fully fledged e-commerce website or an application. I mean, this is how the world's leading applications like Amazon, Flipkart, Zomato, etc. are basically planned and have reached greater heights today. This kind of project on your resume could make a huge difference. And who knows, tomorrow you might even get into one of those companies and start working on their projects or build a company of your own. Followed by the online career system, we have the online voting system. Now, thinking apart from getting a job or starting a new company of your own, this is something that we all need today in this pandemic situation especially. In the current scenario, the internet has brought all the ease to our living room. It has replaced physical banking to internet banking, ordering food online, buying movie tickets, buying clothes and household items, to consult your doctor for minor issues, bill payments, and many more. Yet, for quite a long time, going to polling booth and standing in a long queue to cast a vote has been persistent, and it has been challenging for the government to motivate common people to participate in the election system and cast their vote, just because there is no other way to do such thing as such an online voting system. But all the credit can be achieved by software engineers who can make it possible soon for everyone to cast their vote to their respective candidate as their own choice with an unmatchable ease. This can be done just by click on their fingers. This is an advanced Java project developed to show online voting functionality. Followed by the abstract, we will get into the technicality of this particular project. So the first phase of this particular project has the admin phase, where the admin has the right to manage the candidates, manage the voters and their profiles and passwords, and finally election results. Followed by the admin, we have the voter or the user of this particular application. The voter or the user gets to register himself or herself into the application. Followed by that, he can use the login and logout options. And next we have the profile and password managements. So followed by that, we have the option to choose the positions to vote and finally to cast the vote. Now this particular project is an advanced level Java project developed to show online voting functionality. It showcases the use of Java Servlets, HTML and CSS. Again, coming into the IDE. The IDE for this can be anyone who has good support for Java. The most preferable one would be Eclipse and IntelliJ. Followed by the online voting system, we will now continue with the online healthcare management. Named as the corporate Medicare management, this e-healthcare management system is a web-based project developed in Java. The main aim of this particular project is to provide effective management of data related to staff and patients in hospitals or clinics. The features offered by this particular project should be as follows. It should optimize bed occupation. The project should improve the use of operation theaters, avoiding the cancellation of operations. To know how much emergencies affect the administration of the hospital departments or services which include cancellation of operations. To optimize the allocation of human and material resources to wards and shifts. To detect the influence of certain diseases in the hospital services, and finally to find clusters of patients. The software requirement for this particular project are as follows. We need DHTML for the front end and Java as the programming language, and data mining tool which is Weka, and Oracle for the database, JavaScript for the scripting language, and finally Tomcat as our server. The e-healthcare management system is a web-based application that assists the management of staff, doctors, and patients in an easy, comfortable, and effective way. Here, the concept of data mining plays a vital role to develop an effective healthcare management system. The proposed application aims to create a friendly working environment for any healthcare centers to overcome the drawbacks in the existing system of healthcare management. This system is very reliable and flexible from all aspects, so new features and modules can be easily integrated into the system in the future. Followed by the e-healthcare management system, we have a new normal, online banking. Not interesting and arousing for a normal person, but for a hardcore programmer, it is as exciting as a roller coaster ride in an amusement park. Because this is how the major national and multinational banks implement their banking facilities in a wide range so that their customers could experience the ease of banking at their fingertips. One such type of project on your resume could bring major highlight to the recruiter, especially if the recruiter is from a banking or financial based company. Online Banking System project is a model internet banking site. This project should enable the customers to perform basic bank transactions by sitting at a corner of their home or office through a phone or laptop. The customers can access bank's website for viewing their account details and perform the transactions on account as per the requirement. Bank employees can log in and add customer and account information to perform transactions with internet banking. With internet banking, the brick and mortar structure of the traditional bank gets converted into a click and portal mode, thereby giving the concept of virtual banking a real shape. Thus, today's banking is no longer confined to branches. E-banking facilities banking transactions by customers round the clock globally. The features you can offer through this particular project are homepage for online banking site, creation of new accounts, login and logout, manage profiles and passwords, view the balance of the account, deposit the amount into the selected account, withdraw amount from the selected account, transfer the amount from one account to another, close the account. So the software requirements for this particular project are Java programming language and JavaScript for scripting language and Oracle for database and Tomcat for server. So followed by the online banking project, we have the online examination project. Online exams are normal for us nowadays, but this is totally limited to high-end exams like CET, GRE, CAT, etc. The requirement for this particular project is increasing day by day because of the current scenarios. Many schools and colleges have now turned towards the online education system and are looking forward to hosting online exams for student safety. Online examination is a simple project developed to provide an online platform for faculty and students to conduct online examinations and their evaluations. This particular project has two parts. First is the admin part. Admin has the right to add students, create one-time login, adding questions, receive answers, and finally to evaluate. Followed by the first part, we have the second part which belongs to the students. So the students can log in, update their profile and password, select answers for the MCQs, write answers to questions, and finally closing the session and log out. This particular project can be made a grand success by making use of simple Java servlets and Java programming languages and server like Apache, Tomcat. Followed by the online examinations, we have the Smart City. Smart City Java project can be a web-based software developed to store the details of a particular city. The main purpose of the project is to help tourists and other visitors to a city by providing information about hotels, transportation facilities, air ticket booking, shopping details, city news, etc. The Smart City Java project serves the visitors as a guide of the city, and hence the project is called as City Guide project in Java. Using this project, the details of the city can be accessed from anywhere at any time. The implementation of this city project promotes tourism and business effectively. Hotels can be searched more easily from anywhere. With the help of this online software, students can look out for academic institutes located in the city. You can view the complete map of the city using this project. Followed by the abstract, we have the features of this particular project. The features offered in this particular project are login, update profile and password, search for the options, select an option like booking a ticket or hotel or anything like transportation, etc. And finally selecting that particular option, booking that option and payment window. Finally, the confirmation of the order. This particular project can be fulfilled by using the following software tools as mentioned below. They are the Java programming language, Tomcat server, scripting languages like JavaScript, etc., and database as Oracle for interactive data storage. This could be escalated to another level by following. Design drones that can act like a cop, act as a tourist guide for the people touring the city, a drone that has capability to take pictures, videos of suspected activities and store it for future reference. A drone can intimidate a cop if any suspected activities are detected. There can be many drones in the city with different functionalities, and finally you are required to implement the functionality of the drone to the users to interact with the drone. Users could be travelers or cops or travel agents or cab agents. The code for all these projects are provided in the description box below. Followed by the smart city, we have the bug tracking system. The bug tracking system is a web-based application developed by Java programming language for software companies. The main aim of this project is to manage the errors or bugs that occur during the software development phase and cycle. After the implementation of this project, the employees can update the issue details, solve the issues, and update the system for any location with internet access. Below are the features of this project, and source code of this project is linked in the description box below. Coming into features, the software is applicable in managing the bugs that occur during the development of software and tracking the older issues. It facilitates searching the facility to bug history and solution. The system is fully secured and authentication method is adopted to manage security. It stores the older bug reports so that they can easily be solved when they reappear. The application helps the project manager in evaluating the works of the employees. And finally, the proposed software is capable of auto update when the latest version is available. So the software requirements for this particular project are programming language, which is Java, web-based applications such as JDBC, JNDI, Servlets, JSP, and Oracle database or Access database as the database. Followed by that, the server deployment is Red Hat, JBoss, AS, etc. And the client-side scripting as the JavaScript. And the IDE for this particular project would be Eclipse with all the My Eclipse plugins. And finally, the user interface can be designed using HTML and CSS. So with this, we can move ahead into the next project, which is the facial recognition. The face recognition with OpenCV is an open source computer vision library that has tons of modules like object detection, face detection, and augmented reality. The major features that this particular project offers are managing the use of faces, facilitate face identification, easy login and logout, store face IDs, identify suspects with just images, enhanced way to find cyber criminals. So followed by the features, now we should look into the software requirements to build this particular project. So the programming language we need for this particular project is Java, and followed by the programming language we need the Apache Ant framework, Ming W64, and finally the CMake framework. So followed by the facial recognition project, we have the next project, which is the vehicle recognition. So Java ANPR is a number plate recognition software which implements algorithmic and mathematical principles from artificial intelligence, machine vision, and neural networks. So the features offered by this particular project are high-level language for numerical computation, interactive environment for iterative exploration, mathematical functions, built-in graphics, functions for integrating MATLAB, and many more. So this particular project can be fulfilled by using OpenCV and Java programming language along with some natural language processing algorithms. So followed by vehicle recognition project, we have our last project, which is the speech recognition system. So speech recognizer converts audio to text. Java x.speech.recognition package defines the recognizer interface to build speech recognition plus a set of supporting classes and interfaces. So the features or stages in this particular project are to create a speech recognizer, allocate resources, load and enable grammar, attach result listener, commit changes, and finally provide the process results. So this particular library is readily available in Java, and you can code this project using the Java programming language and an IDE such as Eclipse. We all know that Java is one of the most sought programming languages in the current IT industry. There are multiple multi-million-dollar companies which are using Java till today. So this video is completely dedicated to help out the Java developers and the beginners in Java programming language to crack the most frequently asked Java interview questions. So without further ado, let's begin with our interview questions. At first, we will start with the beginner level interview questions. So in the beginner level interview questions, the first question we have is, what is JIT? So the answer for this question is, JIT is an abbreviation for Java In-Time Compiler. It increases efficiency of the interpreter by compiling the bytecode in the runtime. JIT or just-in-time compiler compiles code to machine level directly for higher speeds of code execution. So basically, just-in-time compilation is a feature added to the interpreter of Java. So this involves conversion of the code directly to machine level during the compilation stage. This improvises the speed of execution of a Java program. Now, after the first question, the second question in the docket is, what is a class loader? Now let's discuss the answer for this particular question. So basically, class loader is the first file to load when you execute any Java program. So the Java class loader is the integrated part of Java virtual machine. So the functionality of class loader is to load the class to the Java virtual machine while it is demanded to execute a class. Java has Bootstrap extension and application type of class loaders. So the third question in the docket is, what are the memory allocations available in Java? So the answer for this particular question is, Java provides multiple types of memory allocations. But the 5 major types of memory allocations which are most frequently used are class memory, heap memory, stack memory, program counter memory, native method stack memory. So the next question in the list is, will the program run if I write static public void main? So basically we write public static void main, but in case, imagine if I write the program as static public void main, will the program execute properly? So the answer for this question is yes, because Java does not follow any specific rule for the order of specifiers you place in your program. So when you execute the program with such pattern in your specifiers, then the program will compile successfully. Also, it will run successfully. So the next question we have is, what is the default value stored in local variables? So in C programming language, when you declare a local variable or a global variable or any type of variable, then the first value which is stored inside that variable will be a garbage value, unless you initialize the variable with a personalized value. For example, if you declare a variable I equal to 0, then you are storing a value in that variable I, that is 0. If you just declare it as int I, then the value stored inside that I variable will be a garbage value. So similarly, when you declare some kind of local variable in Java, then what will be the default value stored inside it? So the answer for this question is neither the local variables or the global variables or any primitives or any object references do not have any kind of default value stored in them. So followed by the fifth question, we have the sixth question. So what would be the output of the following code segment is the sixth question. So this might happen sometimes. So basically what happens is your interviewer will throw a question at you which has a code segment. So all you need to do is decode that code in your mind and provide the output. So this would be the code that we will be dealing with. So you can see our question has two printf statements. The first one has 100 plus 100 plus a string which is Simplilearn. And in the second printf statement, we have a string that is e-learning company plus 100 plus 100. So what will be the output of these two printf statements? So the answer for this question is really simple. So we'll be having 200 Simplilearn as the first output and e-learning company 100 as the second output. Why? Let's check out the code segment once again. So when you see the code segment once again, so the first printf statement has 100 plus Simplilearn. So JVM here understands 100 as an integer value and the plus symbol as an addition operator here. So followed by the addition operator, we have another integer value. So what JVM does is it adds the two numbers 100 plus 100. So followed by that we have another plus symbol here. So followed by the plus symbol we have a string value. So here the JVM considers the plus symbol as a concatenating operator but not as an addition operator. So that's why the first two numbers got added and the result was 200 and the next two values were concatenated. So it became as 200 Simplilearn. Similarly, in the second printf statement, the JVM encountered with a string value. So it considered the plus symbol as a concatenating operator. Similarly, it happened with the second plus symbol as well. So that's the reason we had e-learning 100 as the second output. Now followed by the sixth question, we have the seventh question. What is an association? So the answer for this question is, an association can be defined as a relationship that has no ownership over the other. So to understand this definition, we can consider a simple example. Consider a person associated with multiple banks. So consider person X who has got accounts in bank A, bank B and bank C. And similarly, a bank is associated with person X. That is, a bank A, bank B and bank C are associated with the person X, but no one has ownership over the other. A person X who is an account holder with all the three banks, that is A, B and C, does not possess any kind of ownership over the three banks. Similarly, banks A, B and C who has the customer, which is the person X, but the banks do not possess any kind of ownership over the customer. So the relationship between the person X and the banks ABC can be considered as an association. Now followed by the seventh question, we have the next question, that is the eighth question. Define copy constructor in Java. So the answer for this question is as follows. A copy constructor in Java is a constructor that initializes an object through another object of the same class. A copy constructor in Java is really helpful because when you want to copy a complex object that has several fields, or when we want to make a deep copy of an existing object, then the copy constructor is the one which will help you out in this situation. So followed by the eighth question, we have the ninth question. What is a marker interface? So the answer for this question is, an empty interface in Java is referred as a marker interface. Serializable and clonable are some of the popular examples of marker interface. So basically a marker interface is just another interface, but normally in interface we provide some signatures. So these signatures belong to particular methods. So in normal interface we just have method signatures, but not the complete implementation, or at least we'll be having some variables. But in a marker interface, we do not have any kind of data manipulating method signatures, any data members, nothing. They have special functionality unlike a normal interface. So followed by the ninth question, we have the 10th question. What is object cloning? I guess the word object cloning is completely self-explanatory. Yet the answer for this question is, it is an ability to recreate an object completely similar to the existing object. This process is known as object cloning in Java. Java provides a built-in function or method, that is the clone method, to clone an existing object, offering the same functionality that of the original object. So followed by the 10th question, we have our 11th question. Why is Java not completely object-oriented? So this question might be a little confusing, but it's true. Java is not completely object-oriented. But what's the reason? Yes, I'll explain you why Java is not completely object-oriented. So the answer for this question is, Java is not considered as 100% object-oriented programming language because of the data types it uses. It still makes use of 8 or more primitive data types, which are int, float, double, and few others. So this is the only reason why Java is not considered as completely 100% object-oriented programming language. So the next question is, define wrapper classes in Java. So the answer for this question is, in Java, when you declare primitive data types, that is the int, float, double, etc., then the wrapper classes are responsible for converting them into objects or reference types. Just as we discussed before, Java is not 100% object-oriented programming language just because of the primitive data types it uses. So when you include such primitive data types, then wrapper classes are the ones which convert them into objects or reference types for the ease of compilation and execution of programs without any issues. So followed by this question, we have the next question. Define singleton classes in Java. So the answer for this question is, in Java, when you make the constructor of a class as private, then the particular class can generate only one single object. This is the reason why such type of classes are called as singleton classes. So followed by that, we have our next question that says define package in Java. So if you use some of the popular IDEs, that is the integrated development enterprises such as IntelliJ or Eclipse, then you might be familiar with projects, packages, source files, and then the class file. So basically you create a project first, and inside the project you will be having your source folder, and then you will be creating your own package using the source folder, and inside the package you will create a class file, and inside the class file is where you write your Java program. So here the question is, define package in Java. So the answer for this question is as follows. Package is a collective bundle of classes and interfaces along with necessary libraries and jar files. The use of packages helps in code reusability. So basically when you create a specific package, inside that package you will store all the class files that you will be using in your Java program. So not only class files, in case if you use any kind of connectors or any kind of jar files or any kind of dependencies for your Java program, you will include all those inside the package so that the requirements and the class files are bundled together, and this helps out in code reusability, making sure that the program files or the jar files or any dependencies are not juggling between one package to the other or one file to the other. So using a package is basically a good practice. So followed by this, we have our next question. Can you implement pointers in Java program? So if you remember C programming language, we had pointers there. So we use pointers to directly access the memory. So similarly, can you use pointers in a Java program? This is a little tricky question for beginners, but basically it's really simple. Now the answer for this question is no, because Java Virtual Machine personally takes care of memory management implicitly. So Java's major motto was to keep programming simple. So accessing memory directly through pointers is not a recommended action. So the answer is a big no, you cannot implement pointers in Java program. So followed by that, we have our next question. Differentiate between instance and local variables. So the answer for this question is really simple. Instance variables are declared inside a class and the scope is limited to only a specific object inside which an instance variable is created. So followed by the instance variable, we have the local variable. So the local variable can be anywhere inside a method or a specific block of code. Also, the scope is limited to the block of code where the variable, that is the local variable, is declared. Now followed by the 16th question, we have our next question. Explain Java string pool. So the answer for this question is a collection of strings in Java's heap memory is referred as Java's string pool. So for example, you wanted to create a new string. Consider your name. So your name might be some XYZ. So if you wanted to create XYZ string, then you provide that particular code to your JVM. So what does JVM do? It will not directly create that particular string. First, it will search for the XYZ string in your string pool. If that is already existing in your string pool, then it will provide a reference to that particular string. In case if XYZ is not there, then the JVM will create a new string, that is the XYZ string. So followed by this, we have our next question, that is, what is an exception? So the answer for this question is, an exception in Java is considered as an unexpected event that can disrupt the normal flow of the program. So for example, just consider that you are going to write a program for division operator. So after you finish your program, your evaluator might want to test your code to the extreme levels. So instead of providing a proper number, imagine that your evaluator is providing a wrong input, such as special symbols, sometimes 0, or any other sort of input. So if this kind of input is provided to your program, then your program might crash. So you can avoid this kind of crash by using exception handling. So basically you can use try and catch blocks. So you can embed your code inside the try block and say to your program that if any kind of wrong input such as special symbol or 0 is provided by the evaluator, then send a message saying wrong input or divide by 0 exception. So this kind of approach will provide an output, but this kind of approach will avoid your program from crashing. So this is how exceptions are handled in real time. So followed by this, we have our next question. What is final keyword in Java? So the answer for this question is, the term final is a predefined word in Java that is used while declaring values to variables. When a value is declared using the final keyword, then that particular value of that particular variable will remain constant throughout the execution of program. So sometimes if you include a normal variable and provide an operation on that particular variable, then the value of that particular variable will change after the execution of program. But when you declare the same variable using final keyword, then no number of operations or any kind of manipulations applied onto that variable will not change the value of that particular variable. So that's the speciality of final keyword in Java. So followed by that, we'll dive into the next question, that is, what happens when the main method is not declared as static? So the answer for this question is, when the main method is not declared as static, then the program may be compiled perfectly, but ends up with a serious ambiguity and throws a runtime error that says no such method error. So when you basically declare a main method, don't forget to specify the static keyword. So with this, we finish the beginners segment of questions. Followed by the beginners segment, we have the next segment, that is the intermediate level segment. So the first question in the intermediate level is, what is JDK, and mention the variants of JDK. So the answer for this question is, so JDK is basically an abbreviation for Java Development Kit. This is a combined package of JRE, that is the Java Runtime Environment, and developer tools used for designing Java applications and applets. Oracle has the following variants for Java Development Kit. So the first one is the JDK Standard Edition, which is normally used by beginners and intermediate developers. Next, after the JDK Standard Edition, we have the Java Development Kit for Enterprise. So this particular Enterprise Edition is used by professional Java developers for developing Java-based applications and frameworks. Now the last one is the Java Development Kit Micro Edition. Now followed by 21st question, we will dive into the next question that says, brief access specifiers and types of access specifiers in Java. So the answer for this question is as follows. Basically, access specifiers are predefined keywords used to help a Java virtual machine to understand the scope of a particular data member or data manipulating method within a class or outside the class. So in Java, we have 4 types of access specifiers. The first one is public access specifier. So when you declare a data member or a data manipulating method as public, then that particular data member or method can be accessible by any class or object throughout the package. Followed by that, we have the private access specifier. So unlike the public access specifier, when you provide the private access specifier, then the accessibility of that particular private data member or the data manipulating method will be provided to specific classes and specific objects only. And finally, we have the protected access specifier. So the protected access specifier is a bit more secure than the private access specifier. So the access for this particular protected data member or protected data manipulating method could be a little more difficult to access unless you are going to implement everything which is present in that particular package. So basically, if you are trying to access the protected data member or protected data manipulating method of a different package, then you need to first import the package into your existing package. So that's how the protected access specifier works practically. So finally, after the major 3 access specifiers, we have the default access specifier. So default access specifier will be provided by the Java virtual machine. So in case if you declare a variable or a data manipulating method without using any specific access specifiers that are public, private and protected, then JVM implicitly considers the default access specifier. So there is no much of a difference between the public access specifier and the default access specifier. Both have the same functionality and accessibility. So followed by this question, we enter into the next question, that is, can a constructor return a value? So the answer for this question is as follows. Yes, a constructor can return a value. It basically returns the current instance of a class implicitly. You cannot make a constructor return a value explicitly, but automatically it returns the instance of a class. So the next question is, explain this keyword in Java. So in Java we do have a keyword which is called as this. So what does the keyword this mean in Java is the question. So the answer for this question is, the term this is a special keyword designated as a reference variable. So the term this keyword is used to refer to the current class properties like data manipulating method, instance, data member and constructors. So followed by the 24th question, we have our next question that says, explain super keyword in Java. So the answer for this question is as follows. The term super is a special keyword designated as a reference variable. So similar to this keyword, even super keyword acts as a reference variable. But the difference is super keyword is used to refer to the immediate parent class object. So followed by the 25th question, we have our next question, that is, explain method overloading in Java. So basically method overloading and method overriding etc. are the concepts of polymorphism. So now let's have a correct answer here. So the process of creating multiple method signatures using one method name is called as method overloading. So for example, consider that you wanted to include an addition operation in your program that performs addition operation. So the first method will be having the name add, and inside the method parameters you'll be having 2 integer types of parameters. Similarly, you wanted to perform another addition operation with the same name add. So here you will provide the method name completely same to the first method, but inside the parameters there is a difference. You are adding 3 parameters here. So when you pass the values to the add method, then which method to be overloaded? That's the confusion, right? So should I overload or should I execute the first add method or the second add method? So this completely depends on the number of parameters you pass. If you are passing 2 parameters, then the first method will be executed. If you are passing 3 parameters, then the second method will be executed. So this is how the method overloading happens in Java. So the process of method overloading can be achieved by using 2 different ways. The first way is to change the number of arguments. So that's what exactly I've discussed before. Now the second way is varying the return type of the method. So with this, let's enter into the next question. Can we overload a static method? So as discussed before, the values of the variables or data manipulating methods will not be changed when we have used the keyword static in front of it. So the question is, can we overload a static method? Now let's discuss the answer for this. The answer is no. Java does not support overloading of static method. The process worked through an error reading static method cannot be referenced. So followed by this, we have our next question. So the next question is define late binding. The answer for this question is binding is a process of unifying the method call with the method's code segment. Late binding happens when the method's code segment is unknown till the method is called during the runtime. So followed by this, we have our next question. Define dynamic method dispatch. So the answer is the dynamic method dispatch is a process where the method call is executed during the runtime. The overridden method is called through a reference variable of superclass. So this process is called as runtime polymorphism. Now we have our next question. Why is delete function faster in linked list than an array? So basically linked list and array are the Java collections, or in other words, it's also considered as data structure. So to answer this question, you need to understand the analogy of linked list and array. So basically an array is a complete memory block of consecutive memory locations. So consider that your memory location starts from 100 and your array has 10 locations. So it's a complete reserved block of from 100, 101, 102 to 109. So you have 10 memory blocks. So in case if you wanted to add a number or delete a number, then you had to make changes to the complete memory block. But when you come into linked list, you have the memory blocks used from the memory heap. So basically what you do here is you basically connect the nodes through addresses. So in case if you wanted to eliminate a number, then what you do is just to manipulate the addresses. So the address of the consecutive node will be changed. So that's the only change what you make. So now this is the reason why the delete function or any kind of manipulation function is faster in linked list compared to array. So now let's have a brief answer on this. Delete function is faster in linked list as the user needs to make a minor update to the pointer value so that the node can point to the next successor in the list. Now followed by this, we have our next question. Give a briefing on the life cycle of a thread. So the life cycle of a thread includes 5 stages, which are as mentioned below. Newly born state, runnable state, that is it provides the JVM with a feedback that I'm ready to run now, followed by that the running stage where the thread is actually running, followed by that the block stage. So basically the thread will be blocked for some reasons, for some intermediate output or something, if the thread is waiting for an input from another source or something similar. So that's where the blocked state comes to existence. And finally the dead state. Once after everything is processed, the thread is eliminated by JVM. Now followed by this, we have our next question that says, explain the differences between the operators provided here. So the operators might look similar, but they are different. Now let's understand about these operators in a much better way through the answer. So the answer for this question is, although they look similar, but there's a huge difference between them. So the first operator, which looks like 2 greater than symbols, perform the operation of right shifting. So when you provide a binary number or binary value, then the bits will be shifted towards the right. And the second symbol or the second operator, which is having 3 greater than symbols, is used to shift out the 0 filled bits. So this is the functionality of these 2 operators. Now followed by that, let's have the 33rd question. Brief the life cycle of an applet. So the answer for this question is, the life cycle of an applet basically involves the following stages. The first stage is the initialization stage, next is the start stage, third is the stop stage, fourth is destroy, and finally we have paint. Now the next question is, why are generics used in Java? So the answer for this question is, compile time type safety is provided by using generics in Java. So this approach allows the users to catch unnecessary invalid inputs at the time of compilation. Generic methods and classes help programmers to specify a single method declaration, a set of related methods, or with a single class declaration, a set of related types. So followed by this, we have our next question. Explain externalizable interface. So the answer for this question is the externalizable interface helps with the control over the process of serialization. The externalization interface incorporates read external and write external methods. So we have listened to a new term here, which is serialization. So what exactly is serialization? Serialization is a process of sending your Java code or Java project from one computer system to a different computer system. So basically, if you wanted to execute some kind of Java program from a different location, then you serialize this particular code to a different location where you actually want to execute, and this particular process of transferring your code is called as serialization. Now the next question is explain daemon thread. So the answer for this question is the daemon thread can be defined as a thread with least responsibility. The daemon thread is designed to run in a background during the process of garbage collection in Java. The setDaemon method is used to create the daemon thread in Java programming language. So we have our next question now. Explain the term enumeration in Java. So the answer for this question is enumeration or enum is an interface in Java. Enum allows the sequential access of elements stored in a collection in Java. Now the next question is, why is Java considered as a dynamic programming language? So the answer for this question is Java was designed to adapt to an evolving environment. Java programs include large amount of runtime information that is actually used to resolve access to the objects in real time. So this is the reason why Java is considered as dynamic programming language. Now followed by this, we have our next question. Can you run a code before executing the main method? So the answer for this question is yes, we can execute any code even before the main method. We will be using the static block of code in the class when creating the objects at load time of the class. Any statements within the static block of the code will execute it once while loading the class, even before the creation of objects in the main method. Now the last question in the intermediate section is how many times the finalize method is called. So the answer for this question is the finalize method is called by the garbage collector. So for every object, the garbage collector calls the finalize method just for once. Now with this, let's enter the advanced segment of interview questions based on Java. So the first question in the advanced segment is, can the keywords this and super be used together? So the answer for this question is no. This and super keywords should be used in the first statement in the class constructor. So the following code segment will give you a better idea. So you can see that we have used the keyword super and this in the class constructor. That is the first class constructor. Now this is how you can use super keyword and this keyword together in case if you wanted to use. So with this, let's continue with the next question in the advanced level. So the next question says explain JSP page. So the answer for this question is JSP is basically an abbreviation for Java Servlet page. So the Java Servlet page consists of two types of text. The first is the static data and the second one is Java Servlet page elements. Now the next question is explain JDBC. So the answer is JDBC is an abbreviation for Java Database Connector. JDBC is an abstract layer used to establish connectivity between any existing database and to a Java application. Next question is explain the various directives of JSP. So the directives are instructions processed by JSP engine. After the JSP page is compiled into a servlet, directives are used to set page level instructions. insert data from external files, and specify custom tag libraries. Directives are defined between the following symbols. So these are the symbols that are used to specify the directives in a JSP page. The different types of directives are shown as below. There are 3 types of directives. They are include directive, page directive, and taglib directive. So include directive includes a file and merges the content of the file with the current page. The page directive is used to define specific attributes in the JSP page like error page and buffer. The taglib directory is used to declare a custom tag library which is used in the JSP page. Followed by that, we have the next question. What are observer and observable classes? So the answer for this question is objects that subclass the observable class maintain a list of observers. When an observable object is updated, it invokes the update method of each of the observers to notify that the observers that it has changed its state. The observer interface is implemented by objects that observe observable objects. Might be a little confusing, but you need to read this answer once again. You can pause it and you can read this answer once again so that you can get a brief understanding of this. Followed by that, we have the next question. What is session management in Java? So the answer for this question is a session is essentially defined as the dynamic stage of a random conversation between the client and the server. The essential communication channel includes the string of responses and requests from both sides. Typically, the most popular way of implementing session management is the employment of a session ID in the communicative discourse of the client and the server. The next question is brief about Spring Framework. Spring Framework is basically the framework of frameworks. Now the answer for this question is Spring is essentially defined as the application framework and inversion of control container for Java. Basically, the chief purpose of Spring Framework is to create enterprise applications in Java. Also, it is especially useful to keep in mind that the central features of the Spring Framework are essentially conducive to any Java application. So the next question is, explain JCA in Java. So the answer for this question is, JCA is basically an abbreviation for Java Cryptography Architecture. So JCA provides a platform that gives architecture and APIs for encryption as well as decryption. JCA is used by the developer to combine the application with the security measure. It also helps in performing the third-party security rules. It uses the hash table, encryption message digest, etc. to implement the security. So the next question is, explain JPA in Java. So the answer for this question is, JPA stands as an abbreviation for Java Persistence API. The JPA is enabling us to create the persistence layer for desktop and web applications. JPA deals with the following: Java Persistence API, Query Language, Java Persistence Criteria API, Object Mapping Metadata, etc. So the last question in our list is, explain the different authentications in Java Servlets. So the answer for this question is, authentication options available in servlets are as follows. The first one is basic authentication. So the basic authentication consists of username and password provided by the client to authenticate as the user. The second one is form-based authentication. In this particular type of authentication, the login form is made by the programmer by using HTML. Followed by that, we have the third type of authentication, that is digest authentication. Digest authentication is similar to basic authentication, but in this the passwords are encrypted using hash formula. This makes digest more secured. And lastly, we have the client certificate authentication. The client certificate authentication requires that each client accessing the resource has a certificate that it sends to authenticate itself. This requires SSL protocol.
Now, with that, we have come to an end of this Advanced Java full course. If you have any queries regarding the topics covered in this tutorial, or if you are in the need of the codes executed in this particular tutorial, then please feel free to write us down in the comment section below and we will be happy to resolve all your queries. Until next time, thank you, stay safe and keep learning.